Imagine a world where machines can think, learn, and make decisions just like humans. Picture your computer, smartphone, or even your kitchen appliances, not just following your commands, but actually understanding your needs and preferences. This fascinating realm of technology is what we call artificial intelligence, or AI for short. AI is like giving a brain to all the machines. It's all about making computers and devices smart, hence enabling them to perform tasks that usually require human intelligence. But don't worry, you don't need a degree in computer science to understand AI. In fact, AI is an exciting field that's becoming more and more a part of our daily lives, and it's surprisingly accessible to everyone. Hello everyone, and welcome to this session by Intellipaat. In this session, we learn all about AI. Artificial intelligence is not only transforming industries and technologies, but also creating a wealth of career opportunities for individuals seeking to dive into this exciting field. According to the World Economic Forum, AI is expected to create 12 million new jobs by 2025. This significant increase in job opportunities spans across various sectors, including healthcare, finance, manufacturing, and more. AI specialists such as machine learning engineers and data scientists are in extremely high demand. When talking about compensation benefits, AI professionals command some of the highest salaries in the tech industry. According to Glassdoor, the average salary for a machine learning engineer in the US is around $112,000 per year, and data scientists can earn even more. Now let's take a look at the agenda. We will start with the basics, that is, what is artificial intelligence. Then we will see how to make a career in AI. Moving on, we will have an introduction to neural networks and understand what is a perceptron, as well as multi-layer perceptron. Then we learn how to build neural network from scratch and building neural network with logistic regression. Then we'll see activation functions in ML and best neural network frameworks. After which we'll have an introduction to Tensorflow and Keras. Then comes sequential modeling, CV2 for image processing, as well as understanding network topology and various parameters for building neural network. Next up, we'll learn how to train large image models in batches, as well as we take a look at TensorBoard for large model performance monitoring. Furthermore, we'll see what is transfer learning and how to use VGG and VGG16. Then we have transfer learning versus fine-tuning. As we move towards the end, we will see problems with CNN and understanding RNN and LSTM. And lastly, we'll discuss some important machine learning interview questions. But before we begin, please make sure you subscribe to our YouTube channel and hit the bell icon for regular updates from us.
Artificial intelligence has revolutionized the way people think, learn, and work in various fields from finance to healthcare and mobile apps. What's more interesting is that AI plays more of a role in our daily lives than we can imagine. From Siri and OK Google to various virtual player games and social media apps, AI is everywhere. It sure is the most happening topic in every business right now. It is the most wanted and exciting career domain right now in the market. Artificial intelligence or AI uses intelligent machines that build in a way that they react like humans. The primary process involved in making these smart machines is to carry out decision making, which analyzes and uses data available in an enterprise. It is similar to the human mind absorbing and synthesizing information and providing the required decision. So how does an AI work? AI systems work by investigating large amounts of data labeled training data, analyzing the data for correlations and patterns, and using these patterns to make predictions about future states. In this way, a chatbot that is fed examples of text chats can learn to produce lifelike exchanges with people, or an image recognition tool can learn to identify and describe objects in images by reviewing millions of examples. AI programming focuses on three cognitive skills: learning, reasoning, and self-correction. Learning processes. This aspect of AI programming focuses on acquiring data and creating rules for how to turn the data into actionable information. Reasoning processes. In this aspect of AI programming focuses on choosing the right algorithm to reach a desired outcome. In self-correction processes, AI programming is designed to continually fine-tune algorithms and ensure they provide the most accurate results possible. So there are four types of artificial intelligence. First, we have reactive machines. These AI systems have no memory and are task specific. An example is Deep Blue, the IBM chess program that beat Garry Kasparov in 1990s. Then we have limited memory. These AI systems have memory so that they can use past experiences to inform future decisions. Some of the decision-making functions in self-driving cars are designed this way. Theory of mind is the third thing. It means that the system would have the social intelligence to understand emotions. And finally, we have self-awareness. In this, AI systems have a sense of self which gives them consciousness. Now let's see what are the applications of AI. One of the best known healthcare technologies is IBM Watson. It understands natural language and can respond to questions asked for it. AI can automate grading, giving educators more time. It can assess students and adapt to their needs, helping them to work at their own pace. AI tutors can provide additional support to students, ensuring they stay on track. Banks are successfully employing chatbots to make their customers aware of services and offerings and to handle transactions that don't require human intervention. AI technologies are used in transportation to manage traffic, predict flight delays, and make ocean shipping safer and more efficient.
First of all, we shall go ahead and talk about AI as a career domain. Since the last few years, artificial intelligence has grown in popularity. With the inception of tools like ChatGPT, Bard, generative AI, people are talking so highly about artificial intelligence and things it could do. Not only that, the research for putting AI to use has been going in almost all possible sectors of businesses. It's kind of a trend of recent times. Almost all organizations of different scales are leveraging AI to gain insights from large amounts of data, to automate their processes, to enhance their decision making, and to improve customer experience. As a result, there is high demand for skilled AI professionals who can design, develop, and deploy AI solutions. According to various reports and studies, the job market for AI professionals is projected to experience significant growth in the coming years. For example, a report by Indeed indicated that job posting for AI-related roles have seen a substantial increase over the past few years. India Times has reported that there are almost 45,000 job openings in the domain of artificial intelligence. What that suggests is there is huge potential in this field. So now the question is, how do you approach this journey of becoming an AI expert and secure a high-paying job? Well, let us answer that question to you guys with the help of step-by-step process that will help you reach the goal of yours. First step on our list is understanding the AI landscape. As with any career path, it's crucial to have a solid understanding of the career domain. In this case, the AI domain. To be specific, AI is a huge field which involves multiple subfields such as deep learning, big data analytics, data science, machine learning, computer vision, robotics, natural language processing, etc. There are different jobs available across all of these subfields. So literally speaking, you won't actually be dealing with AI as a whole. Instead, the job that you will get will be related to the subfields that we discuss right now. So read details about these subfields. Evaluate which part of AI interests you the most. Now focus your attention on that one particular subfield. Look into its career prospects, current trends, and the big players in the market. Attend a few online webinars to gain insights into what's new going in the field. By doing so, you'll have a bright idea about the current AI landscape, and ultimately, you'll be better equipped to make informed decisions about your career path. Now that you are equipped with the AI landscape, it's time you start entering into the learning phase. First thing we want you to do is revise mathematical concepts. Remember, most of the AI deals with learning from data to develop intelligent machines. And mathematics, or to be specific, statistics, is the ideology that drives this process of making sense of data. So it is increasingly critical that you cover statistics. If you have completed the first few years of college, you already have learned all of the mathematics required. Yeah, you heard me right. During college, all of us have already learned terms such as normal distribution, mean, median, variance, calculus, linear algebra, etc. You just need to recall all of that and touch upon a few more technical terms down the line. Once you are done with that, you move on to the next learning step, that is picking up Python programming language. Python is the most used programming language in the domain of artificial intelligence. All the subdomains that we talked about earlier have been quite awesomely integrated or rather implemented in Python programming language. Hence, it is critical to learn this programming language. Begin with the fundamentals of Python programming. Familiarize yourself with the syntax, data types, variables, loops, conditional statements, and functions. Try and master the concept of object-oriented programming in Python. Learn how to use classes effectively, and then dive into the rich ecosystem of Python libraries and tools for AI and machine learning. Start with basic libraries such as NumPy, Pandas, Matplotlib. Experiment with data frames, learn the difference between them and arrays. Create different graphs with Matplotlib and gauge how graphs are communicating the data. Consider this as important step because graphs are going to be very helpful when you perform exploratory data analysis. You can also look into the Seaborn library framework. Also, if your interests lie around something like data analysis, business analysis, or business intelligence, you could also try your hands on R programming language. Alright, now the next thing on your path should be learning how to work around data. Data is actually something that fuels the field of artificial intelligence, be it data analytics, data science, machine learning, natural language processing, or computer vision. Everything requires data. You need to have a clear picture of which subdomain you want to go ahead with. However, irrespective of that, it's better to learn how to clean all different types of data available out there and make sense of them. You have already learned NumPy, Pandas, Matplotlib, and Seaborn. Now using those learnings, you can import any dataset into your programming console. Then you can begin with learning different steps of data preprocessing. This process involves removing incorrect or irrelevant data, checking for missing values if they are there, perform row deletion or value imputation. Next, check for data completeness, removing duplicates or producing important values such as mean or averages. Here, you basically take in the raw data and convert it into something that can be fed to the artificial intelligence algorithm. Now the next thing is listening to what data speaks. Once data is cleaned, it's time you use Matplotlib and Seaborn to visualize the data. You can use multiple plots like bar graphs, scatter plots, and pair plots. Graphs will provide you with insights into the relationship between output variable and multiple features in the dataset. And if you are interested in big data analytics, you should go ahead and learn tools such as Apache Hadoop or Spark. These tools can help you churn huge datasets and find insights into how to drive business decisions based on the data. After that, the next phase is quite interest specific. You should pick up upon the subfield that you like and master all the important stuff that is necessary for you to master that particular subfield. Let me cover the overview of all the subfields one by one. First, data science. You'll have to learn many things if you wish to become data scientist. Your learning journey will begin with data exploration, data visualization, and statistical analysis techniques using libraries like Pandas, NumPy, and Matplotlib. Then go to the core topics such as feature engineering, model evaluation, data scraping, deep learning, etc. Next we have machine learning. Machine learning is at the core of AI. Understanding the concept of supervised and unsupervised learning, regression, classification, clustering, and dimensionality reduction is essential. Familiarize yourself with popular machine learning libraries like scikit-learn, Tensorflow and Keras to implement and evaluate machine learning algorithms. Third one is deep learning. Deep learning is a subset of machine learning that focuses on neural networks and has revolutionized the AI industry. You will have to gain expertise in deep learning architectures like convolutional neural networks, recurrent neural networks, and generative adversarial networks. Hands-on experience with deep learning frameworks like TensorFlow, PyTorch, and Keras is crucial for building complex AI models as well. Then we have natural language processing at fourth. NLP is a crucial area of AI that focuses on enabling machines to understand, interpret, and generate human language. Familiarize yourself with NLP techniques such as text classification, sentiment analysis, named entity recognition, and language generation. Gain hands-on experience with popular NLP libraries like NLTK, Spacy, and ZenSim. Next up is big data technology. We already have talked about learning big data. AI applications often require handling large data sets, making knowledge of big data technologies essential. Learn technologies like Apache Hadoop, Apache Spark, and Apache Cassandra to process and analyze massive amounts of data. Familiarize yourself with distributed computing, parallel processing, and data storage techniques to handle big data for AI applications. After that, we also want you guys to learn something out of AI domain, that is cloud computing. Cloud computing has become an integral part of AI development. It is critical that you familiarize yourself with cloud platforms like Amazon Web Services, Microsoft Azure, and Google Cloud, which provide tools and services for building and deploying AI applications. Understand concepts like virtual machines, containers, and serverless computing to leverage cloud computing for AI projects. And finally, we have model deployment as a critical skill. You'll have to learn techniques for deploying models as APIs, containers, or serverless functions. Understand model versioning, monitoring, and management to ensure reliable and scalable deployment of AI models for real-world applications. After you master the subdomain that excite you, it's time you take on a multitude of projects and keep practicing. Remember guys, until and unless you get your hands dirty with real-time problems, you won't actually become good at developing AI solutions. So it is quite important to take on multiple AI projects. You can use Kaggle for that purpose. Kaggle has thousands of AI related projects. You can visit their website and start learning your way up. Besides that, you'll find a competition section there as well. Once you have got enough experience dealing with different types of problems and really have built the confidence, go ahead and participate in a competition. Besides winning prize money, you'll know what kind of work you'll be doing once you get employed. At the end of the day, I want you to upload all of your projects on GitHub. Ultimately, building digital profiles is equally important as building skills is. Besides that, you can also optimize your LinkedIn profile for the certain subfields you have mastered. However, mastering a certain subfield or AI as a domain is not the walk in park. You'll really be required to do hard yards. So we recommend you to go ahead for formal education in the field. You could join any university BTech program that lets you select artificial intelligence as a minor. If you are a graduate or don't have facilitation of going for AI as a minor, then we recommend you to go for proper extensive artificial intelligence certification training. While the internet is full of wonderful and free resources, it won't give you the structured approach or the hands-on practice that you need. If you want to become an employable AI expert, the most effective way to do so is through a specialized program or course. Intellipaat thus provides state-of-the-art certification that are designed according to different sets of industries that artificial intelligence spans across. And it can definitely act as a ladder for your career change with an exciting salary hike. With this program, you could get planned curriculum, wide learning materials, live lectures from IIT Madras faculties, 24/7 expert support, and many more. So go ahead, visit a website and launch your speedy journey of becoming an AI expert. That being said, the next stuff we want you guys to do is build your portfolio. Your portfolio is arguably the most important asset you'll have when it comes to applying for jobs. It showcases how you work and demonstrate to employers that you have not only mastered the right practical skills, but that you know how to apply them in the real world. Focus building LinkedIn, GitHub, formal resume clearly. After done with that, the last phase will be networking, creating job applications, and preparing for interviews. Well guys, by now you have developed the skills, you have built your portfolio. Now you just need to tie it all together and get that job. Mention your projects, technical skills on your resume. Apply for different job openings on different web portals. Be patient. You'll get that interview schedule call. Meanwhile, start preparing for the interviews. Go through different interview preparation questionnaires and also do mock sessions with your friends to gain more confidence. Ultimately, with some time, you'll crack those interviews and land a job in the domain of artificial intelligence.
Framework is a term that is not just related to deep learning. Framework is a term that can be used anywhere, right? A framework is like a Lego skeleton, right? Somebody where you do not have to, let's say, completely write the complete code, right? Rather than you have to, let's say, you already have a set of framework which will do majority of the code for you. You just need to customize it. Now, remember, do you do that error calculation on your own in machine learning? Do you calculate the error on your own? The answer is no, right? Do you write down the linear regression equation on your own in machine learning? Do you write down the decision tree, let's say, the structure on your own? No, you don't. You just simply import a particular library or a framework called sklearn, and sklearn does all the things for you in the background, correct? The same thing is happening, my friend, that a framework in deep learning, we will be using Keras and TensorFlow. And framework is not just related to deep learning or machine learning. It can be anywhere. So let's say if you are building an app in Python, you can have a web framework like Django, Flask, Bottle, right? Do you understand the concept now, my friend? What we are going to do, my friend, that is called as single cell perceptron. Now, to understand this whole thing more into detail, my friends, what we are going to do is we are going to learn about single cell perceptron. Now, most of you might be thinking, what is this perceptron, right? Single cell perceptron. Single cell perceptron means that there is only one neuron, right? What happens if there is only one neuron? Right, only one. This one is going to act as input also, act as hidden also, and act as output also. So right, this will make our life easier in understanding the mathematics that we will go in detail. Do you all understand? Correct? Okay, now what I want is, let's say that we have a data set with us, right? X is the input and Y is the answer for that, or Y is the output for that, correct? And this Y, can I say that this is the Y actual? It means it is the ground truth, correct? This is the ground truth. Let's say that there is a input called X1, for which there is a output called XA that exists. Output called XA that exists. Now in the first phase, remember, in the phase 1 of neural network, my friend, again, I'm saying, please focus, give me just 15 minutes of your life, just 15 minutes, and you'll understand the complete deep learning, right? Okay. So what we're going to do is, my friend, we will, let's say, give a input called X1 over here. We will give an input called X1 over here. Now, for this X1, there will be some output, right? What that output will be, we will calculate that output, right? Now, just like your machine learning, what we do, my friend, we assume that the YP, which is the output of this particular model, which is also called as Y predicted, right? Can I say that this YP will have some relationship with the X? There exists some relationship. That is what we are trying to find out, correct? Now, deep learning says that we will think like how the nervous system of or the neuron system of a human exists, right? In that particular case, my friend, the deep learning framework says that for every input you need to have a weightage to it. You need to have a weightage to it, correct? You need to have a weightage to it. Now this weightage will be called as W1. This weightage will be called as W1. So now what we are saying is that the relationship between the output and the input is this, that we will multiply a weight with the X1.
Let's have a quick quiz question, guys. And the question is, what is the primary goal of artificial intelligence? And your options are replicating human intelligence, automating all human tasks, enhancing computer processing speed, or developing advanced algorithms. Please mention your answers in the comment section below.
We will multiply this weight with the, what's happening? I'll just write down like this. Okay, we'll multiply this W1 weight with the X1 input, right? Now one of my friends says, what is the meaning of weightage? See, obviously, can I say like this, that WP is X1? Can I say that the output of the model is equal to the input of the model? No, right? No, we can't say that. We can't see, this is not going to exist, that output is equal to input, right? Obviously, if both of them are same, but otherwise there has to be a relationship. So what deep learning says that there is a kind of a linear relationship. Please again give me your attention. What I'm saying is that we will have some kind of weightage to it. Now what is the weightage? Weightage is nothing but, let's say, a number being multiplied to input, right? And then the output is over there. Now, obviously, this W can sometimes become 0 also, correct? This W, the nature of this W is that it can be anything in the world, right? This can sometimes become 0 also. Am I right? So this YP might become 0, correct? This YP might become 0. So that is why, my friend, what we do is we add another term. This term is called as weights. This term is called as a weightage. Weightage means but just some kind of, let's say, proportion that we have given, right? Now, because this W can be anything, right? We don't know as of today. We don't know what this thing W is. But so this W can be 0 also. And if W becomes 0, 0 multiplied by X1 is 0. It means we are saying that YP is 0, which may or may not be true. That is why, to avoid this condition, my friend, we add another term called as B, which is called as bias, Again, I'm saying, please give me your attention, right? This is, if you understand this small concept, right? Deep learning is just nothing, correct? So, okay, what are we saying? We are saying that the input X1 has a relationship of YP, and we are assuming that it's some kind of, let's say, relationship where W is multiplied by X1. And because this nature of W1 can be 0, it can be anything, it can be 0. So what is happening is we add a term bias to it so that this YP does not become 0. Correct? YP is representing what? See, that is why I am saying, please pay attention to this thing. Please, right? YP is nothing but the output that the model will give. YP is the Y predicted, correct? Okay, now does this remind you of anything? Does this equation remind you of any other equation?
Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with iHub Divya Samparka, IIT Roorkee and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence, and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
It's a line equation. Those of my mathematical friends, or let's say even machine learning, you all have done. Do you see that this is what is y is equal to mx plus c? This is the straight line equation and it looks like similar to us, where y is the output, x is the input. Instead of m, which is the slope, you have a weightage, and instead of bias, you had a c constant over there, correct? So it means, my friend, deep learning is saying that there exists a linear relationship between input and output. Do you understand till now? Correct? Do you all remember the straight line equation, right? Straight line equation is like this. This line is called as y is equal to mx plus c only when mx plus c, only when the distance on the y-axis from 0 is c, and the angle over here, if you take a tan theta of this thing, that is equal to the slope m over here. Do you all understand? Do you all understand the straight line, my friends? Those of you who did, very good. Those of you who don't, this is what a straight line equation is. Now see, if you move this line up, what is going to happen? It comes over here. The slope remains unchanged, but the constant term has been increased over there, correct? And this theta still remains the same. Do you all know this concept that two lines which are parallel to each other, their slope is always the same? Very good, very good. This was the concept of straight line. Why does deep learning think that linear relationship is, let's say, there is always a linear relationship over there, right? Why does deep learning think that there has to be a linear relationship over here? And that is a very good question. That yes, almost 90% of the time, there will never be a linear relationship between the input and output, correct? And you yourself saw this in machine learning, correct? That hardly there were problems in which you were using linear models, correct? Majority of the time you had to use a random forest or a gradient boosting model, correct? Very, very good. Now let me tell you the answer over here. Yes, that not every solution is linearly doable. That's a very good point that you guys have made. But linear is the most, how do I say? It's the most interpretable model in the world. Can I say this thing? Can I say this statement? That linear models are the most interpretable models. You can interpret them very easily, correct? So from a human perspective, to explain this particular model, that what it is doing, why it is doing, how it is doing, linear makes sense, correct? But obviously, all the models, all the problems in the world can't be solved through linearly. Very good, right? That's a very good point. Now, give me a second. I'm going to pull up an image in front of you. Okay, this is one type of data. And the another type of data is this. This is a 2D plane, and you have two concentric circles over here made up of blue cross and red circles. Your question is, divide this data linearly. Same question that you guys are asking me, right? I am asking you the same question. Can you divide this data linearly? The linear solution, can we generate a linear solution to this particular, let's say, data which is like this? When you see it like this, the answer is no. But listen to me, right? But what you can do, my friends, you can take your input data, and if you introduce another dimension over here, it means that if you see it from now, currently you are seeing the top view of this thing. Currently, this is the top view of this thing. What happens if I introduce another layer over here, another dimension in data? Now you know what is going to happen. It is going to look like somewhat like this. That this is your red layer, and this is your blue crosses below, like this. And now I can draw a hyperplane which is linear in nature and can cut this data into two halves. Okay, can you all see this image, right? You can see the red dots and the blue circles over there, correct? This is the data. And then for this particular data that you're looking at, this, let's say, can't be generated. But what if I say you that in the same data, rather than doing a PCNA and decreasing the, let's say, decreasing the dimension of this particular data, what if you can increase the dimension? What if you increase the dimension? Listen to me. Till today in machine learning, what you have done is you have decreased the dimension of the data so that it can be understandable by a human, correct? You did PCNA, my friends, because you had huge amount of features and you wanted to condense the features, correct? PCNA, TSNE, you have done multiple dimensional reductionality problems. But in deep learning, what we are saying is that because we will not be handling the feature engineering, because humans do not have to handle the feature engineering. That is why we can have a liberty of more features, right? And when more features come in, when more dimension comes into picture, your data gives you more clarity and helps you to create a linear solution. Do you understand now? The point that I'm trying to explain over here is, my friends, that when you add dimensionality in the data becomes much more explainable, right? You can divide the data linearly now. Do you understand the concept that I'm saying over here? The concept is that when you introduce a third dimension, or let's say when you introduce one more dimension into the data becomes much more clearer. It is just like investigating, right? I mean, most of you have read that those detective, what is that detective movie or the book? I forgot. So what happens in those, right? The detective tries to go inside the scene scenario. They try to find more things, right? Same thing is happening over here. If you want to segregate that data, right? Sherlock Holmes. Thank you. Sherlock Holmes. Yes. So when you try to, let's say, investigate the data also, my friends, right? When I give you more and more dimensionality, right? The data becomes much more clearer to you. Now, you guys never did this thing in machine learning. Why? Because there you as a human, as a data scientist, had to deal with features, right? And a data scientist or a human has a limit to how many features they can digest. Do you all remember our conversation that we did, that why deep learning over machine learning? Do you remember that in machine learning, we have to extract the features and provide it to the model? Whereas in deep learning, the deep learning will figure out those features. The deep learning will figure out those ROIs, region of interest, and will do categorization also. In machine learning, there are two phases. In phase one, you do feature extraction and then the model does the categorization. Whereas in deep learning, my friend, both the things will be done by the model itself. First of all, figuring out the features and then doing the categorization. Correct? I know there are 10,000 questions in your mind, but till here, do you understand the main concept? Forget about deep learning right now. That if you introduce a dimension in the data, it means if you introduce more features into the data becomes much more explainable. The data becomes much more explainable, and it becomes much more explainable in such a way that you can even now divide the data into a linear way. All of you understand this thing, right? That even a hyperplane is linear in nature. But think from this perspective, what is dimension? What is features? What was feature for you in machine learning? Tell me this thing. What is feature for you in one more column? In machine learning, for you, one more column was a feature. Similarly, here also, figuring out in images. And when we'll talk about images, I think then it will be much more clearer to you. Figuring out more features in the data is also called as the dimensions. See, my friend, if I give you this equation, and again, let me clear this thing to you. If let's say this is the equation, x1 m1 plus x2 m2 plus c. What is this thing? How many features are there? Two features, correct? X1 and x2 are two features. Based on that, you have to calculate what is the y output. Similarly, in machine learning, you could add, let's say, more let's say, features over here. But in machine learning, you condensed the features, right? You always try to reduce the dimensions. That's why you use something called as PCNA, right? PCA and TSNE. But here we will use a technique where we expand this dimension. Okay, now let's come back. Let's come back that we talked about. Let's say, okay, all of us, we now understood that, okay, if you introduce the dimensionality, if you introduce one more dimension or let's say more feature in the data will become much more explainable to us, right? And this is coming at a cost that we can now, this newer data that will come in will be linearly separable. Two things that I have told you over here, correct? Do you all agree? One thing is that if we increase the dimension, the data will become much more explainable. And the second thing is it will be so much explainable that we can have now a linear equation, right? The solution can be linear. So what I am going to say now, please listen to me. What not I am saying, but let's say deep learning says. Deep learning says that, thank you, friends. You had a very good suggestion over here that all the solutions can't be linear. So that is why we will now, what we will do over here is we will apply something called as a activation function. What we will now do is we will say yp is equal to some kind of activation function, ACT, activation function, and then we will put our w1 x1 plus b. Now this activation function's job, my friend, it's a dual sided sword. It will do 2-3 things for you. First of all, it will increase the dimensionality. The first thing it will do is increase the dimensionality, right? And the second thing is that all of you have also faced in machine learning. Okay, tell me, my friends, let's say if you have 2 columns, or let's say even there is only 1 column, but the 1 column has a very broad, let's say, histogram. I mean, the values are in the range of 0 till, let's say, 10,000. What do you generally do? There is a numerical column, there is a continuous column, and the range, let's say it's salary. Let's say it is the salary of the people, and the salary of people is in the range, let's say poor people like me, we have very less salary, and rich people like you also there who have very high salaries, right? So the data is, let's say, very broad, correct? So what will you do? Can someone tell me, why do you normalize that data? Why can't you take, let's say, my salary, which is some $100, and your salary, which is $1 million? Why can't you take that data? That machine learning will become skewed data now. What is going to happen? The machine learning will now not be able to understand this broad range of data. That is why, what do you guys do? You normalize that data. Remember, you use different kinds of techniques like min-max scaler, standard scaler, right? And you bring that data into a fixed range, either 0 to 1 or -1 to 1. Do you remember? Do you all remember those concepts, right? Similarly, here also the same thing will be done by activation functions also. What are activation functions? We will talk about them a little later, but this is what activation function will do, my friends. Activation function will take your data, introduce the dimensionality from a geometrical perspective, and from a mathematical perspective, it will normalize this data also, x1, w1, x1 plus b, because this x2 might be of a different range, right? This x3, another data might be of different range. So it will normalize this complete thing and send it to us. Do you understand now? Tell me if you have a list over here, let's say data is equal to, let's say column 1, let's say it contains 5, 10, 15, 20, and 25. Let's say these are the data points. What is normalization? See, my friend, what is going to happen? See, please listen to me, right? What is going to happen? This data, right? What is going to happen? This data will be problematic for machine learning, right? Why machine learning? Because machine learning might think that 25 is very big, then 20 is small. Then what is 5? 5 is like very minimum, right? This range becomes super high for machine learning to understand anything over here. That is why there exists a technique called as normalization, right? Normalization. Now there are different types of normalization that you might have learned. One is called as min-max scaler, right? And the other one is called as standard scaler. Now what is min-max scaler? Min-max scaler says that you take the number x, you minus it with x minimum, and then divide by x max minus x minimum, right? This is called as min-max scaler. I'll just cut this thing, paste it over here. And what is standard scaler? Standard scaler is x minus x mean divided by x of standard deviation, correct? Remember? Okay, so what? Let's do this min-max scaler. Just for your clarity, we'll do x minimum is 5, x max is 25. Okay, so can I say that the denominator is always going to be the denominator x max minus x min is always going to be 20? Can you say this thing? Very good. Now let's take one by one the numbers. The first number is 5. Now 5 minus 5 is what? 0. So can I say that the first number is going to be 0? Correct. Second number, let's come to second number. 10 minus x min. What is 10 minus x min? 10 minus 5 is 5. 5 divided by 20 is, right? Next number, 15. 15 minus x min, which is 10. 10 divided by 20. What is the next? Similarly, next is going to be 15 divided by 20. And the next one is going to be 20 divided by 20. Do you notice now what has happened? Your data has now converted in the range of 0, 1. Do you see this logic over here? See, my friends, the whole concept of machine learning relies on the ratio of the numbers, right? The ratio between this number 5 and 10 is still intact. The ratio between this 10 and 15 is still intact. The ratio between 15 and 20 is still intact. 15:25 is still intact. The ratio is still the same, right? We might have changed the number, but this is going to help our machine learning to reduce the broadness, right? Okay, so let's now do this thing. Okay, what's the first thing? 5 minus the mean, which is what? Minus 10. Minus 10 divided by 7. What is next? Correct. And this is what? 0. This is what? 5 by 7. And this is what? 10 by 7. Correct. Now this will give you in the range of minus something to positive something, right? These are called as, my friends, normalization schemes. Okay, so let's now come back, and now what we are saying is that the same normalization will be done by our activation function also. Correct. Our activation functions will also do the same thing, right? I'll repeat this whole thing one more time so that we can revise this thing, and then if you have any questions, please ask, right? Okay, so what we are saying that in the very first thing, my friend, there is an input called x1, right? There is an input called x1, and this x1 input, one second, this x1 input goes inside this neural network, and neural network says that I will perform something called as a affine equation. I will perform something called as affine equation, and affine is nothing but it says that, see, I don't know anything about this, what has come to me. So I will assume a linear relationship. I will multiply it with a weight and add a bias to it, right? Now, because all the relationship can't be linear, so that's why we take a help of an activation function. This activation function will introduce, let's say, non-linearity and also add a dimension to the data, right? A dimension to the data, and this adding of dimension will make sure that we have more features, we have more let's say things to classify our data, right? And from a geometrical perspective, it is increasing the dimension, but from a mathematical perspective, it is also normalizing our data. Correct? Do you all understand over here? My question to you is, what is this weight and bias? I mean, see, this input I understand, output I understand. Why? Because they are coming from the data. But what is this weight and bias? What is this red weight and this blue bias? I don't understand this thing. Where will we get these things? So most of you are saying the same thing, my friend. Understand, the very first time, for the very first time, even the model does not know what is the input, what is the output. So it says that we will take it random. Please understand this thing. I am again repeating this statement. Because for the very first time, the model also does not know anything. It does not know what is input, what is output, what is all these things. So the point is, the model will take random values of weights and biases. What will it do? Random weights and random biases. Correct? Okay. Most of you are saying the same thing. There's a very big thing in the chat. Let me read it. Since all the variables do not influence the output equally, each of the variable is given a specific weight of the importance so that they contribute to the output. But do you know this weightage? Do you as a data scientist know this weightage, that the weightage of input is to output? The answer is no. Does your framework know this thing? Does your framework TensorFlow, does your framework PyTorch, do they know this relationship? Every data is different, every feature is different. Do they know this thing? No. So where is this number coming from? I guess no, it's actually no. So do you all understand, my friends, that this weight and bias is random over here? This weight and bias is random over here. And now I know most of you are thinking, Shivam, what is this? What is this deep learning? First of all, you are saying it's a linear relationship, then you are saying it is random. Do you think, my friend, do you think that with this random weight and random bias, will it ever be able to capture the correct answer? Will this YP will ever be equal to YA? The answer is no. Very good, right? Because we have taken random weights and random biases. How can they produce the correct answer? Correct? Maybe one of my friends is showing the optimism. Very good. The answer is no. For the very first time, it will not digest this thing, right? Obviously, because you have taken a random weight, random bias, you're multiplying them and you're adding them over here, right? And then you're adding an activation function. It will never produce a correct answer. Does this align with all of us? All of us agree to this thing, right? That never, not even in a million times it can happen that YP can be equal to YA, correct? Okay. So then the point is, what next then, right? Give me 1 second. I'll just take a snapshot of this particular thing and then we'll move to the next thing. So till over here, what we are saying that there is a YP and this YP is equal to what? This YP is equal to some activation function that you have said, and then there is some random weight and a random bias over here, correct? A random bias, correct? All of us understand that this is activation, this weight is random, this bias is random. X1 we already know, this is the input. YP is the predicted, the prediction that the model is giving to us, correct? Please don't get confused. And this is the table. This is the table, the data set that is given to us, that for every X1 there is a correct output called as YA. Correct? There's the output called as YA. This is the correct output, right? Okay, so because we have taken random weights, random biases, this YP is never going to be close to Y. This YP is never going to be even close enough to YA, right? All of us agree to this thing. This is where, my friends, the learning feedback loop starts in deep learning. See, deep learning is not a hard-coded concept where you try to find the patterns in data using your machine learning algorithms. In deep learning, we actually have no knowledge and we try to learn from ground zero, right? The machine learns from ground zero about everything. So this is where the feedback loop starts now. So in this is where the phase 2 starts now. The phase 2 starts now. In phase 2, my friend, we will calculate something called as error. What was error for you guys in machine learning? Can I say that here also we will have YA minus YP? Can I say this thing? Correct? Now, instead of YP, my friend, can I say YA minus W1 X1 and minus B1? Can I say this thing? I've just taken this YP from here and then written it over here, correct? Now, please see these terms. How many terms are there? YA, W1, X1, this is X1, and this is B1. There are 4 terms over here. Let me write down this X1 again so that you don't confuse it with, correct? There are 4 terms. Now, if I ask you a very simple question, one of my friends is saying why this B1 is not minus, my friend, because there was a minus YP, right? So minus and plus is a minus thing, right? Okay, coming back. If I ask you a very simple question, listen to my question and then please try to answer. My question is, if this error is coming over here, who do you think is responsible for this error out of these 4 terms? Out of these 4 terms, YA, W1, X1, and B1. What do you think? The weights and biases are responsible. Why? See, because X1 and YA, my friend, these are given in the data sets, so they can't be wrong, right? They are the universal truth. X1 and YA is coming from the training data, so these 2 terms can't be wrong. So the terms that are responsible for this error is this random weight and random bias, correct? So what we have done is now, my friends, we have understood that error, if error is coming, right, who is responsible for this error? Weights and biases, right? These random weights and biases. Okay, very good. So what will we do now over here, my friends? We will try to draw a graph of error and weight. So the error and weights are two different things, but I will, let's say, try to solve only for one, and for other also we'll see. Okay, so let's say, my friend, this is the weight on the x-axis, and on the y-axis we have the error called E. Please see over here, please, right? Let's say this is the kind of graph. This is called A point, this is called B point, and this is called C point. I'm going to ask you a simple question. You will answer this to me. First of all, let me explain what this graph is. This graph is that I've plotted is against the error and the W. It means for different values of W's, I have drawn that where what is the error, right? For different values of W. So here is this. Here, actually, let me make dotted lines. For this particular error, for this particular weight, this is the error. For this particular weight, this is the error, and for this particular error, this is the weight, right? And let me write down the value. This is W1, this is W2, and this is W3. Do you all understand the graph? Very simple graph, that for different values of W, because W is a random number. So what we are doing, we are changing this W, and the corresponding error we are trying to plot over there, correct? My question is a very simple question. My question is, if I have to pick up any three of the W, W1, W2, and W3, which one should I pick? Very good. This is what I want. But okay, let me repeat my question and let me ask it again. If I have to pick up the most optimized W, W1, W2, or W3, which one will I pick? Because for W2, the corresponding error is minimum. Correct? The corresponding error is minimum. Do you all agree with this statement? That W2 is giving you the minimum error over here. See, W3 is coming over here, and W1 is coming over here. So you will choose what is the motto of your life. What is the motto of your life for this particular deep learning? Your motto of your life is to reduce the error, right? To minimize the error. Correct? Now, so you will choose everything which lowers the error. Correct? So now what we have done is, my friend, we have understood now that we will pick that particular weight for which the error is 0. Similarly, can I do the same exercise for base also? For different values of base, we can plot the error. Correct? And then we will pick up that which base to pick up. Correct? Bias to pick up. Sorry, not base, bias to pick up. Correct? Now see over here. This is only a single cell perceptron. This is only a single cell perceptron. We are going to work with these kinds of models. I am going to show you over here. This is the kind of model that we will have. This one. This particular, my friend, model contains some 14 million weights and biases. Do you think we can sit down and we can draw the graph for each weight and then corresponding error, and then we can handpick the W? Correct? We'll do this. We're free only. Anyways, we are free only. We'll just plot. We'll take paper. We'll take printout of all these things. 14 million weights and biases, and we'll sit down and do all these things. No, not possible. Very good. Right? So who is going to help us? Who is going to help us? Neural networks? This neural network is what you're designing. No, not Python, not deep learning. We'll do it in next life. Very good. Fantastic people. So, okay, who is going to help us here is maths. Maths is going to help us, right? All my friends who are a little scared of mathematics, do not worry, because even those of you who know mathematics, who have done mathematics, might forget this kind of concept. I'll tell you what this concept is. This concept is called as calculus, and in calculus there is a concept called as differentiation. Now, a differentiation of a particular graph, right? What is differentiation? The differentiation says that for a particular graph, I can calculate the slope. So let's say if this is the kind of a graph, it can calculate the slope like this, right? That what is the slope at this particular angle, what is the slope at this particular point, and what is the slope at this particular point, right? So what we will do is we will differentiate our error with respect to W. Now, what is going to happen if we differentiate this with respect to W? See, I'll explain it to you, right? Again, those of you who know mathematics, it is fine. Those of you who don't know, please do not worry. Listen to me, right? Just listen to me. Let's take that because we have taken random weights, we are over here. This point called as W1. Do you want to stay at this point, W1? Do you have to stay at this point, W1? No, right? You have to come to this point called W9 eventually. Correct? Right? That's the funda in your life. That's the motto. Only one motto in your life. That somehow I have to go to the most optimized weight, and the most optimized weight is W9. Correct? So what we have to do? We have to we have to traverse from this W1 and we have to slowly move towards W9. Correct? Am I right? Forget about mathematics for just 2 seconds. What we have to do is in life, we have to slowly move from W1 to W9. Now, who is going to help us to move this thing? This is where we will come, and the concept of dE by dW comes. Okay. Now, what we are saying is, my friend, we are saying that we want to move from W1 to W9. Correct? W1 to W9. So what is going to happen? We will say that, hey, listen, W. We will take derivative. We will take derivative of this particular dE with respect to W. Now, what is going to happen? What does this dE by dW tells you? This dE by dW takes a small step in the direction of W9. This dE by dW is this particular step, the small step. So what we are saying? We are saying that, hey, W1, right? Please do a minus of dE by dW in yourself. Please listen to me. This is a little bit important concept, right? We have to move. I'll repeat again. We have to move from W1 to W9. Do you all agree? Right? Because W9 is giving us the lowest error. So we have to move from W1 to W9. So now who is going to help us to take these small steps? This is where differentiation comes in, right? Partial derivative or differentiation comes as dE by dW is nothing but this small step that you can take towards W9. So what we are saying is, we are saying that W1, you should change yourself. W1, which is a random weight, you should change yourself in such a way that you have to move towards W9. So we are saying W1 minus dE by dW, and this is going to take you to W2. Right? Now we will again do this thing. Now we will again take a dE by dW2 now, and it will again take one step, and we will reach to W3. Right? Similarly, we'll do one more time. We will reach W4, W5, W6, W7, and at one point we will reach to W8. Now we will again take a derivative of WE by W8 and we will move over to W9. Correct? Now, when you will do it again, dE by dW9, this is going to be almost zero. This is going to be almost zero. Why zero? Because a differentiation taken at this particular point is going to be almost like a straight line, parallel line to x-axis, and the tan of that thing is zero. So dE by dW9 is almost going to be zero. So what is happening? W9 minus dE by dW9. And if dE by dW9 is equal to 0, it means W9 is not changing anymore. Correct? It means it will stick over here. This is when we will say that, okay, we will stop. Now, most of you are thinking you guys are doing a mathematics, right? You guys are saying, hey, Shivam, W9 is greater than W1, right? Mathematically, W9 is greater than W1. So how can it happen that you are subtracting something from W1 and how can it increase, right? So the answer to this question is, my friend, that dE by dW itself is negative over here. right? It is itself negative over here. So negative becomes positive. And that is why W1 adds up and become W2, then adds up to become W3. And if it goes towards this side, then it becomes positive. Then dE by dW is positive. So do not worry. The slope is very smart. The slope takes its position, positive, negative accordingly. And that is why this particular thing is, arranged in such a manner. Do you understand now? Do you understand now? Do you understand the concept now? I know the mathematics part. We will do the mathematics and the practical part later on. See, W9 is just a number over here. You might want to go to 100, 200 also. Yes. But then also I have a trick over here, that how can we fast this process? W1 to W9 are arranged in an order to always have largest to smaller errors. Yes. So dE by dW is forcing you to go towards there. Correct. Again, my friends, see, W9 is just a number. This can be W10, this can be W3 also, this can be W300 also. Please don't pick up that number. You understand the concept, right? Don't pick up the numbers. Understand the concept that what we are doing is over here, that somebody gave us random weights and random biases. We found out the culprit, and to figure out the culprit, we drew the graph, and based on the graph, we are going to that optimized weight. And this optimized weight is going to make sure that we have the minimum error. What is the point? The point is over here. We had this particular sheet over here, and we said that, hey, listen, we have an input called X1, and for that corresponding input, we have an actual output called YA, right? And we said that we are going to use something called as neural networks, and we will use a single cell perceptron, right? We said that, okay, X1 will go in, and the deep learning algorithm said that, see, I don't know anything about the input and the output. So what I am saying is, I am saying that the output is equal to the linear relationship between the input. So it says that YP, which is the Y predicted, which the model is predicting, is equal to W1 X1, where W is an arbitrary number called W1 as the weight. And then you add a bias term to it. Why bias term? Just to make sure that this term collectively, if this becomes 0, there should be another number to make it non-zero also. It does this thing. Now, obviously, a linear solution cannot be the solution for all the problems. All the problems are not linearly separable. We saw this using this example on the top, right? That a linear solution was not possible if you use this kind of problem, right? You had to increase the dimension, and now it is linearly separable. So we said the same thing. Deep learning network said that, okay, if you want something which will increase the dimension, so use something called as activation functions. What are these activation functions? We'll talk about them a little bit in detail, right, a little later. But there is one function which will make sure that this is now non-linear. It has now increased the dimensionality and also normalizes the data. Now, obviously, we have done all these things now, but again, at the end of the day, we are using two random things to figure out the answer. So obviously, the correct answer is not, so the produced output is not going to be correct. So that's why we said that, okay, we will calculate the error. We will calculate the error, and error is nothing but YA minus YP. Correct? Simple error, YA minus YP. And can I say, instead of YP, can I say that is equal to W1 X1 minus B1? Same, I just wrote down the same equation over here. And now out of these 4 terms, I asked you a very simple question, that whom do you think is the culprit? Is the culprit this YA? Is the culprit is this X1? Is the culprit W1 and B1? And all of you collectively said that the culprit is W1 and B1. Why? Because YA and X1, these are the 2 terms coming from the data set. They can't be wrong. So the wrong or the culprit is W1, B1, because these are the 2 random terms. So we said, okay, fantastic. So we have now found the culprit. Now what we're going to do is, what is our job? Our job is ultimately to make this YA almost equivalent to YP. Correct? Almost equivalent to YP. Now, if YA becomes YP, the error will become 0. So ultimately, we have to figure out a place where error becomes 0. So what we said that, okay, we will now plot a error between E and W. E is the error and W is that particular weight. And what we will do, we will try to do this thing. We will try to, let's say, we will try to make different values of W. For different values of W, we will calculate the error, and we will choose that error where the error is, we will choose that weight where the error is minimum, correct? Out of the W1, W2 and W3, we will choose W2. Why? Because it is giving us the minimum error. So we should replace W1 with W2, correct? Do you all agree? Now, obviously, this is just one weight, right? We will have tens and thousands of millions of weights like these and biases like this. Will we manually plot a graph and will we manually, let's say, analyze this kind of pattern? The answer is probably no. We can't sit down and we can't do this thing. So we take the help from mathematics. Mathematics says that I will do this for you. Do not worry. There is something called as partial derivative or differentiation that is going to help us. If let's say you, because of the random nature of the W, let's say if you are here at W1, right? And let's say this is the point called as W9, just a point called as W9. So eventually you need to go from W1 to W9. Now over here, we can see the graph and we can say that we should to choose W9. But do you really think that we will plot these graphs and we will figure out these points? The answer is probably no, we can't, right? So we want somebody to hand hold us, hold our hand and take us to that point, correct? We want some kind of a guidance from somebody who can take us to this point. And who provides this guidance? His name is dE by dW, right? dE by dW is a mathematical term for differentiating the error with respect to the weight, right? Or you can say a delta step towards the minimum error. So what is going to happen? We will slowly, now what is going to happen? This dE by dW is going to slowly give us these steps, and we will follow those steps, and we will say that old weight minus this dE by dW and gives us the new weight. So we will reach to W2. Again, we will perform this exercise. We will reach W3. Again, we'll perform W4. We will perform till this, until and unless dE by dW becomes 0 and no more progress can be done, right? We will move until that particular point where dE by dW says that no more change in weight is required. When dE by dW becomes 0, it means no more change in weight is required, right? And we might need to go down. This particular exercise that you see over here, my friend, this particular exercise that you saw over here, this thing is called as the phase 3 of deep learning. And this is also called as backpropagation. Backpropagation. Now in backpropagation, what is happening? We are going back into the equation and we are saying that, hey, listen. The culprit is weight. Please change your weight, right? The culprit is weight. Please change your weight. Give me 1 second. I'll just take a snapshot and then we can proceed further. So, okay. What we did, I'll just repeat again. In phase 1, we said that y is equal to W1 x1 plus bias, right? In phase 2, what we did that, hey, listen, these are two stupid numbers that you have taken. They will never give you the correct answer. So please calculate the error. And error was what? Error was WA minus WP. And if I can write it down, it is nothing but I say W, I should always say Y. YA minus W1 X1 minus B1, right? And we found that the culprit are these two numbers. In phase 3, what we are saying, we are saying that, hey, listen, the error that you are using, the weight that you are using, the term weight that you are using is actually wrong. And you should change your weight, and your new weight should be weight is equal to weight minus dE by dW. It means take your old weight, whatever is the old weight, and update it by this thing. And similarly, update your bias also. Your bias is also wrong over here. So new by old bias minus dE by dB. dE by dB. This becomes your new bias. And we will again start this and we will go to the phase one. Phase one will again say that, okay, new Y predicted is this updated weight called weight 2 X1 plus bias B2 over here. Again, this error will be calculated. Again, for this error, there will be gradient descent or backpropagation, which will happen. Again, we will go phase one, phase two, phase three. We will keep on running this cycle until and unless either the error stops decreasing or it becomes almost zero. Generally, it does not become zero, but it becomes almost stagnant. First of all, fundamentally, forget about mathematics. Is the concept clear to you that how we don't know anything which was totally, let's say, random over here? We just came up, and deep learning is using something called as learning feedback loop, my friends, right? This is how animals learn. This is how human kids learn, right? This is called as learning feedback. We do things, we do the error, and then we do them again, right? We calculate the error, we figure out the culprit, we correct the mistakes, and then we again do this thing, right? Learning while doing things. This is how based is deep learning. The loop will continue until either a condition where the error becomes zero, which is highly not going to happen, and B, where the error stops changing now, right? Your error becomes almost stagnant, right? Error, no change, correct? If YP is inaccurate, how do we calculate error? YA is the correct answer, and we know this thing, correct? YP is something that the model is calculating based on the limited knowledge. The model is calculating this thing, correct? Obviously, this YP is not going to be correct because you have taken random weights and random biases. That's what we are doing. I deconstructed this YP into W1 X1 minus B1, correct? And that is what phase 3 is doing. Phase 3 is now making sure. Phase 3 is now making sure that we are optimizing those random weights in such a way that error becomes zero. You understand now? What is Y train? Can I say Y train is nothing but the correct answer to that X train or the actual output? Correct, right? So in machine learning, you have those things. Similarly, in deep learning also, and I think you forgot, I said the same thing over here in this image also. You can see over here that when the data set is given to you, for every X1, you already know the original answer YA. Is this confusing now also? No? Fantastic. Fantastic. So again, see, I don't want to go into mathematical details, but this is what exactly approximation is doing over here. When you say your dE by dW, right? And again, right now, this is very simple thing, right? Because we are doing just a single cell perceptron. When we will do the same thing for a big network, my friend, you will see that we have to apply a chain reaction to get weights dependent on other weights, right? So don't worry. Again, I don't want to confuse you right now. That is why I have taken only a single cell perceptron. We always start with single cell perceptron, and then we keep on adding layers, and then we'll reconstruct this. See, listen, my friend. Do not go behind this numbering, right? That you are here. Let's say you are here. And this point is called as A. This point is called as B. And this point is called as, let's say, C. This point is called as C. I have a very simple question for you. What is your ideal weight? Where do you want to go? You want to go at position A, position B, or position C? You said position B. Okay. So now you have to travel from A to B, correct? Currently, you can see the graph. Currently, you can see the graph. But imagine where you can't see the graph. So you need a guidance, correct? You need somebody to hold your hand and then move you over there. Yes? Forget about this term W9. Please do not confuse yourself with this W9. Forget about this thing. Just imagine that you are, because of the random nature of weights, you are at a non-appropriate position, right? Non-optimized position. And you need to move to the optimized position. And the only way to do that thing is dE by dW. Now you will repeat this chain of, let's say, things over here, as you can see, right? As you can see in this picture also, you will repeat this thing, phase 1, phase 2, phase 3, phase 1, phase 2, phase 3, phase 1, phase 2, phase 3, until and unless you reach to the optimized weights, And what is the optimized weight? What is optimized weight? Optimized weight is nothing but which gives you error almost equal to 0. Normalization actually helps the machine learning to narrow down the scope, right? I'll take the same example, the salary. Let's say salary is one of the columns, right? Now salary can be as low as mine's, right? $100, and it can be as large as yours, which is 1 million every day, right? Now this band is very high for machine learning to consume. That is why what we want it to bring into a standard range, right? And generally that standard range is either 0 to 1. Sometimes it is -1 to 1, right? Different range are here. And we also have different activation functions, which will help you to normalize your data. So generally, my friend, in deep learning, we will talk about images, and in images, we will talk about our categorization problems only, right? But in y hat, again, don't get confused. One of my friends said how y hat term. Y hat is nothing but y actual. And in other literatures, it is also called as y hat, like this. Don't confuse. Understood? We have something called as one hot encoding, where you can encode your categories. Don't worry, we have that. You thought that we are going to do yes minus 0.9, yes minus 0.8, yes minus 6.75. No, that's not going to happen. We have one hot encoding over here also. We'll talk about activation functions. We talked about all these, fancy functions which would come up over here, and which will be a savior for us. We'll introduce dimensionality. Will, let's say, normalize our data also, right? Do you remember those? I talked about some kind of a lightsaber kind of a thing which was going to help us. It's actually over there. If we go to activation function Wikipedia, which is the best place to read about this thing, and if I show you, these are the different activation functions over here. Again, don't get overwhelmed by this particular page. I will explain you each and everything, but these are the functions. YP means Y predicted. It means what the model is saying. What is your model saying? And YA is what? That is Y actual, which is what data is saying, or what the ground truth is. Now it is clear, my friend? In machine learning, do you remember that you had X train and Y train? Now, what was Y train? What was Y train? Training out. Not training output, my friend. The original answer, the correct answer, not the training output. This thing, Y train was actually the original answer which the data is giving you, correct? It comes in data set. Neither you are producing, neither I am producing. This is coming from the data set. This is the correct answer. And what happened when you said model.fit? What would it produce? Sorry, model.predict. When you run model.predict, my friend, what is the output of this thing? What would you call this thing? You would call this YP. Okay, other, what would you call this? Some people call it Y hat. What else? Predicted output. That is what exactly it is, right? So we said that these functions are those magical functions which will convert our W1 X1 plus B into, introduce one more dimensionality, will do all those things. So the very first activation function, which we will very rarely use, is the identity function. Identity function means that whatever is coming will go out as it is. Nothing is going to change. Nothing is going to change. If something is X, it will return X. If something is 5, it will return 5 only. So this is of no use for us, right? This is called as identity activation function. It means it returns as it is. So this is not any use for us. Binary is also not useful for us, right? This is not useful for us. Binary is also not useful for us. The first activation function that you will be using is called as sigmoid. sigmoid function, or also called as 1 divided by 1 plus e to the power minus x. This particular function, my friend, it actually makes a graph like this. Let me change the page. It actually runs like this. There is the pen. Here it is. Somewhat like this. And this particular thing, it saturates over here. Right? This thing is 1, positive 1, and this thing is 0. And the formula is 1 divided by 1 plus e to the power minus x. It means you can give anything in the world, any number from minus infinite to positive infinite, any natural whole number, right? Any number. And if you pass it through this formula, my friend, it has to become like this. It has to come like this. So if it is a negative number, let's say you're giving a negative number, it will always return the value from 0.5 or less. And if you're giving a positive value, it will return you 0.5 or above 1. Correct? This is called as sigmoid function. Now you might have noticed two things. Is this graph linear in nature? By any angle, do you think that this graph is linear in nature? Is 1 divided by 1 plus e to the power minus x? No, it's a non-linear function. So if I wrap a linear function inside a non-linear function, it becomes non-linear in nature. Also, can I say that it has bounded the data in the range of 0 till 1? Say yes or no. Correct? Is it doing both the things for you? Right? First of all, it is bounding the range, and it is also introducing non-linearity in the data. Correct? Very good. Then we have, my friend, our second activation function, whose name is tan h. His name is tan h. It is e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. Don't worry if you don't remember the formula. The graph is almost the same as earlier, but is going to return the negative value also. Like this. This is positive 1. This is minus 1. It means if you enter any value negative, right, it is going to return you values from minus infinite till 0. And if, sorry, minus 1 to 0. And if you're passing any positive integer, it is going to go from 0 till 1. So it means it has bounded your answer in the range of minus 1 to 1. Correct? So this is the second most used function, right? First is sigmoid, second is tan h. Now, obviously, you might be thinking which one to use, when to use, right? Don't worry, I'll explain. The last one is ReLU, rectified linear unit. Now, it says that I will return all the negative number as it is. Again, please be cautious over here. I will return all the numbers as it is, and if it is a positive number, sorry, if it is a negative number, I will make them 0. And if it is a positive number, I will return them as it is, like this. So if you ask me the function, this is somewhat like this, that if x is less than equal to 0, then it will return you 0. And if x is greater than 0, then it will return the number x as it is. You see, there were two things that the activation function was doing. One was that it was binding the output into a specific range, whereas I don't see a specific range, right? I mean, this ReLU can go from 0 till positive infinite. It can go in any range, right? There's no range over here. Correct? Second thing, you told me that it is going to be non-linear in nature, and this is linear. This is a straight line. This is a straight line. Correct? So how is ReLU activation function? This is not linear. This would have been linear if this would have been a straight line. Correct? This is not a straight line. This is a bended line. If you see over here, if you see this complete thing, if I draw this complete thing again, right? Give me 1 second. if I draw this complete thing again, this is the x-axis. And if I draw the graph, I drew the graph like this, that for this is over here and this is over here like this. Now, it looks like that this is a linear function, but it is not, right? I'll actually erase these grid lines now and you will notice that, is this a straight line? Is this a straight line? No, it's not a straight line. So the first thing which I was saying that this is a linear function, it is wrong. This is non-linear. This is non-linear, first of all. Second thing about range. Yes, that is true that it has no range on the positive side, but on the negative side, it is always making sure it is 0, correct? Do you all agree? That on the negative side, it can never go below 0. So yes, ReLU is one of the exceptions, my friend, where it does not have a positive, let's say, a positive bind over there, and it lets you go to infinite, right? There's no limit over there. Now, why is this activation function still being used? Now, this might be a question that most of you are thinking. So I will explain this a little later, but again, just to answer your curiosity, images, my friend, right? Images are very fantastic things, right? Images have numbers in them, right? That images are nothing but big metrics, correct? And in metrics, you have pixel intensities. Remember? And what is the range of pixel intensity? That a pixel intensity number can be either in the range of 0 till 255. Very good. So if we already know this thing, right, that the maximum number is 255. So what I can do is, instead of this infinite, I can write down 25, correct? So to answer your question, actually we can't write 255 over here. Why? Because that x is multiplied by w. So even that x is 255, this w can be anything and this b can be anything. So what ReLU does is, my friend, in ReLU, what we are expecting is that let the intensity flow where it is going on the positive side. And on the negative side, we are blocking that this number cannot go less than 0. So ReLU is one exception over here. Understood? So we have different types of ReLU also now. So see, this problem came in, people started saying that, hey, listen, we sometimes want negative value also. So people said that, okay, if you want negative values, I will not make it I will not make it like this, right? Like this. I will not make it like this. I will make different parameters. Some people are saying we'll make it like this. Some are saying we will make it like this, right? So there are different versions of ReLU over there, right? You can see Gaussian error ReLU, and then this is exponential ReLU, scaled exponential ReLU. But don't worry, right? Don't worry. We will be focusing on ReLU, tanh, and sigmoid. These three types of activation functions are there.
Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with iHub Divya Samparka, IIT Roorkee, and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence, and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
There are 3 inputs and 4 neurons in the hidden layer. Now, what did I told you? That every input layer has to connect to every neuron in the hidden layer. I'll repeat again. Every input neuron has to connect to every neuron in the hidden layer, like this. Now, I am asking you the question, my friend, how many weights and how many biases are there? See, I have drawn this very correctly for you. Now, how many connections do you see? It is 12 weights and 4 biases. How now? See, first of all, how will you count them? The number of connections that you have made, my friend. So in this particular neuron, how many connections are there? 3 connections. So this will have 3 weights and 1 bias, correct? Do you all agree? This particular neuron will have 3 weights and 1 bias. This particular neuron will have again 3 weights. Why? Because there are 3 connections which are coming, right? And then 1 bias. And then again 3 weights and 1 bias. And then again 3 weights and 1 bias. Right? And if you add them all, it becomes what? 12 weights and 1 bias. Now, one of my friends is saying, what about input layer? So my friend, this is the input layer, right? This is exactly what the input layer is. Do you all understand now this thing? Do you understand the schema of that there are 2 layers right now in front of you? This one is called as input layer, right? This is called as input layer, right? And this is called as hidden layer, right? We all have discussed about this architecture multiple times. There can be an output layer also, but just for the sake of, let's say, simplicity, what I'm doing is I am just drawing this half structure. The right hand side structure is still left, correct? So how many neurons do you see in the hidden layer? Can I say 4? How many neurons do you see in the input layer? Can I say 3? Now, do you agree that every input neuron has to connect to every neuron in the hidden layer? I'll repeat again. Every input neuron has to connect to every neuron in the hidden layer. Say yes, right? Now, obviously, every input will have its own weightage towards its own hidden layer, correct? This hidden layer will have different weightage. This hidden layer with respect to x1, this hidden layer with respect to x1, and this hidden layer with respect to x1 will have their different weightages, right? So how many neurons are connecting into this particular hidden neuron? How many neurons are connecting to this particular neuron? How many red color dotted lines can you see? Red color line can you see over there? 3. Very good. So it means 3 weightages are there, right? So this equation can become, can I say that this equation is nothing but H1 is equal to W11 X1 plus W21 X2 and W31 X3. Can I say it like this? Right? And then there will be a bias called B1. Do you all agree to this statement? Now, can I say the same thing for H2, sorry, right? But this time I will say this is W21 X1. Now they have changed, right? W22 X2 and W23 X3, correct? Plus B2, right? One of my friends says, how are the suffixes you have taken? Oh, so suffixes are very simple. You can say anything, right? What I'm taking is, when I say W21, I mean this 2 is the input layer and this is the hidden layer. So what I'm saying is that this second neuron in the input layer is connecting to the first neuron in the hidden layer. Simple. Don't worry about the nomenclature that I've taken. I can just write down simple 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 also. But this becomes much more easier to read, right? It's very easy to read in such a way that W21 means that the second neuron in the input layer is connected to the first over there, right? So that is this how it becomes, correct? Similarly, this H3 and similarly H4 can be done, correct? Do you all agree over here now? Why there are 12 weights and 4 biases? Okay. What if I change the question now? What if I change the question now and make it a little more complicated? Actually, not complicated. Just okay. What if I tell you that there is a output layer also, right? So what I'm going to do is I am going to say there are 2 output layers also. Let me just write them down. And this is output 2 neurons, and I will just simply connect them. Now tell me the total number of weights and total number of biases in this complete structure, please. Again, read the question thoroughly. First of all, read the question thoroughly. I am saying total number of weights and total number of biases in this complete structure. Very simple formula. to remember, very simple formula to remember. Whenever you are calculating the number of weights in between the two layers, what will you do? You will multiply the number of neurons in the first layer and the second layer. So how many neurons are here? This is 3. This is 4. So this becomes 12. It means 12 weight exists just between these two layers. Correct? And how do you count the number of biases? Just count the number of neurons in the second layer, right hand side layer. So 1, 2, 3, 4. So 4 biases. Now in between these two, how many weightages are there? 4. 4 multiplied by 2, which is what? 8 weights exist. And how many biases? 2 biases exist. It means 12 plus 8 is 20. And 4 plus 2 is 6, which I think majority of the people were saying. Definitely, I was expecting one of the formulas regarding this thing. See, I know that all of you are asking for formulas, but I would say don't run behind the formula. Please understand the concept. Because formula is derived from the concept. The concept is not derived from the formula, right? The other way is not correct. Correct? I can tell you thousands of these formulas, but do you want to become a formula machine? Just regressing those formulas? No, right? So my point is that understand the concept. Understanding the concept is very important. Okay. So is there anybody now? So people who are saying 24, 22, do you understand now why this is 20? Should we not consider the weights of input layer? No, input layer are themselves layers. So if you have counted for them, that's not correct, right? We should not count for input layers. Input layers in themselves are input only. Can you confirm that input layers have weightages as well? No, input layers will never have their weightages. They are not connecting to anybody. See, weightages, my friend, only exist when there's some connection, right? Do you understand, everybody? Very good. Affines are neurons. No, my friend. Affine is the equation. One of my friend is saying bias question mark. What is this bias? Just one bias for each. Yes, I just explained you 5 minutes ago. I wrote down the complete equation, right? That for one neuron, this one neuron, it will have only one bias. This will have its own bias. This will have its own bias. That's it. This will have its own bias. Wherever the affine equations are happening, they will have only one biases for them. Okay, but we were talking about a simple model, right? A simple one where we say that x1 w1 plus b1, correct? This was the fine. This is what? This is the phase 1, and phase 1 is also called as feed forward. Oh, feed forward neural networks, my friend. Okay, now what is the second phase? In second phase, we will say that obviously because you have taken these random weights and random biases, the y predicted can never be equal to what? Y predicted can never be equal to the y actual. Correct? Very good. Very good. Fantastic. So can I say that error is nothing but yp minus ya? Correct? Right? We can say that error is nothing but yp minus ya. Now, tell me one thing, my friend. I have a question for you, right? Let's say you are a judge, right? You are a judge. You're a judge of a court, and there are two folks who come in front of you for a plea, right? One is this guy who did jaywalking, right? He was in emergency. He had to cross the road and he did jaywalking. And this other person, he's a serial murderer, right? He has done some murders over there. Will the judge give both the people same, let's say, sentences or penalties? Each and every error should not be penalized equally, right? The penalty should be different. correct? Similarly, my friends, when you're calculating error, now please see over here now. This is a fantastic point over here that I think you have missed in your machine learning also. Now, if there is an error, right? If there is an error where you say yp minus ya, why should all the errors be treated equally? Let's say if the error is very high, why should we penalize them equally? Why should we not penalize them according to based on their intensity? Correct? Do you agree? I mean, see, you guys are deciding the life of a person based on this intensity. The same should happen on machine learning also. That if a model is giving more error, we should penalize it more. Do you agree? Very good. So that is why, my friend, we have a function over here. And this is where your best friend would come in. And his name is quadratic function y is equal to x squared. Now to all my non-mathematical friends, right? See over here now. This is magical thing. What is this function? This function says that if you enter a value of 2, y will become what? Y will become 4. Y will become 4. If you enter a value of 3, this will become what? 9. If you enter a value of 4, this becomes 16. And if you enter a value of 5, this becomes 25. Now, most of you are thinking, Shivam, what is this? Why are you telling us all these things, right? We know this thing. My friend, what you don't know is the magic that is going to happen over here. Now, see, this is a typical graph of y is equal to x squared. This is a typical graph of y is equal to x squared. Now, if I try to draw a y is equal to x over here, you will notice that for a particular time period, y is equal to x is above y is equal to x squared. Again, I know most of you are confused. Shivam, what do you want to say? What are you saying? See, I'll show you a magic. I'll show you a magic. See now, if the value of x is 0. Let's say 9, what is the value of y? It is 0.81. Can I say 0.81 as 0.8? What if I take the same number as 9? It becomes 81. Now, do you notice something what happened over here? If the x number is greater than 1, if this number is greater than 1, it is penalizing it very high, right? The y return is 81, correct? It is returning you 81. But if you take a number which is smaller than 1, if you take a number which is smaller than 1, which is 0.9, if you take a square of it, it actually decreases. It is actually decreasing. You notice over here, 0.9 has actually become 0.8. I'll take the same answer as, let's say, same equation over here. If you take, let's say, 0.4, it becomes what? 0.16. Whereas if you take a 4, it becomes 16. And it becomes, if you take a 40, it becomes 1600. So what this particular function is doing over here, right? If you now come back and focus on this particular graph over here, if you focus on this graph now, this graph is saying that if the number is less than 1, y is equal to x square will always return a smaller number. It means if you have done a small error, let's say if you did a jaywalking because of emergency, because you had a medical emergency and you had to do a jaywalking, which is fine. We will not penalize you. But if you have done a very, let's say, big crime over here, we will penalize you very heavily. Do you all understand the magic of squaring function now? I sometimes, in my own mind, I have never read somewhere, but in my own time, I think that squaring function in itself is a very great judge in itself, right? He's like not he, but let's say this function is like the balancing of the world. It says if you're a small number, it is fine. I will not penalize you. But if you're a bigger number, if you are 4, I will make you 16. But if you're 40, I will make you 1600. Do you see how exponentially it is increasing? That is what the factor of this error is. And that is why, my friends, we use squared errors also. Now, this is why we use squared errors. I think most of you, you have used this error in your machine learning also. But did you ever knew this thing that this is why we use squared errors? This is what the function of square error is. That is why I always say, do not memorize things, right? understand and have the fun in them. Each and every function has a story. Why do we use squared errors? Why do we use root mean squared errors? Why do we use activation function tan h? Why do we use relu, right? Understand those things, and then it will become, everything will become super easy for you, right? So we all understood now what is squared error. Now, why did we talk about square error? Because now what I'm saying is that I will take a square over here, please. What I'm saying is that we should not use this, let's say, a function simple just yp minus ya. We should actually use this function, squared function. Do you all agree now? Why should we use a squared function now instead of using a simple function, right? When we take a sum of, let's say, non-absolute numbers, they might become 0, correct? So squared function is actually doing two things. First of all, it is making sure that all the errors are in the same degree, magnitude, right? And the second thing is that it is penalizing you based on your intensity. Do we all understand? So what is this graph? This graph is nothing but a simple graph which says, and all of you have studied this graph, all of you in your I think, see over here now, this is your typical graph of y is equal to x squared, and I'm only drawing it for the first quadrant. It is replicated the same way in the second quadrant also, right? Correct. So this is how the graph looks like, but I wanted to draw your attention to the small detail that if you draw a y is equal to x, simple line, y is equal to x, you will notice that these two graphs coincide each other at which location? 1, 1. Both the graphs will collide with each other at 1, 1 location. Why? Because when you enter in y is equal to x, if x is a 1, then what is y? Y is also 1. And in x is equal to y square, if x is 1, then what is y? 1 square is again 1, right? So it means both the graph will yield the same value when you are at x equal to 1, right? If you take this one, this is 1 over. Do you understand the graph now? Now what this graph is saying is that for a certain period of time, this line y is equal to x is above the line y is equal to x square. It means that y is equal to x square will return smaller things. It will return smaller things, right? One of my friends says that, but what do we call this graph? This is just a graph, my friend. This is just an equation, right? Y is equal to x square. We have plotted the equation. You want to know what this is called? This is called parabola. This is called parabola, correct? I just wanted to give you a essence that why do we use the squared errors and why they are much better as compared to your normal errors, right? When you take a normal error of ya minus yp, instead of that, if you take a ya minus yp to the whole square, do you understand now? Forget about the graph for now. Forget about the graph for now, right? One of my friends says, if my model error is below 1, and our model accuracy needs to be below 0.1, then does that make sense to use normal error? No, I think then also you will use this error only, my friend, right? Because see, if your error is already reduced, right, then you do not want to go further around this thing. And obviously, see, errors never go in the egg. To be very frank, from a practical perspective, they never go as low as you're thinking, right? But the main point is about the intensity, correct? Because see, the weights are random, correct, my friend? The weights are totally random. They can be very close to what you're expecting versus they can be as far away as you can think. So our job is to make sure that if they are too far away, we have to bring them as quick as possible, correct? Okay, so now what is the error? The error, can I write down the error as ya minus x1 w1 minus b1? Can I say this thing and the whole square? Correct. Now who's the culprit? Who are the culprits for this error? if you see this particular equation, who are the two culprits? Very good. It is W1 and B1. Very good. So this is where your phase 2 ends and your phase 3 starts. What is the phase 3? The phase 3 is back propagation, that we have identified these these culprits. Now we need to correct these culprits. So what do we do now? We need to now adjust our weight in such a way that the error becomes minimum. Very good, very good. For that, I think last time we talked about that what we have to do, we have to differentiate. We have to use a mathematical tool called as differentiation, right? Again, those of you who are not aware of differentiation, please do not worry. Please do not worry. We talked about this particular thing in last class also, but I can tell you again, the differentiation will actually help us to figure out that value of weight where error is. What we have done, we have figured out this equation of error. We have figured out this equation of error. Now we have known the culprits also. So what we'll do, we'll do differentiation. Now, what I am asking you guys to do is that please differentiate this particular equation for me. Now, what is the equation? This is the equation. Let me just draw this line again for you guys. This is the equation. And those of my friends who know differentiation, very good. Those of you who do not know, it is fine. Can somebody do the differentiation for me over here? I'll do it for you. First of all, you solve for the power. So you will say WA minus WP as it is. And then 2 minus 1, it is 1. And then you will say multiplied by, and now you'll solve for the interior one. YA is a constant 0. X1 will be X1 as it is, minus X1 as it is. And then B1 is constant. Similarly, when you will do it for DE by DB1, it will be same. Solve for error. First of all, 2 into YA minus YP and multiplied by YA is a constant, WB is a constant, minus B is minus 1 as it is. Do you understand? Now, I know some of you are thinking, Shivam, you said no mathematics, but now you're bringing mathematics and this is bland. I don't know differentiation. I will not do this thing. So if these are your questions, take a deep breath now. First of all, you will not do all these things, right? Similar to your sklearn, we have all these, let's say, TensorFlow and PyTorch for you. I am just explaining you the concept, correct? I am just explaining you the concept that this is what is happening behind the curtains, right? This is what is happening in the background, correct? So that you know what is happening, right? You will never have to do all these things. One of my friends actually messaged me last week that, Shivam, I'm a little scared of mathematics, but you are doing all this differentiation and all these things. Will I have to make it for complex neural networks? I said a neural network has 15 million weightages. Will you sit down and do differentiation for each weight? Answer is no. I never expect that from you, but I'm just explaining you that this is how it is done. Can you please explain one more time? Can error be negative? So see, when you're taking a square, can a term be negative, my friend Rahul? No, that is the advantage of using the I was telling you the same thing, right? That square actually gives you two advantages. The first one is this, that the magnitude always remains positive. One of my friends says, can you please explain differentiation one more time? So my friend, tell me what is the part where you are having issues, right? I'll take this bigger screen and we'll just use this one. We'll do one more time, guys, friends, one more time. Let's do it one more time. So what was error? Error is y actual minus yp to the whole square. Do you all agree? And if I open up this particular thing, I can also write it down in such a way that ya minus x1 w1 minus b1 to the whole square. Correct? I can write it down like this also. Both the things are correct. Now, if you have to take a differentiation, right? Again, for differentiation, you need to understand all the things. The first culprit is W1. Now, see, whenever you are doing differentiation, you have to solve for equation, solve for the power first. You can see there's a power of 2 over there, right? So the power 2 comes over here. I'll give you a smaller example. Let's say if let's say you have to differentiate this thing. So how will you differentiate? This thing will become what? First of all, bring the power to the multiplication, 3 multiplied by, and then you say 3 multiplied by x, and then you minus the power by 1. So this becomes what? 3 of x square. If I take another example, let's say 4 of x square, or let's say 4x cube. If you have to differentiate this thing, what it will become? See, 4 is written as it is. So we will write down 4 as it is, multiplied by, solve for power, bring the 3 down, 3 into x and 3 minus 1, right? 3 minus 1. So this becomes what? 12x square. Again, I'm asking you that this is not important. This is not important, right? This is just, if you know, it is good. If you don't know, that is fine. Please do not go into details and burn yourself. Okay, coming back. Let's say come back. So what we are doing, we'll solve for the power first, because there's a power. So we will say ya minus yp, and it was 2. So 2 minus 1 as it is, right? Now we will go inside this thing, right? Now we have solved for the power. Now we'll go inside. Now ya is a constant, and the differentiation of a constant is 0, right? Differentiation of a constant is 0. So if we go inside, this becomes 0, b becomes 0. Now we are left with x1 w1. Now w1's differentiation with respect to w1 is 1 only. So this becomes minus x1 multiplied by 1. So it becomes as it is. And if I do the same thing for bias over here, right? Same thing for bias over here. This will be solved for power first of all. Ya minus yp to the whole square into, now see, this is constant, only b1 is there. b1 with respect to b1 is minus 1. This is like this over here. This is what these two equations are. Correct? Can this thing be done without differentiation? Unfortunately, no. Can't. Where have ya and b1 mv1 gone? My friend, as I told you, please do not worry if you don't understand. Second thing is that ya is a constant, and the differentiation of a constant is 0. So this ya becomes 0, and this b1 becomes 0 when you are differentiating with respect to w1. Correct? This is the first and the last time you are seeing these mathematics. Next time you will not be seeing this, right? But see, don't worry about the mathematics, right? I think worry about what is coming out. What is coming out? And actually, let's do practical. I think this will become much more helpful for you when you will do hands-on on this thing. Correct? So let's write down one thing. So see over here, this is a simple example. Here you are not even using, they're not even using a bigger example, right? That is why it is not over there. But when you will see bigger, let's say chain reactions, then you will notice that you have to do partial only. Ya minus yp, and then I just remove this one into minus 1. Now what is going to happen? If let's say we have done this phase now, what is going to happen next? We have done this now. We have calculated these let's say we have calculated these dE by dW. Now what is this dE by dW? This dE by dW is nothing but, let's say, it is the movement that is required in the W so that the error will become minimum. Do you all remember the statement? That dE by dW is nothing. I'll repeat again. dE by dW is nothing but that small step that the weight has to take so that it becomes correct, right? So what we will do now, we will say that, listen, W1, you were random earlier. Now you have to change yourself. And how? That W1 is equal to alpha times dE by dW1. And similarly, our bias B1 will be changed in such a way that B1 minus alpha times dE by dB1. Do you all agree? Right? And what is this alpha? This alpha is nothing but the learning rate. Why learning rate? You all should remember, we talked about that example that if you want to, let's say, stop a car, If you want to stop a car, let's say at the exact, let's say end of the flyover, if you have to stop it just here, you have to apply brakes. Your deceleration won't work, correct? If you, let's say, remove your pedal, let's say if you remove your leg from the acceleration, right, this car will not stop. You have to actually apply reverse brake. And this is exactly what we want, right? If, let's say, we have to land in this valley point, and if we have to stop our, let's say, gradient from going below, and let's say stopping at this point, we have to apply some brakes. And that is why we are using learning rate over here to apply some brakes. Now we are open for questions. First of all, does this make sense to you? This is the same thing that we did last time also. The only small change that I have done today is that I have introduced a newer error. That is it. All of these things we have done last time also. We have done as it is last time also. One of my friends says, is it like W1 is equal to new W1 minus alpha? No, this is the new one. This is the new W. Let me write down. This is the new one. And this is the old one. So we are saying old minus, if you do this thing, you will become a new W. Is this backprop? Yes. Can we have a break for 5-10 minutes? Yes, we can. Is learning rate calculated? Learning rate, I will explain you how learning rate is calculated, but think of it as a break as of now. So, okay, tell me, my friend, when we started for the very first time, and we wrote that equation y is equal to W1 x1 plus b. What was the value of W there? Random, right? Now, this time we will not keep it random. This time we will say that WP is equal to X1 into the new W1 plus the new WB1. Is it correct now, Nikhil? If you remember our last sheet, right, you will notice over here, see what we have done. All of you, please focus here. What we have done is in the phase 1, we start first time with the random weights, random biases. In the phase 2, we calculate the error, right? And we find the culprit. In the phase 3, we are saying backpropagation, that we will now optimize or correct the weight, right? So this W becomes now what? W minus dE by dW into alpha. And this B becomes what? B minus dE by dW alpha. And now this new B and new W will be replaced by the random ones. And again, this loop will continue. But I think, wait. You guys are running in the future. You guys are going, I want to do learning rate and all this. Wait, first of all, hold your horses. Do you understand this page? This, what is in front of you? Do you understand? Forget about mathematics for 2 minutes. Forget about mathematics also. Do you understand the concept? What is happening? How a random weight will now give you the best answer. See the magic now, right? Feel the magic. That is very important. That you started with a random weight, random bias, you took a linear equation, and then how that linear equation just enjoys that magic, right? That how error came into picture, how we are differentiating it, and now this will become correct weights, and eventually our YP will become equal to YA, correct? At one point of time, when we'll repeat it multiple times, we will have a YA equal to YP, correct? Understood? Very good. Now, what we're going to do is we are going to do the same thing. We are going close to YP. Yes, not exactly YA. YP will become very close to YA. One of my friends says this error will be calculated for all the neurons, right? Then backpropagation. So error is calculated at the output. I'll explain you, don't worry. Just struggled with WE. So DE by DW and DE by DVC. Right now, this is those of you who are thinking that you guys are struggling with these two equations. I want to tell you two things, right? First thing is that this is one of the most easiest chain, this is not even a chain reaction. when I'll actually show you the complete thing, right? Then I'll show you how many equations will come into picture and then how complicated this becomes, right? But right now, think of this thing as an equation only. Do you understand that? Let's say if in an interview, they ask you, why are you doing differentiation? Can you answer that question? Nobody, I can guarantee you, nobody in this complete world is going to ask you and say that, hey, tell me what is DE by DW1, or let's say tell me what is DE by DB1. Nobody in the whole interview community is going to ask you this type of question. This is the current position of W1 over here, right? And you are saying that this W1 will change, and you are doing a minus of something, right? Minus of something. Now Obviously, when you are doing a minus, this will decrease, correct? This is what my friend Aryan says, but that is exactly not true, my friend, because it depends on the sign of dE by dW also. What if the dE by dW itself is of negative sign, right? And in the example right now, which I'm showing it to you, actually, when you have to slip down this line, right, your dE by dW is definitely going to be negative in nature. And that is why you will eventually land up to this new W, let's call it as Wn. And this Wn is always greater than W1. You can see on the graph also, right? This is where W1 is. Do you understand, my friend? Please don't think that this is always a positive number. This can be negative also. So now what we'll do is, actually, I think some of you, all of you have understood some nits and bits and pieces of all of you have understood now, right? What we'll do is we'll actually write down this in Python, and I think then you'll understand it better, right? One of my friends says, can we arrive to the new W2 from new W1, or do we have to repeat the dE by dW again? No, you have to repeat the complete cycle. You have to repeat.
Let's have a quick quiz question, guys. And the question is, which of the following is not a subfield of AI? And your options are machine learning, natural language processing, robotics, or cybersecurity. Please mention your answers in the comment section below. Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with iHub Divya Samparka, IIT Roorkee, and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence, and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
This is a complete cycle. And you have to repeat this phase 1, phase 2, phase 3, phase 1, phase 2, phase 3, phase 1, phase 2, phase 3 until either the error becomes almost zero, or the error is not changing anymore. Right? Now, what I want from you guys is, I want complete dedication. Right? I want you guys to just look at my screen, forget about your notes, anything, right? Just drop those notes, whatever you're thinking, right? So what I'm doing is I'm simply importing our three friends. NumPy, pandas will not be used, but let's still import him. He might feel lonely, so let's import him. Matplotlib.py plot as plt, and I will run this. Correct? Okay. Now, please, again, I'm repeating. Please be with me. Give me your undivided attention only for 30 minutes. 30 minutes, right? So let's take any random equation, right? Let's take a random equation. Y is equal to 3x1 plus 4x2, right? Now, what you guys have to do is, you guys have to tell me that for, so just like your machine learning, my friend, in machine learning, you had inputs and outputs, correct? Right? You had input and output. So tell me, if for this particular equation, if the input is 3, x1 is 3, and x2 is, let's say, 2, what is the output? The output is 17. Very good. So what we have done is we have taken some random equation. Forget the equation now. Just remember these three things, that for a input x1 3, for a input x2 2, the corresponding output is 17. This is how your machine learning data also looks like. This is how it is arranged. x1, x2, x3, x4, and then there is the output. Correct? This is what it is, right? So what is the first thing that we will do? The first thing that we will do is we will declare these variables, right? I will declare these variables. I will call them that x1 is equal to 3 and x2 is equal to 2. And can I say that YA is equal to 17? Correct? All of you, those of you who had problems in understanding, that x1 is 3, what is ya, where did ya came from? Do you now all understand that ya is y actual and it came from this number, right? Let me also write down y actual. So do you all understand this thing now? What we have done is we have taken a x1, x2, x3, there is a y, and I have declared the variables. Now can I say that w1 I have to take them random, correct? Random weights and biases, correct? We will not take bias for this particular equation, but just so that I make the mathematical equation simple. Can I say that I can write down np dot random dot rand int, and I will say that give me any random number between 1 to 10 and give me just one number, correct? And I just to show you that this thing actually gives me random number, I am running it below also. Can you all see that if I run it again and again now, see it is giving me random numbers between 1 to 10, right? Just to prove my authenticity, I am running this thing. Okay. Similarly, can I take a W2 also as random? Why W2? I will explain you. Can somebody tell me how many weights are required for this equation? 2 weights, right? Because there are 2 inputs. Very good. Do you all agree that I have taken random weights over here? I have not done any cheating. I don't know what this W1 and W2 is over here. Now, can we say that YP is equal to X1 multiplied by W1 plus X2 multiplied by W2? Is this what YP is? Can we say this thing? No. Plus bias. Oh, so as I told you, right? Just for the sake of, let's say, this equation, I'm not taking bias over here. Right? Just for this equation, because see, we have not taken any bias over here in the original equation also, right? So that's why what I'm doing is just for this equation, just for the simplicity, what you have done is feed forward. What is the next phase, my friend? Once you have done feed forward, then the next phase is error calculation. Okay. One of my friend is saying, Shivam, why have you done this 0, 1 over here? Okay. So those of you who know how this random.rand int works, you might know this thing that if I run it like this, and if I run it like this, it will give me a array, right? NumPy always returns a array. So I have to fetch this number out. I don't want that array over there. So that's why I'm saying 0. Understood? How are weights 2? Please confirm. Okay, my friend, tell me why there are 2 weights. Because there are 2 inputs, x1 and x2. There are 2 inputs, so that's why there are 2 weights over there. Okay, what is error calculation now? Can somebody please tell me what is error over here? ERROR. Error is, can I say YP minus, sorry, YA minus YP to the whole square. Correct? Any problem till now? Any problem till now? Where is YA? My friend, YA is here. See, we have declared over here. This is the actual Y. What is the next phase? The next phase is backpropagation. Very good. Very good. Can I say that backpropagation dE by dW1 is equal to nothing but 2 times YA minus YP into X1, correct? And dE by dW2 is nothing but 2 times YA minus YP, YA minus YP into X2. Am I right? Any issues till now? I have written the phase 1, phase 2, phase 3, right? This is phase 1. This is phase 2. And this is phase 3. Okay. This is phase 3. One of our friends says, you given 1, 10, 1. Why should you have given 1 after 10? Okay. So for that, my friend, you have to answer one of my questions. Do you know what is the syntax of np.random.randint? What it does? It returns random number between lower limit, which in our case is 1 right now, and upper limit. Baba, please don't do this thing. That is why this 1 and 10, those of, listen over here. What is the syntax? The syntax of np.random.randint is like this. This is like this. np np.random.randint lower limit, comma, upper limit, comma, number of, or let's say size of array. Size of array. It means how many elements do you want? Or let's say number of elements. Let me write down number of elements that you want. That's it. No, you know this thing. Some of you know, some of you don't know. Please, my friend who's asking this thing, correct? Okay. Okay, now coming back. One of my friends is saying explain backpropagation. Okay. Explain backpropagation very quickly. I will do. Please wait over here. Yeah, it can be any number. One of my friends is saying why 10? It can be any number. Yes, you can take any number. Any number. Any number. 10, 20, 30, 40, whatever you want. Right? Okay. Let's quickly do the backpropagation also once over here. Right? So can I say that YA minus X1 W1 minus X2 W2? Can it be written like this? Right? Okay. If I have to differentiate DE by DW1, my friends, please see over here. Focus now. We'll not do this again, right? This is first of all solve for a problem, solve for the power. 2 will come down and it will become YA minus YP, right? And then we will solve for the inside part. Now inside part, YA is a constant. It will become 0. We are differentiating with respect to W1. So this term also becomes 0, right? It is left with minus X1, minus X1. And similarly, DE by DW1, W2, what we will do? We will do 2 times YA minus YP into minus X2. And this is what you have written over here. I have not taken the sign correctly. If this is what you were saying, you are correct. I should take it minus X1 and minus X2. So error feed forward, error calculation, and then backpropagation. Now the bad thing is that what we'll do now is update the weights also, right? We have to update the weights. So can I say that W1 is equal to W1 minus DE by DW1, and similarly W2 is equal to whatever the value of W2 is. Now change it to DE by DW2. Correct? Right, now we have to multiply it by alpha also. Alpha over here. Now alpha, which is learning rate, right? So what we're going to do is we are going to take the value of alpha as 0. Actually, let's do it without alpha first of all. Let's do it so that you understand the value of alpha. Let's do it without alpha. Correct? Any questions still here? This is what we wanted. This is what we have done our whole thing, right? But the problem is we have to do it in a loop. We have to run it for multiple times. Correct? We have to run it for multiple times. Correct? So let's do one thing. Let's say that we'll put all these things together, right? And we will run it in a for loop, right? We will run it in a for loop. So I will write down all the things over here again now for you. I will say X1 is what? X1, Y1, Y2. We will, sorry, give me 1 second. See, I'm just writing it again now. Need to fix this thing in a loop. Right, so we are doing it over here, and yeah, that's it. And then now what we are going to do is I am going to make a for loop. So now see, this thing is called as epoch. One iteration of phase 1, phase 2, phase 3 is called as epoch. Correct? I'm saying the term again. one complete iteration. Let's write down also one complete iteration of phase 1, 2, and 3 is called epoch. Correct? Right? Okay. That's one complete cycle. Yes, that's one. You can call it a cycle also, but we generally use the term called as epoch. One epoch means feed forward, it done, error calculation, and then backprop. Next time it will become second epoch, third epoch, fourth epoch, fifth epoch, sixth, seventh, eighth, ninth, 10th. We'll keep on doing it like that. Correct? So the very first thing that we should do is we should write down yp is equal to this equation that we have written over here, right? I'll just copy this whole thing as it is, right? Obviously, we need to, okay. So I'll do some more things, right? Because we need to capture all these details. I'll make some list over here. So let's say y1 underscore list is equal to, let's say a blank list, because we should record all these things, right? Let's record all these things. And this is error list. We'll record the error also. And we will record the y predicted also, yp underscore list also. So I have made these lists so that we can record these values. And shouldn't it be a while loop? Yeah, you can put a while loop, but see, I want to show it to you in a very controlled manner. Correct? Okay. So let's do one thing. First of all, let's start appending these things. So w1, w2 underscore list dot append w2, right? And then I will append the error also. So error underscore list dot append error, right? And we should also, let's say, append yp also, right? So let's append yp also. Yp underscore list, this is a new keyboard, sorry, append yp. Okay, so what we've done is we have stored all these values into a list also, so that any given day, if we want to see them, we can see them, right? Okay, so before I start this thing, my friend, right, let me show you the random value of w1 is w1, and let me do this also. Okay, so you can see over here the value of w1 is 8 right now, and w2 is 5 right now. Correct? And let's run this thing. Okay, it says something. And if I now show you optimized value of w1, w2, this has now changed to something very exponentially high. And if we check our error also, our error is, oh, see this error now. This is huge error. Why this is happening? Why are we not able to come to a point? Let's see what is the value of yp and ya. See, ya is 17, but yp is this very big number. Why? Because we never took our friend alpha learning rate, right? Because now this weight is not stopping over here. Let's say when we have to stop this weight at this particular point, there is nobody which is applying an acceleration. So what is happening is this weight comes over here, and then it keeps on going above. Nobody is stopping it, because that is what is going to happen. If, let's say, think of this thing, if you drop a ball from this thing, right? If you drop a ball from this area, will the ball automatically stop at this particular point? No, it will oscillate for some time over there. Correct? It will go up, then it will go down, and it will go up. Correct? So now my friend says no. That is what is going to happen, right? In ideal condition, there, if you, let's say, put up a ball over here let's say in a bowl, this ball is going to oscillate, right? It will never stop at this point. After the friction, obviously there's a friction between the bowl and the ball, then it might stop. But if, let's say, in the ideal condition, when there's no friction, it will never stop. The momentum will always be there. Correct? Now, please see over here. Now, there is one magic which I want to show you. Let's do one thing now. Let's say that we are going to introduce something called as learning rate. Let's put LR is equal to 0.01. Now, this is one of the standard values that you will see in most of the frameworks that they take, right? And let's say LR multiplied by this and LR multiplied by this. Okay. So let's now start again. Start again the equation. This time the random weight, there are random weights are 7 and 8, right? And if we run again, okay, let's first of all check the values of weights. It has become 2.3 and 4.9, right? Error has almost become 0.0004 and YP has come almost close to YA. Say yes or no? Correct? Now I can actually show you the plot also, that how this has happened. Let's do one thing. First of all, let's plot the error. That what was the initial error and how did the error go down? See, this is your graph. This is your graph. You can see over here that the error was very high. The error was very high. Let me actually put the labels also so that you can understand. What is, who can tell me what is on the x-axis? Correct. So see now over here, what happened, my friend? It went from, see this over here, it went, the error was very high. The error was 400. It eventually went down, 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 and you can see it came down to, after 20 epochs, it means 20 iterations. 20 iterations, it went to 0. Now I know some of you are asking, Shivam, what was the value of YP also? Don't worry, we will do that also. PLT dot plot, and we will say YP underscore list. And if you see over here, this is how the YP was. So earlier the YP was 37.5 and it eventually came to 17 over here. You can see now the error has again reduced to, the error is now 0.001 and the values are again coming out to be 17. Do you all resonate with what has happened over here? Give me just 1 second. Gradient descent, right? If I show it to you, by default, the value is 0.01. Can you see over here? That even these frameworks, and we will be using Keras and Tensorflow, you can see that they are using a learning rate of 0.01. So this is called out to be the optimal one, but is this correct for your model? No, that's not true, right? You can choose a higher or a lower value also. And we will learn that there are other strategies that we will learn where we can change the learning rate. Because of learning rate, now your weights are getting stabilized. Earlier, the weights were not stopping at the valley point. They had to stop at this point, right? They were not stopping. Now, because of the learning rate, there is a push. And you can learn this from the mathematical way also. See over here now. What is this equation saying? The equation earlier said that W1, whatever your old value was, minus dE by dW. Correct? Now, what we are saying is, we are saying that we will not do this big minus. We do not want to bring these big changes. We want to nullify those changes, right? We want to bring very, 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 very small changes. So that is why we are multiplying it by alpha. Now, just imagine, let's say the value of this dE by dW was 3. So earlier we were saying W1 minus 3, correct? Now what we are saying? Now we are saying W1 minus alpha into 3, where alpha is what? W1 minus 0.01 into 3. So now the changes are coming to be very small. Small steps are taken over here because of learning rate. Small changes are happening in W1. So that is why it never misses the valley point. If the speed of the car is very slow, very slow, will it stop at the end of the flyover? The answer is yes, it has to stop. Correct? Let's say you are driving a car. You are driving a car and your point is to stop the car exactly at the point where you have the valley point, right? Or let's say where the flyover is meeting the road. If the speed is ultra slow, the car will automatically stop over here because there is no more momentum from the gravity now. Correct? That is what is happening because of learning rate. Now, I know that some of my friends are stuck to this thing that, hey, Shivam, how are you deciding this learning rate? See, my friend, as I told you, learning rate is a hyperparameter. You can choose a different learning rate also, right? And don't worry, there's a detailed explanation of this thing, right? If you see over here, I have made these sheets for you, right? Where you can see that no learning rate. So see how this is going. When the learning rate is 0.5, see how it is going. If the learning rate is, let's say, if the learning rate is 0.2, see now how it stops over here. Do you see? If the learning rate is 0.01, right? It takes time to reach over there. See now how it has gone down. And now see, I have to reduce the iterations. Do you all see this particular sheet over here? Again, this sheet will come a little later for you guys, but just I wanted to give you a glimpse that yes, there is a topic for us where we will study about these things also. I'll run it again. This time the random weights are 1 and 3, and if we run, error has become now almost negligible now. See, 9.792358 e to the power minus 12, and you can see over here this value is almost 17, right? See now. So what has happened is if I run it for more duration, I am actually just burning my resources because this might have optimized over at this point only. So this was total waste. plt.plot w1 underscore list. And if you see over here, plt.plot w2 underscore list, you will notice that see, W1 went from 1, it increased to 2.75, and after 20-30 epochs, see, it is all saturated. After 30 epochs, it is not changing, right? So my friend was asking this question that will optimized value of W1 or W2 depend on iteration count? The answer is at one point they become saturated. So it's better to use optimized value of epochs also. So we need to take a very low value of LR. Yes, that's what the objective is. The objective of LR is to reduce this term, right? To reduce the effect of DE by DW. But again, there is a caveat over here. If you take a ultra low learning rate, let's say 0.0000000001. So what is going to happen? Now the steps that you are taking, over here will be very minute, like in this particular case. I'll show you. Like in this particular case, can you see now how slowly it is moving? 1 to step, 2 step, 3 step, 4 step. It will take ages for you to do. Whereas if I take a optimized value of learning rate, see now how it is coming up, right? Top, it comes up, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10, it just came down, correct? So yes, it is very critical to use a correct learning rate. Very small learning rate will increase your number of epochs because then it will be working very slow. If you take a huge learning rate, then you're not using the correct, the correct usage of learning rate is not that, correct? When you do not give learning rate, the weights are bouncing on and off, on and off, on and off. I don't know why it is so difficult for you to understand. As I have explained you, Baba, learning rate's job is to stop this ball at this point, and that's it, what we want. If you are not giving the learning rate, the momentum in this ball is so high that it does not stop over here. Rather, it reaches to this point. And then it goes up and then comes down again. It comes over here again and then again goes down. This is just a simple ball oscillation that will happen to you in any given day also. Take a bucket or a bowl that you have in your house, drop a small ball. Will the ball in the very first instance stop at that point? No, it will not. So you can see over here, see your weights now. Your weights are going up, down, up, down, up, down because there is no learning rate. The moment I apply a learning rate, the moment I say that the learning rate is 0.01, you will notice now what happens over here. And again, it is not 0.01, you can make it 0.05 also. Let's say I make it like this. See now, this one is still smoother. Goes up, down, but still it is smoother, right? This is the job of learning rate. This is the job of learning rate. You have taken the value of weights. Your maximum weights random weights can be 10, right? Because you have taken a value over here where you are saying that your upper limit can be 10. If I take a larger number, let's say 100, what is going to happen? So see, my friend, the moment you take a larger number, the y predicted will also become larger, and the larger the yp, what is going to happen? The larger the yp, the larger the error, and the more the penalty, correct? So the model, this whole ecosystem of deep learning is optimized in such a way that even if you give a larger number or smaller number, it will somehow figure it out, right? Did you enjoy this, or did you feel the magic over here? I think the first thing is forget about maths, forget about everything. Do you enjoy the mathematics over here? That what happened? You just randomly took a value, my friends, and see what happened over here. Randomly, with just random weights, you were able to get the correct YP. Your YP was actually matching to the YA, right? See this one now. See how now the error starts with very high error now. See, 16, but it goes down slowly, and becomes 0, almost 0. See over here now. This was 21 initially. The YP was 21 and it went down, right?
Just a quick info guys, Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with iHub Divya Samparka, IIT Roorkee and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
So I am saying that should not be your criteria, my friend. Your criteria is to make sure that you optimize the number of epochs so that you reach the error. If the epochs are less, make them more. Correct? Your focus should not be on deciding what the random value of W should be. Okay, I checked more about the parameters which we use, W1, W2 errors. I was only confused how we can use it in real world projects. So my friend, as I told you, this is just behind the scenes that I am telling you, right? In real world, you will not do all these things. In the real world, you will not be setting your, random weight, or let's say you will not be doing gradient descent on your own. All these things are taken care by frameworks, like how it is taken care by sklearn and machine learning, right? Do you guys sit down and write the own linear equations? No, right? You use sklearn. Similarly over here, Tensorflow and Keras will do the same things for you. Tell me this is not a question. You are saying, my friend, that let's say this is machine learning problem. Let's say this is machine learning problem, right? And this is a house price prediction problem. This is the house price prediction problem. Now, when you are saying, listen to the question. The question is, can we take random x1 and x2? So it means you are saying that you are altering the data. It means you are saying that, Shivam, can I alter the machine learning data? Do you do that in machine learning? I don't know if you're doing that in machine learning. Here we don't do this thing. You don't tamper the input. You don't tamper the input data, my friend. Never. The weights and biases will be random. Your x1, x2 can never be random. Generally, the images that you see, right? There are two different types of images. One is the image that you and me, we see, right? And one is the digital image, correct? That how a computer sees. Now, the very first thing that you need to understand is that how are you able to see the colors? How are you able to see all these different things or structures? The very simple objective that you are standing here, right? You are standing here. Let's say this is the object. How are you able to see this object? You are able to view this object because there is either a primary source, a direct source, or an indirect source of light over here. Direct source is our sun god, right? The sun. This is the direct source of light, or you might have additional, let's say, non-direct sources like electricity bulbs and other things, right? When light comes from this particular part, strikes it over this object, right? Strikes back into this structure, goes through your retina into your cornea, and then a reversed flip image is created for this thing. Now, I have drawn only one line over here, one black line, but that's actually not true, right? There are different wavelengths, my friend, right? Some are short, some are high wavelengths over here, and each color has its own wavelength. Each color has its own wavelength. So there are multiple, let's say, wavelengths coming up over there. There's not just one wavelength that is coming, there are multiple wavelengths, and depending on the frequency of the wavelength, right? Of the light, sorry, not the wavelength, let's say frequency of the light, right? Different colors are dispatched in our eyes. Correct. Why are we seeing all the things in reverse? Yes. So whenever you'll talk to somebody, right, in optics, right, your eyes always see things in a reversed manner. But it is your brain which takes that image, rectifies that image, and inverts it back again. So it comes into the original shape. But and it's also easy to understand, right? See, when you have your let's say eye lens over here, right, and let's say this is the source of energy, this light goes over there. I'll just draw it to you. Again, this is not a biology class, but I just wanted to show you that if you, let's say, if let's say this is the top light, this is, let's say, the bottom light, right? What is going to happen? This goes down, this goes up, reflection, and this arrow will become opposite. That is why. But don't worry, this image goes back into your brain and the brain rectifies this image. Correct? So this is what it is, right? Now there is one more major concept that all of you need to understand is colors. As I was talking about, right, all of you know that each color has its own wavelength, right? All of you know the reason why red lights have the red color in them, correct? Because they have the shortest wavelength, so they can travel the fastest, and you can see them from very far away also, red lights, correct? Obviously, that's the color for stop. Also, later on, we humans decided that this should be the color of stop. But why that is the color of stop is because you can see it from a very long distance, right? You can see it from a very long distance because of the short wavelength. So each color has its own wavelength. Now, the point one more point that we need to remember about colors is that there are three major colors in this world: R, G, and B. Using these three colors, you can make any color. You can make any color. You know, these are called as primary colors. Then you have a layer of secondary colors. Then you have called tertiary colors. And then this tree goes on, goes on, goes on, right? From these three primary colors, you can make any color in the world, right? Now, this is the second concept. Let's talk about the third concept, which is called as pixels. Now, what are these pixels? All of you have heard this name, right? That, hey, what's your camera? How much megapixels of camera do you have? What does this pixel means? It means that in one, let's say, inch square area, right? How many small pixels are over there? How many, let's say, these kinds of cells are over here? Now, all of us have done this exercise. I'll just draw it for you again. Let's say that this is an image that we are seeing, right? Right? Let's say we are looking at one image, right? And whenever we say that we are looking at an image, let's say the width of this image is 1024, just for an example. And let's say the height of the, height was 1024, and this is 1800, just an example. So what does this mean? When somebody says this thing that my image is 1024 cross 412 or 512 cross 720, what does that actually mean? It means that there are 124 rows in this particular image. Now again, please try to forget what you as a human see. We are now in the world of digital images. We are now in the world of digital images, at how images are stored. So when you say 1024, it means 10 rows are there, right? 1024 rows are here. And similarly, 1800 columns are there, which exist, right? And this is nothing. All of you have already seen this thing in your NumPy classes, and this thing is called as a matrix, nothing else, right? I know I can't make 1024, so please don't quote me, Shivam, you didn't make 1024 rows, or you're not making 1800 columns. Okay, fantastic, right? So this is how a digital image looks like, correct? Now, what is stored inside this value? What is this value? This value is called as pixel intensity. Pixel intensity. Now, we are saying that there is a red color, but there are multiple shades of red color, my friend. A red color can be a light red color till the darkest of the blood red color also. And how does this, how do we define this red color? Is based on the pixel intensity of that, right? So each cell in this matrix, right, can have value from 0 till 255. It means how many unique values are there? 256 unique values are there, correct? Do you all understand now? Some people get confused in two things. One is the image size versus the image intensity or the pixel intensity. See, understand, pixel intensity is the value which is stored inside these cells, right? Pixel intensity is something that is stored inside these cells. How many cells are there? It depends on the dimension of the image. Do you all understand? I'll repeat again. There are two things. How many number of cells does a image have? It depends on the dimension of that image. That what is the height, what is the width, correct? But what is inside that cell? That thing is called as pixel intensity, right? Because to generate different types of colors, to generate different types of structures, different pixel intensities are required, right? For a lighter color shade, we'll have a lower value. For a higher color shade, we have a higher value. So please remember, the number of cells is dependent on the dimension of the image, whereas what is the value inside the image, that is determined by the pixel intensity, and that can never be outside of 0 till 255. I'll take a pause over here. Do you understand? Whenever somebody says to you that this image is 1024 cross 1800, what does that mean? That now we are going in the digital era of the images, right? In digital era, it means that 1024, if that is the height of the image, it means that many number of rows are there. And 1800, when that is the number of columns inside that image, it means that there are 1024 multiplied by 1800 number of cells. Does this make sense? I can also say that this particular is a matrix and the shape of the matrix is 1024, 1800. Correct? That is the point. Now see, because there are so many colors in the world, right? And so many structures in the world, each cell will have to have different values, right? And each pixel value or the pixel intensity can only be of the range of 0 till 255. Do you understand now? I'll repeat again. So the number of cells are dependent on what? The number of cells are dependent on the dimension of the image, whereas the value inside that cell, what is going to be stored inside this or this, is dependent on that what color is it rendering, what structure it is rendering, and based on that the value can be only in the range of 0 till 255. Correct? Does this make sense now? Understand this fourth concept now. The fourth concept that is very important for us is that, Shivam, one of my, okay, some of you are asking, Shivam, why only 0 till 255 only? Because this is what my kinds the colors intensity are. Okay, tell me, okay, answer this question. Why are there only 7 colors in the rainbow? Right? Okay, come back now. Come back now. Okay, so the point over here is that, okay, there's a very big question on chat. One of my friends is saying, but on that example that you showed last week, the values were between 0 till 255, but all were either black and white. But in reality, 0 till 255 should show all the colors. No. That's what exactly I'm coming over here, right? Please. That's exactly what the next thing is. That now see over here now, one simple image that we drew over here. I don't know if it is okay. It cannot do over there the back thing. Please. Let's focus here. Let's focus here right now on the next thing. Now see, obviously I told you that R, G, and B can generate, let's say, all the colors, right? R, G, and B. It means red, green, and blue can generate all the colors. But Shivam, here you only showed us 1024 as the let's say rows and 1800 as the columns. So how does it decide that the pixel inside this is for red or for green or for blue? Correct? There might be a question in your mind. Let's go over here. Let's we go to this particular picture, right? Now sometimes it is green, sometimes it is brown. Now let's say when you see the digital aspects of this particular image, how does this cell know that this is going to generate a brown color? Because brown is a combination of some red and some blue, correct? So how does it renders that color, right? How can it render all these colors? For that exactly, my friend, a image that looks like a 1D image to you is actually not a 1D image. What does this mean now? It means that, please see over here. I want especially my friends who are facing issues in intensity to please focus over here. A 2D image that looks to you as a 2D image, please understand. A 2D, see right now, to all of you, this is a 2D image, correct? This one, open in new tab. This is a 2D image, correct? Say yes or no, please. This is a 2D image, right? As a human, it is a 2D image, but digitally, this is not a 2D image. Why? Because it is not just one matrix. Please see over here now. This is how it is arranged. R, then there is a G, and I know we have talked about this earlier also, right? But let's talk about it again. And then B. So what is happening over there is, my friend, the color intensity is not just filled for red. It is filled for green and for blue. And when you merge these three intensities, the desired color is generated. The desired color is generated. Do you understand now how colors are generated? The very first concept that we learned was RGB, that RGB can generate any color in this world. Now, the second thing is that if you have to generate color, you need the value for all the three things, right? R, G, and B. So what you're going to do is you need values for all R, G, and B, right? Correct? So what is happening over here? Let's say this is the first cell, right? This first cell will have values from red also. Let's say 26 is written over here. Lighter shade of red. Let's say a darker shade of green, 200. And let's say again a lighter shade of blue. So it will generate a desired color where, let's say, red and blue are very light and 200 where green is very high. That color will be rendered on this particular image. So every cell will have a 3D view. A image is a 3D. It means that the front end that you see has three colors. Yes, yes. So 3 pixels will be required to generate a color. Yes, yes. RGB colors which are used to derive other colors by mixing any two of the RGB colors. Is this right? Let me read again. RGB are colors which are used to derive other colors by mixing any of the two RGB. Not 2, 3, or even 1 also. Right? And don't worry, I'll show you these color combinations. But do you all understand that an image that looks like 2D to you is actually not 2D, but it is 3D when it is in a digital shape? Correct? So now if I write down, so now most of you can ask me a question that, Shivam, so it means that all the images have 3 colors, right? All the images will have 3 colors. So the answer is no. There are certain images which are, let's say, only of one channel images. What are one channel images? Which do not need all the colors, which need only colors grayscale, right? See, there's a difference between black and white. This is grayscale images, right? So my friend who was asking this question some time back that, hey Shivam, when you showed me that colored, that black and white image, it had only one channel, it did not have 3. That is because that was a grayscale image, right? Then usually you will see all the images will have, usually, I'm saying usually, right? These are colored images. And sometimes you will also have 4 channel images. You will have 4 channel images. This is how it is. The first is alpha, then you have RGB. So alpha is the extra layer, and this is called as transparency layer. This is the transparent layer. Let me write it down very explicitly, that alpha controls the transparent layer of images. Correct? Grayscale images are 2D images. Yes, you can call them 2D images. Correct. Grayscale means, okay, so some of my friends are asking what is grayscale images. Grayscale images are where the colors are in the shades of gray, light gray, from starting from white till black, and then you have, these are grayscale images. Sometimes people call them black and white. These are not black and white images because you can see the shades of gray over here, right? This is not extremely black and white image. I'll show you a difference between black and white, but this is how these are the shades, different shades of between white and gray, which generates a grayscale, right? What is alpha? Oh yes, very good. I will explain you what alpha is. So see, sometimes have you seen these transparent images or logo images, watermarked images? Have you seen watermarked images like this? Now, how is the watermark let's say attached on an image? Now you might say, Shivam, it's very simple. I will just put my logo. That's not true. So what they have to do is, first of all, they have to attach a transparency layer on the image, and then they can, let's say, tune down the whole image, and then the logo is embraced. So exactly. So you guys are thinking that it is just like a signature that it is done on the images. No, it's not. First of all, you have to transparent this image so that this color can come up on the screen. Can you see that this color of the logo is not merging with the background image? This is not a part of that image. So how is it possible? It is possible because of the fourth layer, that is the transparency layer. So in these areas, the image is made purely transparent, and then this logo is superimposed on the image. Do you understand? So force, you will very rarely you will use these images, watermark images, but yes, I just wanted to give you an example that these are 4-channel images. Okay, some of my friends are getting confused between, you know, what is black, what is white, what is this, that. We'll come to that. Don't worry, right? I'll answer each and every questions of your, but please wait. I'll show you with example, with each example. One of my friends says gray is created as a combination of black and white. Is it correct or wrong? Yes, it is true, but a gray color can also be made from RGB also, because RGBs are the primary colors. They can make everything. Do you know even the white and black are made from RGB? Some of you are thinking that no, white and black are the pure colors. Actually, that's not true. White and black are also made from the combination of RGB, right? One of our friends says, for the gray scale, will it not take 3 pixels to show up the gray color? No. Very good. Our friend Ankit has also given the values for them, and very good. One of our friends has shared the hexadecimal values also. Very good. Fantastic. Very good. Okay, so let's come back. We also talked about image intensity. Let's write it down over here also. Not image intensity, pixel intensity. And this can be in the range of 0 till 255. It means you have okay. So now let me show you a magic. Okay. So how many different types of shades can we have for red? Different shades of red, 256. Very good. How many different shades of green can we have? 256. Very good. And how many different shades of blue can we have? Again, the answer is 256. Correct. So it means that there are 256 different red, 256 different green, and 256 different blue over there. Correct. 256, exactly. Very good. All the three are same. Very fantastic. Now, if in the recent time, if you have bought a television, my friend, you might have noticed that the television ads are like this, that, you know, the LG or let's say the Sony Bravia has 16 million colors. Correct. 16 million colors, you know, that many million colors, 12 million colors, and all those things. Do you know that if you divide 256 by 256 by 256, this answer comes out to be this, which is approximately 16.7 million colors. This is where this number comes from, that using red, green, and blue, using the different shades of red, green, and blue, we can generate 16.7 million colors. And this is what the in the TV advertisements you also see when the TV markets itself that, you know, we generate the maximum number of pixel values, right? Do you understand now the concept of colors? The concept of colors and how they are run in digital world also. Fantastic, fantastic, very good. Okay, so we talked about this thing. Let's now talk about that. How do we read these things? Weren't they able to do that before? No. So if you go back 10 years ago, or let's say 15 years ago, you will see that they are saying that we can have, even I think not go 10, 20 years ago. If you go even 8 years ago, right? You will see that the TV advertisement people, the TVs were marketing themselves that, you know, we can do 10 million colors, we can do 8 million colors. One of my friends is saying, can you explain the calculation for 16.7 million? Can somebody explain, my friend? What is the 16.7 and how did it come? Also, one of my friends says, I am colorblind, with that impact my ability to do this properly. Obviously, my friend, don't worry. See, here our job is not to watch the colors. Your job is to watch the values, pixel values. If you can do quick mathematics, if you can do quick, if you can read metrics, you're all fine. We are not here to go in the image era. Correct? We will not work with, we will work with digital images. I will always open up an image as a matrix for you, not as a colored image for you. Correct? Okay, fantastic. So now I think most of you will be thinking that how do we see these digital images? How can we make sure that we can read these images digitally? So in Python, image processing, we have image processing libraries, image processing libraries. The very worthy of them. The first one is OpenCV, right? This is like the great grandfather of libraries. Then we have PIL, also called as Pillow. And then we have SK images, which we will use very rarely because SK images is nothing but the other way around. Right, so there are three different frameworks, three different libraries, not frameworks, libraries to read images in Python very easily. Now we will be working very rigorously on OpenCV. We will be working very rigorously on OpenCV. So let's install OpenCV first of all, right? Okay, can somebody tell me before installing, can I check if this library is already installed for me or not? How can I check that thing? Check if OpenCV is already installed. People are saying pip list, pip freeze, very good. But pip list or pip freeze, my friend, will give you the complete list of all the packages involved. I just want to know that is this package installed or not. For that, I will do import OpenCV. Very good. Hey, Baba. I will do pip show OpenCV hyphen Python. OpenCV hyphen Python. So see, for me, it is already installed. So I am not installing it, but I am doing a pip show OpenCV hyphen Python. That is the package name. And this will give me the complete list if it is installed. And if it is not installed, it will give me nothing. So you can see on Colab, it is already pre-installed with the version of 4.7.0.72. Right? This is already installed over here for me. If you are on Jupyter, please use this thing pip install OpenCV-Python to install OpenCV. But I am pretty sure it should be already installed. If not installed, we need to give pip install. No. Yes, you need to install it if it is not installed. Yes. One of my friends says how to update the version. Very good question. So my friend, this is a question for you. You guys all know Python. You have done multiple packages. how to update OpenCV. How can you update any package? See, this is what our class is. This is what, these are the people. These are the future of data scientists. Pip install -hyphen upgrade and then the package name. Very good. Revise, bhaiya, revise, please revise, because see, today you will learn deep learning, you'll understand deep learning, and you're forgetting machine learning, you're forgetting Python. Please don't do that. Okay. So what I'm going to do is I'm going to, let's say, open up an image. I have an image. I actually use pip install again. So pip install again, my friend, will never upgrade it, right? It will never upgrade it. It will just say that it is already installed, and it will say that use this. Okay, so I have an image over here that I figured out for you guys. We will use this image. Now, what I am using is I am using the wget command to download image on collab. One of my friends has a very good question. He says that how do we know if an upgrade is available or not? How do I know that this 4.7 is the latest or not? So for that, very good, you will go to PYPI. PYPI is the Python index where we keep all these things, correct? And you can check over here or open cv-python, and you can see over here that 4.7.0.72 is the latest version over here that they have, and this is exactly what we are using. Okay, fantastic. So now what I'm doing is I am using this I somehow use this image. This is the image that I always use. I am using wget command now. So wget is a Linux command to download, let's say, any content, right? You can download the image just by right clicking also, but I will use this thing, and you will notice over here that this is done. You can see this image is downloaded over here. If I double click on this thing, it will open up also, and here it is, right? So I've downloaded this image now, and I will use now OpenCV to read this image, right, and display this image, correct? So the very first thing that I will do is import CV2. How do you import it? Import CV2, just like this. And then we will say image is equal to cv2.imread. And then I will say, then I will say A5. What is the image name? A5 something, right? I will never write this name. What I will do is I will use the auto help, autocomplete. That's it. Now, tell me one thing, my friends, if this is a digital image, what is the type of this image content? What do you expect this to be? A matrix? And a matrix is called as what? Tensor? No, dimension, array. I thought you guys have learned NumPy very rigorously. You have used NumPy very rigorously. np.nd array. In NumPy, everything is not, there's nothing called matrix. Everything is np array. What does this n stands over here? Can somebody tell me what is this nd array? What is this nd array? Is this Nandlal there, Hamare? Very good. Nth dimension array. Very good. Very good. And this is how, and if I do a shape, can somebody please explain me the shape? Fantastic. Fantastic. It means that there are 1050 rows in this particular matrix, 1680 columns in this matrix, and there are 3 channels or depth, we can say. Correct? Is there any confusion in this thing? When an image shape comes out, we will never treat it as an image. We will always treat it as an array. It means that there are 1050 rows, 1680 columns, and there are 3 layers back to back. Correct? Very good. Now I know some of you are saying, Shibam, very good. You have shown us all these things. Can you please show us the image also? I mean, that will be like the thing. So this is how the image looks like for you. This big ND array is filled with numbers, and these numbers will be in the range of 0 till 255. Very good. Very, 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 very good. You can see over here, this is your image. This is how it looks like. Can we call them three-dimensional or depth? I think, see, from a matrix perspective, obviously this is just one array, one dimension. But from an images perspective, we call them channels or depth. From an image perspective, we call them channel, and from a geometric perspective, we call them column, rows, and depth. Very good. This is what your image is, my friend. This is how it looks like. This is, and you can see how many cells are there in this image. 1050 multiplied by 1680 multiplied by 3. These many input, can I say that these many inputs are there in this one image? 5.2 million, right? Am I reading it right? Around 5.2 million features, or let's say input, is there in one image. Now those of my friends, I want to ask my friends who are saying, hey Shiva, machine learning can do feature engineering, we can do the same in deep learning also. My friends, and I told you that I will answer this question a little later. Today is the later. My friends who were saying that, you know, we can do feature extraction for images also. My friend, sit down now. There's one image, and one image has 5.2 million input parameters, right? Your house price prediction had around what? I think 21 input parameters, right? If I'm not wrong, 21 or 23 input parameters are there. And there you were struggling. There you were struggling, and you were using techniques like PCA. What is happening? Sorry. 23. There you were using techniques like PCA to decompose these columns and bring this number down to 4 or 5 or 6, correct? This is 5.2 million. Can you do hand printed? Can you do hand feature engineering? That's not right. No, you can't. This is why deep learning comes into picture, correct? One of my friends says this is pixel intensity. No, this is not. Oh, this is not pixel intensity, Baba. This is not pixel. Pixel intensity is the value which is stored inside this thing. This 209, 163, 33, 77. The value inside the matrix is called as the pixel intensity. This is the shape of that matrix, my friend. Shape of the matrix, right? There is one more question on chat where one of my friends says, what is 105016? My friend, 1050 is the, we just wrote over there, just this cell above, rows in the matrix. 1680 is the columns in the matrix, and 3 is the depth of this matrix, right? Do you agree, my friend? Okay, do one thing for me. Do one thing for me, right? Tell me one thing. Okay. How many number of cells are here into this thing, into this image? Please tell me. Okay. There are 3 rows. There are 3 rows and 5 columns. How many cells are there, my friend? And what did you did? You did a simple calculation called 3 into 5, correct? The same thing I did over here also. Same logic I applied over here also. Number of rows multiplied by number of columns multiplied by number of depth, and that came out to be 529,200,000. This is 5.2. That is what we are discussing. Because see, I don't want to proceed further until unless people are clear with this thing, right? And just to make sure to you, right? Okay. If I do a dot min, this number is 0. And if I do a max, what this number can be? Very fantastic. So now one of my friends is saying that they are trying to do the same, let's say, thing on their laptop. And when they do this thing, right, this type is giving them none. So remember one thing, those of you who are on Windows, those of you who are on the Windows machine, you can't read an image like this. Do you remember your machine learning days also? You can't just directly read your image like this. You have to give the complete path, or let's say even the absolute path, but you have to make sure that you're giving it like this: C:// users. Remember to use double slashes, please, like this, please. Correct? So in Colab, it will automatically appear, my friend. As you can see, if I wait there for some second, right? If I just wait there, it should automatically come. And if it is not coming, then you can use command and then spacebar. Let's say I want to know what are the different features of this thing. So I will say command and spacebar, right? Okay. Why are we using image show? Because sometimes people do not like the structure of image, right? Sometimes people don't like this thing. So if you want to see the image, if you want to plot the image, then you say plt.im_show and then you say image. Now see, obviously this will not run. Why? Because I have not imported matplotlib. I will just do matplotlib. Now there is no one in the chat who's going to ask me what is matplotlib, right? All of you know what matplotlib is. Okay, so see, if I do it now, tada, it is over here. Now I know the moment you will say that, hey Shivam, this is not the original image somewhat looks like this. What is happening? Can you guess? Can you hypothesize why it is not happening? What is the thing that is not looking good over here? The color, the tint. Okay, be specific. You are a data scientist. Don't say anecdotal facts. Give me bluish tone. Okay. Can I say that the red color somehow has been replaced by the blue color? Do you agree with my hypothesis? That the green color is still fine. The green color is still the fine. I can see the green trees over there, but somehow the red color has been replaced by the blue color. Correct? And the blue has changed by green. Correct? Okay. So now I'll tell you what happens over here. The problem, that's not a problem. Actually, let's write down. By default, OpenCV reads the image in BGR format and not in RGB. So technically what is happening is the first layer should be of red, right? This should be red. But what is happening is your OpenCV somehow has a problem and it reads it as blue. That is why it is rendering as blue over here. So how can we get rid of this thing, right? We can change the channel in OpenCV. We can change the channel distribution in OpenCV, right? And how do we do this? Very simple. You say image2 is equal to cv2.cvt color. I know my friend was asking, see, this is how I get the auto help. cv2.cvt color image comma cv2.color_bgr to RGB. Change from BGR to RGB. If I do it like this, and if I run it like this, and if I do plt.im_show, and if I do image2 this time, obviously with the correct spelling, you will notice over here that is this what you wanted? Is this what you wanted? Do you all understand now what was the issue with it? Right? That OpenCV somehow does not like to read the image in RGB format rather than the BGR format. Now I know some of you have again the curious minds, why does OpenCV does this kind of this thing? I don't have the answer. So what I did over here, I asked OpenCV that OpenCV, there is a function with you which is called as CVT color, right? take this original image and please convert the color schema from BGR to RGB. Correct? From BGR, please convert it to RGB. And that's what it did. It stored it into a new image called image2. And when I plotted image2, you can see that the color is swapped. Okay, tell me one thing. From a matrix perspective, my friend, okay, forget about all these things. I know you have questions on the chat. No, I will not answer them. First of all, you have to answer my question. Let's say that you don't know OpenCV. Let's say somehow you don't know OpenCV, right? And because it's a new library, and this is what OpenCV has read and given you an array. That first is blue, then it is green. Please listen to my question very carefully. I will not repeat this question. And this is red. Let's say you don't know OpenCV. You just know NumPy, right? And I read the image through OpenCV and I gave you the array. Now your job is to convert this thing into a R and B format. You can't use OpenCV. You can't use OpenCV, right? Very clearly, you can't use OpenCV because you don't know. Can you do it using NumPy? Those of you who are saying transpose, the answer is wrong. Transpose is not this thing. You guys just use the term, right? You guys don't even think that what is the answer. You're not even looking at the question. This is not transpose. What is transpose? What is transpose? Transpose is this. Let's say if you have an array like this, 1, 2, 3. The transpose of this is equal to like this, 1, 2, 3. Is this what you want? Is this what you want? You want to change from rows to column? No. Think thoroughly. Okay, see the two images and tell me what is the operation. Okay, forget. Okay, please forget about the answer, right? Just tell me what will you do in plain English. np.flip. Okay, no, the answer is swapping the numbers. Mirror imaging. Is this mirror image? Really? Need to reorder the RGB layers. Very good. Swap the R into B. Now you guys are correct. Reverse. Some of my friends are saying reverse. No, my friend. The very simple thing is that this blue has to go from here and go at the back, and this R has to come in front. That's it. Correct? No inverse, no transpose, nothing, my friend. Just a simple reordering of the channel depth. Right? Again, see, I'm not discouraging you, but this is not good. Correct? Not good. Okay, let's come back. Let's come back. And some of you were asking that CV to CVT color function is used to convert BGR to RGB, right? You cannot just do BGR to RGB. You can do RGB to BGR and multiple other things. You're confusing two things, my friend. Consider this image as only a matrix. As a matrix, correct? Can I say that it has 3 different rectangles of this shape? Say yes or no, my friend. Please be with me. Can I say that there are 3 different rectangles of the same shape? 10501680, 10501680, 10501680. Can't you swap this third channel with the first position and first with third? You are saying no to this thing. Please don't confuse this with images and metrics both. Consider them either image, either matrix. In each channel, we have 10501680. Yes, my friend. Okay, let's come back to the topic, right? So we learned about this thing that OpenCV can read this image, can do all these things. Now let's do one thing. Let me show you a magic, which I don't think any one of you asked me, but I can actually show you subplot 1, 2, 1. All of you know subplot, right? Don't say you don't know subplot. Now, instead of doing a image show of RGB, what I'm asking you is just to do RGB : comma, colon, comma, 0. Please tell me what is this? This is the original image. This is the original RGB image. What is this thing that I've written over here? Can somebody please explain me? Image with only red color. And you can see over here, these are the tones. Now, some of you might ask me again this question, Shivam, why can't we see the red color? Why is this all blue and all these things? No, this is not blue. This is just a kind of a grayscale color in the red domain. This is not green. Please don't treat it as a green color. What is happening is this is just the red tone. Wherever the red tones are there, you can see darker parts. Wherever red tone is not there, you can see the lighter parts, because this is now just only a one channel image. Do you all agree? The shape of this thing, this is only a one channel image. Do you all understand? Is this only a one channel image when I write it like this? Colon, 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 and 0. Okay, what is this? Okay, again, see, this is where you guys are lacking right now. This is basic NumPy. What we are saying is, we are saying that we want all the rows, all columns, but we only want what? 0th from 3 channels. Correct? Do you agree, my friends? Okay. What happens if I write it down like this? Instead of 0, if I write down 1, red pixels only. And this is green pixels only. Very good. Actually, we don't want these two. Correct? Okay. Let me actually use another image that will make things much more clearer for you. Give me just 1 second. Just 1 second, right? RGB color model. I have a color model image with me. Right. Give me just 1 second. Okay. What I'm doing is I am going to upload this. I'm uploading this red color model that I have. Okay. So what I've done is I've imported this image now. Let me say this is some image cv2.imread RGB color model. And if I show you, this is how it looks. Okay. This has red part, this has blue part. Obviously, I will need to do one more thing. What? Why this red is showing me blue and red is B is showing me red color? The answer is exactly because OpenCV is not reading it in the correct format. VGR to RGB, and I will just say it like this. C2.cdt color. Now is it correct? Right? Okay. Now, please see this image very carefully. What this image is saying to you over here. This image says that it is made up of red, green, and blue. When you mix this red and blue, this makes something pinkish color. When you mix green and blue, it becomes some aqua color. When you mix green and red, it makes some yellow. And if you mix all the 3 colors, red, green, and blue, it becomes white. Correct? It becomes totally white. Now, what I'm going to do over here is, my friend, I am going to simply just, let's say, first of all, show you the shape. That it is made up of 3 channels so that you don't doubt me. 720, 723. Now, please focus just for last 10 minutes. Please focus over here. What is happening? Please, if you don't know, say no in the chat. What is happening when I write it down like this? Okay, one of my friends says no. Others, everybody understood? Okay, see, I'll explain it to you. My friend, please see over here. What does this mean? It means you are saying that image, give me all your rows. I want all the rows. Again, a colon, second colon means give me all your columns. I don't care, give me all your columns. Now in the last part, in the depth, how many depth do you have? You have 3 depths, correct? It is saying 3 over here. And you know what are the 3 depths? R, G and B. And you are saying that give me only the 0th depth. It means give me only the red colors. Do you agree? Now see, red is not a color over there. Red color will only appear when you mix all the 3 over there. Red, when I'm going to write it down like this, it will just show me the intensity, right? I will just plot it for you. Please look into this thing and please be with me. This is a little important and I can see some of you are not getting. Okay, see over here now, when I write it down like this, what I'm doing is I am asking it to give me only the 0th channel. There are 3 channels, but it is going to give me only 1 channel now. And as you can see, this is how it looks like. So on the extreme right, on the extreme right top or left top, you can see it is all filled with 255, 255, 255. To my friends who are asking question on the chat, please just for 2 minutes, right? Otherwise, I'll miss your question and you will say, Shivam, you're missing my question. But I need to focus here also, and you should also focus here just for 10 minutes. Now, what is happening over here? You can see it is all filled with 255, 255, 255. Now, see, the color red is only relevant. The color red is only relevant when there is some other color to either contrast it or to brighten it up. Correct? Otherwise, what is this 255 and 256 and all these things? It is nothing but just pixel values. Correct? When the 3 will mix, then it will make some color, but right now it is just showing you the red. So please don't expect a red color, rather it will give you a black and white, or let's say it will tell you where it is blink, where it is activated, where it is not activated. Correct? I am going to say this thing and I'm going to put a CMAP of gray because these are gray channel now. So I will just say gray over here. Right? Somehow I have a hunch. The moment I write this thing, do you notice that which part of the image is activated only? Can you please tell me? Only the parts where the red was there, right? That only became white, correct? Which is this part, right? This was all complete red, either in full format or in partial format. This was all red, correct? It was all filled with red, 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 red. There was one more place where it was red, was this particular. Sorry, I just moved it over there. Sorry. So I was saying, you can see over there. What is CMAP? Don't worry, CMAP again, it is a matplotlib function. Don't worry, I will explain you. But do you notice over here, only the red is being activated over here. Let's do one thing. If I turn it to 1 now, which part will be activated? Green one. And you can see over here, only the green parts are there and the others are all blacked out. Understood? If I just do the same for 2 now, it means R, G and B, the blue one. This is only activated. Does this make sense to you? What are the 3 channels and how they're activated? Very good. Very good. Fantastic. Now, there are some other parts of the image also. Sometimes you might want and come to me and say, hey, Shivam, we might need to, let's say, sorry. Hey, Shivam, you know, this image is very big. And can you somehow, shrink this image? Now, please understand, there are 2 types of operation of shrinking on an image that can happen. One is called as resizing. And the other one is called as cropping. All of you use cameras every day. All of you take those selfies every day. All of you them upload it on Instagram, Facebook, Snapchat. Can you please tell me what is the difference between cropping and resizing when you do it on your images through your camera apps? Very good. Crop, you remove some part. Very good. Whereas resize, it does not. Very good. It is very important for you to understand, my friend, that cropping an image actually loses a part of the image. Whereas when you resize an image, the data is, let's say, shrunk, right? but the content remain as it is. The content remain as it is. So I'll just show it to you. See over here. So if I do, let's say image 2 is equal to cv2 dot im resize, cv2 dot resize. So what is going to happen in this thing, right? You can say that currently the image is 720, 720. I want to make this image, let's say 200, 200. You can see that now this new shape is 200, 200, 3, but it does not remove any part of data, right? The data is still over there. The aspect ratio is still constant over there, but you can see the data is now 170, 170. You can see the markers on the plotting light, right? Earlier it used to be 700, 720, and now it has done over here. The quality gets reduced. Yes, it does. The quality gets reduced. The pixel intensity also somehow smudges, right? So that is over there. But there you retain the data, my friend. In resizing, you retain the data, whereas in cropping, this is what a cropping is. Let's say this is what a cropping is. In cropping, you say that, hey, I want only the first 400 rows and 400 columns, and I want all of this. This is what is called as cropping. See now, this is called as cropping. In resize also, we are losing some information. You don't lose the data aspect of it, you lose the quality part of it. All of you have done this in your selfies when you crop somebody else. All of you have done these things, right? You crop the people when you move them down. Whereas resizing is when you try to zoom in or zoom out of a picture. If I explain it into your terms of Instagram, this is what is. Resizing is almost like zooming in and zooming out, whereas cropping is when you crop somebody out of that image, when you throw that extra person out of that image, correct?
Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with iHub Divya Samparka, IIT Roorkee, and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence, and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
Image here, I will say import cv2 and import numpy as np, import pandas as pd, and import matplotlib.py plot as plt. cv2.imread. First of all, we need to download this image also. So I will say wget. You can download anything as you want. I just downloaded this image, right? And you can see that this image is here with. Okay, somehow this image is not working. We need to use a new one. Fantastic. Every image today is not opening for us. Oh, it's open. We'll use this image and you will help me. Just rename this thing. Okay, I've downloaded the image. I'm going to read the image. How do I read an image? cv2 dot I am read. Very good. And then I say the name of the image. Railway something something. Okay, here it is. Railway. So sorry. I'm missing this up. Load. Okay, here it is. I just loaded this thing, and this is, my friend, right now how the image looks like. You cannot use OpenCV, and you have to convert the image, let's say, bring it to BGR to RGB. Now, I explained you last time also, I'll explain you one more time, is that, my friends, right now the image should be like this: R, G, and B. That's how they should be, correct? But currently they are into this format: B, G, and R. So what you have to technically do is, my friend, the point which is at the third, in the third dimension, whatever is this plate, you have to bring this forward, and you have to bring this into the backward side, correct? Is this everyone clear? Now, before you do this kind of, before you, let's say, answer me this kind of question, I want you to answer me this thing. Let's say there is an array called np.random.randint, and it is in the shape of 3, 4, right? What I want you to do is that move this 0920 on the top and bring this 7053 to the bottom. I'll repeat the question again, that you have to bring this 7053 at the bottom, and you have to bring this 0970 at the top. Okay. Can I say, now please listen to me now very carefully. I'm going to answer this thing. I can see some of you have answered correctly. Some of you are still figuring out. Okay. Can I say that the current indexing is like this, that this is row number 0, this is row number 1, and this is row number 2? Can I say it like this? Right? Now, am I not just asking you to flip this thing, that you do it like this? Correct? Am I not asking you to just reverse this array? Reverse this 0, 1, 2. Now, reversal of 0, 1, 2 is what? 2, 1, 0. Do you all agree? And if you don't agree, then we will need to go to NumPy 101. Right? Very good. So what is this now? How do you reverse an array? How do you reverse an array? There are two ways to reverse an array. Transpose. No, transpose is not array, my friends. Colon, -1. Very good. Very good. Fantastic. Okay. I can still see some of you are very confused. Very confused. Okay. Let me take a list example. My friends, let's say this is the list. 1, 2, 3, 4. I want you to reverse this list. How can you reverse this list? One way is, what I'm asking you to do is, I'm asking you to write it down like this: 4, 3, 2, 1. Correct? Right? So how can you do this thing? Colon, -1. Okay. Somehow this will work. Why? Because you need to understand what does this colon, this thing means. Correct? You can't just, let's say, randomly say :1 or :1, right? See, I'll tell you how this is working. And again, I want you to give me your attention. Those of you who have not understood this thing, this is called as slicing and indexing, right? First of all, very quickly, we'll talk about indexing over here. What is indexing? Indexing means if you want to figure out any one number, right? So let's say you have to figure out this 9, right? What will you write down? You will say array 1, and then you will say, this is the syntax that we are writing. Right now. So the syntax is somewhat like this. Syntax says array 1, first of all, the row name, and then the column name. Correct? So not name, number. Okay. So array 1, what is the row number for this 9? Where is this? What is the row number where this 9 is present? 2. Okay. The moment you write down 2, you will notice that this complete row is printed. Now I don't want 2. I only want this 9. So what is the column number? Column number is 1. Very good. This is called as indexing. It means if you have to pinpoint only one number, correct? Now let's talk about slicing. Now what is slicing? Slicing means that you don't want just let's say one number, you want a piece of array. Let's say you want this particular part of system. So how do you write down? You will write down like this, array 1, and then you say start row number colon stop row number comma start column number colon stop column number. Okay, tell me, if you have to write down this 3392, what is the starting row that you want? If for this 3 to come, what is the starting row? 1. Very good. And what is the end row? It means this 9. What is this? 2. Very good. We will write down 2. Fantastic. Fantastic. Now tell me the column. Similarly, column is again, this is column 0, this is column 1, this is column 2, and this is column 3. So what column do you want? You want to start from column 1 and go till column 2. Correct? Is this correct? Right? Very good. The answer is no, this is not correct. And you will see it does not return us the answer. Why? Because you guys forgot one rule of Python. That if you are talking in the range of numbers, if you are saying somebody that Python will return you the range 1 and 2, it means Python, if somebody says to you that range of 0 till 4, this thing will only return you 0, 1, 2, and 3. It will never return you 4. Why? Because that's what the rule of Python is. The second golden rule of Python is that Python always, when you're talking in numbers, will only exclude the outer limit. Right? So what small change we need to do? We just need to make it 1:3 and 1:3, and you will notice that 3392. Does everybody understand this thing? Is there anyone who says no in the chat? This is the basic NumPy thing, right? Now you might have noticed that I am writing like this: array, then start, and then stop. But there is one more thing which is called as step over here, which we are not talking about. And this is why there are 2 colons over there, if you notice. Right? There are 2 colons over there that you might notice. Generally, we only write 1 colon because that is the start and stop. The step is by default taken as 1. Very quickly, I will make another array over here, np.random.rand int 0 till 10, and let's make it for 3 rows and 6 columns, right? And this is how it looks like. Now see over here, all of you, if you can see over here, over right. Now I don't want this complete row. What I want is, I want you to give me 2, then 7, then this 7. So see over here, if I write down array like this, that give me 0 colon 0, 1, 2, 3, 4, 5, 6. If I write it down like this, you will notice that it will give me all the elements in the first row, correct? 2, 7, 7, 3, 7, 0. But I don't want all of them. What I want is that when it goes to 2, it should not go to this 7. It should go to this 7. It means don't take a step of 1 by default, but take a step of 2 for me. And you will notice now what is happening is, it goes to 2. It now goes to this 7. Then it goes to this 7, right? I'll pop up another array so that it becomes much more easier to understand. Now see, this is 4, 8, and 9. Correct? Please tell me what will happen if I write it down like this. If I write it down 3, then it will give me only 4 and 0, because then there is no element left. Do you understand now? What is this? This is start, stop, and step. How does this work? It works very simple. The very first element is the start element, right? The next element is start plus step, correct? Then start plus 2 times of step. Do you all agree? Then start plus 3 times of step. This is how it is done, right? But notice now what is going to happen if I write down array 2. Give me just 1 second. Okay. Let's say if I write it down, let's say if I make another array and I quickly say that this is equal to nothing but let's say like this. I want the 0th row. Okay, so this is the array now, as you can see, 4, 3, 6, 2, 1. Okay, you all understood that if I write it down like this, see what does colon means? Simple colon means that I am not giving you start, I am not giving you stop, whatever you want, you can take, correct? I am not giving you any starting, it means go from the start. I am not giving you any end, it means start from the start and end till the end. You all can see. If I put a number over here, it will say that, okay, give me only 0, 1, and 2. 0, 1, and 2. 4, 3, and 6, you can see over here, correct? Now, if let's say I write it down like this, it means it will give me all the things. Now, if I say double colon, it means start from the start and the step is by default 1. What happens if I give a step of -1? You will notice something magical happened over here. Why? Because of this formula, the same formula. Earlier, we were saying start plus step. So what it does, it says, okay, I am at the 0th position, 0 plus 1 is go to the first index. Then from first till go to second, second till third, third till fourth, fourth till fifth. Now what is happening is, my friend, now we are saying that, okay, we don't know the start, we don't know the end, and our step is negative. It means it will start from 0. It will say, okay, go -1, -2, -3. You, all of you know, right, this thing that this 4, 6, 8, 0 in positive indexing, it is called as 1, 2, 3, 4, and 5. And in negative indexing, this is called as -1, this is called as -2, this is called as -3, this is called as -4, -5, and -6. You all are aware about this thing, correct? So that is what is happening now. Now it says, okay, -1 means 0 -1, it means give me -1. Then -1 is what? -1 plus -1 is what? -2. So this is -2. Right? This is -2. This is -3. This is -4, and then 5, and then 6. Correct? Is this clear to you, to all of you, that now why it is reversing? Do you all understand the logic? Please do not memorize these things that, I will put double colon -1 because I've read it somewhere else. No, please understand the logic. This is the formula. Start plus step plus 2 into times, 3 into times. You all agree? What is the value before colon and after colon? My friend, I just wrote it over here. Do you understand now? This one. Do you all understand now how things are, let's say, reversed? Now, can you do the same thing in this image? This is how this image is, image.shape. 440, 268, and 3. In this third dimension, you have 3, let's say, slabs, right? R, G, B, G, and R, and you have to move them. How will you move it? You will say image. You will say, I don't want to touch the rows. I will keep them as it is. I don't want to touch the columns. I want to keep them as it is. But for the channels, I want to reverse them. So colon, -1. And I will save it into image 2. The shape is still going to be the same. Do you all notice what just happened over here? And you just put these images side by side so that you can compare, and you can see that without the use of CV2 also, I just did flip this image. And I will say it again that please, if you have any NumPy backlogs, if you have any Matplotlib backlogs, please complete them. You can't continue without them, my friends. Right? Is this clear to everybody? Okay. But again, please, next time, please, when I give you something, please respect that and please come up with the solutions also. Okay, so what are we here today for? We are here today for introduction to Keras, and we are introduction to doing to MNIST, right? So you might have heard these two names from me, the learning framework. You might have heard these two terms from me, TensorFlow and Python, correct? But before that also, my friend, erstwhile frameworks do exist, right? They used to exist, but as of today, they are no more with us. Cafe 2, right? Tefla, then was Piano, right? Torch. These were some old names in framework, but as of today, we have two major frameworks. The first one is TensorFlow. I have zoomed my screen already, right? I now it's not visible to me also. Can you see now? Better? Okay, fantastic. Okay, so the first framework that all of you might have heard is called as TensorFlow, right? TensorFlow came into picture. All of you might have heard this name also. This came from Google. Google was the one which introduced this framework, and this is very industry heavy, right? Whereas we have another one, and this name is PyTorch, and this is from Meta, or your old friend called Facebook. This is very research heavy, right? So these are two frameworks that we use today. One is called as TensorFlow, the other one is called as PyTorch. Now, obviously, we'll go with the industry one, what industry has been using and how they have been doing it. So we were talking about these frameworks, TensorFlow and PyTorch. These two frameworks majorly exist. One is for industry, one is for research. We will obviously go with the industry one because you have to study in the industry also. So, okay, this thing came up, but then there is another thing, which you might have also heard from me saying it again and again. This is called as Keras. Now, most of you will say that, hey, Shivam, what is the difference between a wrapper and a framework, right? See, sklearn was your framework. Similarly, TensorFlow and PyTorch are framework. But Keras came into picture when we had multiple of these, let's say, frameworks, right? Keras said that why do you have to learn all these frameworks, right? You just learn my framework, and when you write code inside it, just tell me that what backend do you want to use, right? So it means that it would primarily run for, Keras would primarily run for TensorFlow and another one called Theano. So these two were very popular in the 2015 era. I wrote the wrong spelling. Right. So these two were popular and people had to learn TensorFlow also, and people had to learn Theano also. This person came and said that no, now you don't need to learn both of them. What you can do is you can learn just one language called as Keras. Right? You can just learn one language called Keras, and you tell me now that which one do you want to use. You want to use TensorFlow? I will convert it for you. Do you want to use Theano? I will convert that code in the backend for you. You don't need to learn these 3-4 different frameworks. I am a wrapper for it, right? So you write just code in one language, right? In just one, I should not use the term language, but let's say in one kind of thing. And this will, let's say, convert it for you in TensorFlow. It will convert it for you in Theano, right? So Keras is never a framework. It is called as a wrapper, right? Now, what happened, my friend? Theano eventually died out. right? They had to sunset their product in 2017, early 2017, Feb of 2017, I still remember. And then Keras, the founder of Keras, his name is Francois Cholet. This guy, Francois Cholet. This guy eventually joined. Then he eventually joined Google, and now Keras is nothing but official API for TensorFlow. It means that until and unless you don't have to do anything very, let's say, changing in the TensorFlow, you should always use Keras, right? Keras is like a compiler? No, it's not compiler. Sir, for what R language is used? R, my friend, R was your statistical language, right? R is not a deep learning framework. R is a statistical language. And again, it's a language. Like Python is a language, R is a language, right? R is all gone now. You should focus only on Python for today. Correct? Okay. So do you all understand now why I don't call Keras as a framework? Rather, I just call it as a simple wrapper, right? This is not an interview question, but generally people do confuse in between wrappers and frameworks. Frameworks are the real backbones, my friend. They are the things which are doing the real work for you, right? Okay. Understood? A wrapper is just a simplified way of writing your syntax. Okay. There are two types of frameworks. One is TensorFlow, one is PyTorch. Now, the TensorFlow syntax is very complex, right? Writing code inside TensorFlow is a little bit complex. That is why they called this person and they said that, hey, Keras, you are syntactically very easy. You are syntactically very easy. So you become the wrapper on top of this thing. What is a wrapper? A wrapper is nothing but it is something that is protecting your chocolates, right? So your chocolate is still your TensorFlow, which will do the main work. The wrapper is just a coating on top of this thing to make things much more easier to port or to transfer. Correct? Similarly, Keras is just a syntax where you can, where developers can write easy syntax. Correct? Understood now? Okay. So the very first thing that we will always check is that do we have TensorFlow with us, right? You don't need to explicitly install Keras because Keras comes with TensorFlow itself. So how do you check if TensorFlow is installed or not? How do I check if TensorFlow is installed or not? What is the command? Version, okay. Pip what? Pip freeze, okay. Pip install, no. Those of you who are saying pip freeze and pip list, they are correct, but there's another way also. See, pip list is going to give you a long list. See, this very big long list. This is not the correct way, right? See, you can't just go and read everything, right? A simple thing over here is pip show and then write down TensorFlow. This pip show command will actually show you what kind of version. First of all, is it installed or not? If it is installed, what version it is using, right? And you can see all the things over here. So it means you don't need to install, I don't need to install TensorFlow, it's pre-installed. But those of you who want to install TensorFlow, they can do it by saying pip install TensorFlow. Correct?
Let's have a quick quiz question, guys. And the question is, what is the fundamental difference between supervised and unsupervised learning in machine learning? And your options are, supervised learning uses labeled data, while unsupervised learning uses unlabeled data. Supervised learning requires human supervision, while unsupervised learning is fully automated. Supervised learning is used for text data, while unsupervised learning is used for image data. Or there is no significant difference between the two. Please mention your answers in the comment section below. Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with iHub Divya Samparka, IIT Roorkee and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence, and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
Those of my friend who are saying that import TensorFlow and then tf dot version, see, that's also a good way. But my friend, tell me one thing. If it is not installed, how will you even know? Right? So first of all, you need to install it, right? Or check it. So for checking, this is the method. Okay, let's import TensorFlow. This is as simple as this. Import TensorFlow STF, and you can do it over here also. TensorFlow version, and this will work. Now, as I told you, we don't need to install Keras. It is pre-bundled. With TensorFlow. tf.keras.version. You can see it is inside it. Is it already installed on Google Colab? Yes. Those of you who are on Google, not Google, it is Google Colab. Those of you who are on Google Colab, it is already installed. You don't need to install it. So Keras to TensorFlow is equal to front end to back end. You can say, you can say to this thing. That because the hardcore TensorFlow is so difficult for people to understand, that they bought in a new thing called as Keras inside it and made it much more simpler. Rather than simplifying the TensorFlow, they said that rather than we spending time in simplifying this TensorFlow, we should actually call this Keras inside. Okay. So let's now talk about what is this MNIST part over here, right? Those of you who are saying we'll go for a break, yes, we'll go for a break, but listen to my part over there, right? See now, what is MNIST? MNIST is National Institute for Standard and some T also, I forgot. This is about 1990s, if I'm not wrong, right? The US postal code, right? These people came to these Yan LeCun and Joshua Bengio and all these folks, and they said that, hey, listen, you guys are working on something called deep learning, and I know you're doing all these things. We have a bigger problem over here. And they said, yes, what is the problem? They said that right now we have to manually read the pin code of these, let's say, pin code of these telegrams, right? And we have to postcards, sorry, not telegrams, postcards. And we have to manually, let's say, somehow categorize them. Can you propose a system which can read these pin codes, and we will then make an automatic arm which can, let's say, tell you where to go if this is the pin code. So your job is to read those digits on the pin code. Now, as all of you know, pin code is made up purely of numbers, right? 1, 2, 2, 0, 0, 1, 1, 3, 4, 5, 9, 6, right? These pin codes are purely made up of numbers over here in US and in India also. So typically what they are saying is that if I give you an image like this, where it is written like this, you have to tell them that this is a 9. Correct? Do you understand the problem? That for every image of a digit, you have to tell what digit is written inside it. This is the problem. Correct? So Yan LeCun said that, yeah, fantastic, we'll do it for you. What is the problem? The problem is they said that we have never collected the data. We don't even know how to collect the data. So can you make your own data set and can train this model? he accepted the challenge and he made the data set, which is now called as MNIST data set, right? Now, there used to be a dedicated MNIST website by Yan Kun, and this is now logged somehow. It requires some kind of login. I don't know why, but it has been logged just recently. But MNIST was the website where you can read about more into details. What is this thing? Okay, give me 1 second. I'll just. Okay, this is how the website used to look like. Right. So I know it's not a very fancy one, but he says over here that Yan Kun, Corinna Coates, and Christopher Bergs, these people said that we are creating a data set called as MNIST, and this data set contains handwritten digits. I will show it to you also. How does it look like? But this is what they have done, and it contains 60,000 images. Now, what they did is they said that because you guys are not giving us the data, so they went to every student in the university and they asked them to please write down 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. They asked everybody that, you go and write down, and that's how they collected. That's how they collected this data. Now, this data contains 60,000 images for training and 10,000 images for test. Again, I'll repeat, 60,000 for training and 10,000 for test, right? And they gave you a 28 cross 28 image. If you can see over here, it says that the images are centered in 28 cross 28 image, right? So it means the images are not very big. They are just 28 cross 28 images, right? And how do they look like? They look like very simple. I'll just show it to you. If I write down MNIST, that's how they look like. That is how they look, right? Do you all understand how this problem arrived and how, as I always say, right, that see, deep learning is all, or let's say even machine learning is all about understanding what with the problem mindset. Should work. Let's try. No, it does not work. That's a web page. So I need to use this one. So this is what MNIST looks like, right? So this is how it looks like. Currently, this is a very small sample. Let's write down what it is. So can we say that is handwritten digits from 0 till 9, correct? Do you all agree? Right. These images are single channel. Remember this thing. They are not 3-channel colored images, right? These are small single channel images. It means the shape of this thing is going to be 28 cross 28 only. And then they told us that 60,000 images are for training and 10,000 for testing. Correct? Understood? For different handwritings. Yes, obviously, one person will not write, otherwise the dataset will be biased, right? They have asked different people. So you can see now the variation in the two. Some people write two like this. Some people write it like flat, right? So it's different for everybody. So to bring those variations, they ask different people to write this different thing. That is the dimension of image, my friend. It is written over here also that these images are single channel images with size. It means the image size is 28 cross 28. Right? The height of the image and the width of the image is 28 cross 28. Very good. You guys have answered it on chat also. Fantastic. Now, so what is the objective? The objective of this particular call is that we will have an image. We pass this image inside a deep learning model, correct? Inside a deep learning model. Once you send this inside a deep learning model, the model should give what? It should predict the digit. Is this clear to everyone? This thing, this process flow, right? What is the input of the model? Input of the model is images. Can I say? I can say this is called X also. And can I say what is the output of the model? Output of the model is digit, or we can also call it as label, or we call it as Y. Objectives. The objectives are clear. So what is the first thing that you want? You want the data, right? So fortunately, Keras is your best friend. And Keras says that I can help you with this data. That I already have these very major data sets with me. As you can see, I'm going to populate the list. CFAR, Boston, Fashion MNIST, right? So I'm going to take MNIST and I'm going to say load data. Now, the moment I say load data, how is it going to return me the data? Is it going to be in images? Is it going to be an array? What is this going to be? So let's try to read this. What does the function say? The function help says that give me the path, whatever you want. So I don't have a path. We just will take it, let's say, as the default, which is says MNIST.npz, which is fine. And it says in return, it is going to give me a tuple of a tuple. What does this mean? It means it is going to give me data into two parts. One is the training and testing. And inside the training and testing, we will have images and their corresponding labels, correct? Okay, as you can see over here, we already know this thing that this data set has 60,000 images, 28 cross 28 grayscale images of 10 digits, right? Along with the test of 10,000 images also, correct? And you can see it returns a tuple like this: X train, Y train, X test, Y test, right? So I'm going to just copy this as it is, or actually let's write down. It's much easier to write it down. So it is returning you data into two formats. The first one is the train, and then the Y train, and then the X test, and then the Y test. How many of you are not familiar with this terminology of X train, Y train, X test, Y test? Double roll, not aware. Okay, not aware. So see, my friends, this I think you all have done in your machine learning also. Remember your machine learning days. Okay. So as I told you, this data set is going to give you two parts. One is the training data, correct? And the other one is called as the testing data. So as you can see, these two are testing and training. Now, my friends, tell me, to train any kind of model, what are the two things that are required? One is the input, other one is the output, correct? One is the input, other one is the output. You need both the things. So X train is the input and Y train is the output. So in our case, what is the input? It is the images, which is the X train. And what is the output? The output are going to be labels, right? So if I run this thing, first of all, can somebody tell me what is the type of, what is the type of, X train? Now you might say, Shivam, these should be images, right? But yeah, actually, Keras has done one thing for you. They have already, let's say, read these images and they have converted them into NumPy array for you. They have already done this thing. So as you can see over here, if I tell you the type of X train and Y train, all of you should not be surprised that they are already ND arrays. So let me reiterate now. Testing data, training data. We'll forget the testing right now for some 5-10 minutes. We'll only focus on the training data. So this concept is clear to all of you, right? This thing that when you are training a model, you require both the input and the output. You require both images and the labels. Is this concept clear to everyone? Say no in the chat if not. I'll repeat my point. I'm saying that the concept of having both the input and output ready, right? It means you have to give the model both the things, the input also and the output also to the machine learning model. This concept is clear to all of you, right? Very good. Very good. Now see over here. Who can explain me what is this shape? Who can explain me the shape? Can I say that this is nothing but number of images, X, height, and then width? Correct? 60,000 images. And what is this? Just 60,000 labels. Correct? Now all of you internally want to see the images. Am I right or wrong? Right? You want to see the images? Okay, let's see the images. plt.im show, and I'm going to show you the first image of X train. And in the meanwhile, I am also going to print the corresponding label for this. Is how it looks like. Is this a fifth image? Right? We can see more images over here also. I can show it to you. Give me just 1 second. The image is distorted. No, the image is not distorted. Actually, the CMAPs of this particular thing are distorted because this is a single channel image. I have to do it like this. Now you can see. And those of you who are saying this is not this is distorted. So my friend, this is a very small image, a very small. Just imagine you guys have a problem of looking at, it's not a problem, you guys have a habit of looking at 1028, 1028, right? HD images. This is just 28 cross 28, right? Okay. So this is the first image that I showed you. Let's make a function and let's get any kind of image, right? So let's make a function here called as plot digits. We are going to say image is equal to X train and then image number, and then label is equal to Y train and then image number, and then we are going to say plt.im show image, and then we are going to print label is correct. Now if I say plot digit, let's see what is at the 100th location. So now there are 60,000 images. Obviously the function name is not correct. Now it will work. So there are 60,000 images. Now I can enter any number between let's say 60,000, and you can see it will now print me images. Throw any random number between 0 and 60,000. 6877. Okay, 6877. At this particular position, there is an image called 1 and the label is 1. Okay. 59999. Okay. At this particular image, there is an 8. One of my friends says 101. 101 is over here. 808. So at this particular location, you have 3. Right? 555. Right? So you can see over here that these are different types of images that are present. See, again, there is no objective to show you just these things. I'm just saying that this is how you can see the images. 60,000 different images, right? And these are the correct labels also, as you can see, right? Scroll up. Yes, over here. All of you understood this simple function that I've made over here. This number takes in the number that you are sending. For that corresponding number, it grabs the image, it grabs the label, it tries to show you the image and prints the label. Why it's now grayscale and PL? Okay, you can put a grayscale, my friend. You guys fret over small things. See, now it is fine. Now is it fine, my sir? Okay, fantastic. So that's how you can do. Just to give you a brief idea that those of you who are having hard time understanding this thing, that this function will pick up. The only thing we have used till now for Keras is just to download them. That's it. Other than that, these are just NumPy arrays, correct? We have just used dot shape, dot plot, anything, correct? Do you agree, my friend? Keras is not doing anything as of now. We have just downloaded the data. Y_train. Now what should I write down? Dot balance. Dot what? dot value counts. Okay, fantastic. And you will be surprised to note that value counts does not exist for NP arrays. It exists only for pandas data frame. Very smart folks. You are in the right direction, but not. Okay, very good. So what will we do? We will say PD dot either data frame, and then we say y underscore train, and then we say dot value underscore counts. And then if we run it like this, you will notice that, yeah, it's slightly biased. Sorry, not balanced, right? Technically, all the images should have same number of images. Is this clear to everyone what we have done over here? We are actually checking that if the number of data inside this is this balanced or not. It means we are checking for each corresponding digits how many images are there. So you can see that 1 has the highest number of images. So 6742 images are there corresponding to 1. 6265 images are there for 7, with I would consider almost balanced, right? Ideally, we can consider this as balanced, right? I mean, we should not be rigid that, all should be 6,000, but it's almost there. Okay, fantastic. So the data looks good to us and we are over there. Okay, now can somebody, I'll give you 2 minutes, right? Can somebody write down a function for me that if, let's say, let's say give it a digit name, and it can print me 10 different types of those pictures. So let's say if I write down something like this, that let's say def print all, not print all, let's say print digit images. And if I give it the digit number over here, it shouldn't return, return print 10 random images of digit passed in function. I want this kind of this thing, right? I will give you 2 minutes. Think about this thing. First of all, read the question and then think about this thing and how can you make this function. Again, this is not data science. This is just pure Python and NumPy. Y-train is nothing. Y-train is nothing. But what is Y-train? Y-train is labels, right? If I print over here Y label for you, Y-train is nothing but digits like this, where it is written the first image is of 5, second image is of 0, fourth image is of fourth, third image is of fourth, and then similarly the digits are written over here. We just clubbed those images and then we got this answer. Do you understand, my friend? We are not going in the images, rather than we are talking at the label level right now. If Y-train was not balanced, then what do we need to do? Well, that's a very valid question. As of today, don't worry about it. But in a particular session, we have a particular problem that will come to you where you do not have balanced data. And then I will teach you what is synthetically generating data, what is augmentation. We'll talk about it. What I'm asking you to do is, I am asking you that, let's say I asked you to print all the images of 0. So what you have to do is you have to find 10 random images of 0 and then print them. 0 is one example. I can ask you for 3, 4, 5, anything, but just 0. If let's say you have to print 10. Okay. So first of all, let's break down this problem, right? Let's break down this problem. Plot multiple images. Tell me how to get all images of 0. Let's say a very simple question. How can I get this thing? How can I get all the images of 0? np.where Y-train is equal to 0. Okay. And what will it give you? Get indices from Y-train and apply it on X. Very good. Fantastic. So some of you have given me the rough skeleton. Those of you who are thinking, please, my friends, please look over here. Please. If you have figured out the answer, very good. If not, please see over here. See, this is how X-train is right now looking like. Do you all agree? This is how it looks like. That 60,000 images are stacked one behind the another, right? One behind another, these images are stacked, right? And each image has a height of 20. each image has a height of 28, a width of 28, and there are 60,000 images which are stacked one behind the another. Correct? Similarly, there is another array which is called as Y train. Now, for each corresponding image, the label is stored inside this Y train. Correct? Inside this Y train. And then you have labels like this. 1, 2, 3, 4, 5. Inside these, your labels are arranged. Right? Now, these labels, what are these labels? These labels are nothing but 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct? Give me just 1 second. They are filled up like this. So it can be, let's say 0, it can be 1, it can be 9, it can be 8. So the very first thing that we should do is we should collect all the zeros wherever all the zeros are present in this Y train array. Correct? Wherever all the zeros are present. So what will I do is find all 0 digit in Y train. Correct? Please be with me. Give me your attention. Please. Right? I'm saying it again. Please. Okay. So what I have to do is now can I say that np dot where, all of you have read this thing, right? Np dot where. It means we are asking that wherever Y train, wherever you are 0, give me all the indexes. Now it has returned you the indexes over here. That at the first position is a 0. Then at the 21st position there is a 0. At the 34th position there is a 0. Do you all understand this thing? It means these are all 0 indexes. It means at this position 0 is present. Correct? Now can I say that at the same position their images are kept but in X string? I'll repeat again. What we have done is we have first of all asked that Y train, tell me wherever the zeros are. And it gave you a very long list. It said that, okay, this is where I have all the zeros present. Now, can I say that at the same position, but in X string, we have all the images? Correct? So can I say that 0 images is nothing but X underscore train and then 0 index? Correct? Something like this. Right? Sorry, did I say test? I'm sorry. Please don't take test. This is where it is. Do you understand what I just did over here? I just printed the shape of 0 images, and you can see that all the 5923 images, of 0 has been captured in this array. Now we can do the similar thing for 1 digit, 2 digit, 3 digit, 4 digit, and 5 digit also. Right? Am I right? Very good. Now, how do we plot this thing? Now we have figured out all the images. Now we have to select only, let's say, 10 random images. How do I find 10 random images over here? How do I find out 10 random images over here? Very good. One of my friends says np.random.choice. Very good. Very good. Fantastic. We can do it like this. 0 images, and let's say I want 10 random images. You can see over here that it will throw 10 random images, but it says that np.random.choice can only take a one-dimensional thing. It can't take three-dimensional object over here. So for that, what you can do is you can say that 0 images. It means np.random.randint go from 0, go till length of 0 images, give me 10, and that's it. And if I show you the shape, you will notice that this number has now reduced from 5923 to 10, and these 10 are selected randomly. Who can tell me the logic over here? What have I done written over here? Please read this thing carefully. Hey, what I said is that you have 5923 images. What I'm saying is that please run a np.random integer from 0 till this number, 5923, right? And give me only 10 images. That's it. And every time 10 different images will come up. Do you understand, my friends? Right? Fantastic. Fantastic. Now, what I'm going to do is I am going to, let's say, make a function around the same thing that we have written. Def plot let's say digits. We already have made a function, so we should call it something subplot. Let's say subplot images, actually digits, and then we will ask for a digit, right? First of all, what is the responsibility? That gather wherever the labels are, wherever this thing is present. So np.where y_train is equal to digit, right? Where are the images? Images are x_train and then labels. Then we will say that we do not want, let's say, all these things. We will say that we only want 10. So what we will do? We will do over here, we will say images is equal to images np.random.randint, and then we will place 0, comma, length of images, comma, number, right? And then we will say as it is. Then we will do what? Then we will plot these images, right? For plotting, my friend, I'm going to say for I in range of number. Let me write down the full code and then I will explain you the complete things. I can see some of you are asking for this thing. plt.subplot 1, number, I plus 1. And actually, I should not explain you this thing. You should write down this code, but it's fine. Xtrain and then what? And then I should give you that we have already got the images, right? We have got these labels already over here. So why should I run this thing? I should just give it the labels. Okay, give me 1 second. Labels is equal to np.random.choice. I'll just copy this. Okay. Now what do I want? I have all the labels with me. I will just write down the labels and then I. Correct. And then I will try to write down CMAP is equal to gray. What is all this thing? I will explain it to you. Give me just 2 minutes. So, okay, we ran this thing and let's say by default the digit is 0, right? We'll also write down this thing. So subplot digits and let's say we give it for 3. Let's see what happens. This should fail. Oh, dramatically this fails. Very good. Let me see where the problem is. We said that give it 10 labels. Okay, fantastic. This should not be the case, but okay. Okay, has anybody figured out the issue already? Because I have. Okay, fantastic. And then I say labels again, and then I print the length of labels. This should decrease to 10. Okay, number is 10. Fantastic. And the latest labels should be this. My mistake. See, oh Lord, please Don't punish me for this thing. This is what it is, correct? What I was doing was, I was just selecting the random number between them, but okay, fantastic. And also I should not choose numbers from them, right? Very good point. Very good. Very good. Those of you who figured it out, fantastic. Those of you, fantastic. Okay. Give me just 1 second. Can I run a np.random.choice on this thing? I'm pretty sure I can, but just again, those of you who are asking what I'm trying to achieve, I have written it already. I told you also. Just 1 second. Fantastic. So I don't even need all these things. I will just simply say np.random.choice, and I will say labels, comma, number. That's it. And you will notice that we are able to print this thing. And if I have to increase this, let's say fig size, I can increase it to 12,10. So what I'm doing over here is, my friend, let me explain it to you. Very simply, what I'm doing is I am saying that, hey, please print the digits 3 for me. And by default, it prints, let's say 10 digits for you. You can ask it for 15 digits. And now it will print digit 3, but 15 random images for you. Every time they're going to be random, right? So if you want to do a quick sneak peek over the data, right? That how does 8 look like? How does 7 look like? How does 5 look like? How does 4 look like, right? You can see over here, correct? The most, I think, confusing number is 6. I'll also print that also, but you can see over here, see? Every time you run this thing, you will have a different set of 15 different digits. Does this make sense to you now? 2 is confusing. Yes, I know that's how people write down. And if you think 2 is confusing, then my friend, I should print 6 for you. 6 is like very confusing. 6 and 8 are very confusing numbers over here. See, 6 sometimes also look as 4. 6 sometimes also look as, you know, something else. But that's how it is, right? Okay. Now I'll try to explain what I did over here and why it is important. Most of you might be thinking, Shivam, this is a deep learning class. Why don't you just push and show me the code over here? See, we will not reach the code until unless you don't understand this thing, right? Okay, so I'll explain you what I'm trying to achieve first of all. All of you understood, right? That what I'm trying to achieve, we are, let's say, plot random images of similar digits, right? That's what we are trying to do. Now, what I have done in this particular part is, my friend, collect all images of that particular digit, right? So let's say in our case, we have written 6 over here. So this particular command, this particular line collects all the images of this particular 6, right? Then what we are saying is, we are saying randomly pick 10 images, or let's say pick the number of images that the function is saying. By default, the value is 10. It means 10 images will be picked up from random. Then we are saying, this is just nothing but, let's say, create a PLT figure and define the size of graph, correct? Second thing is, now that I am running a for loop. For loop for the number of images. So let's say if you have asked for 10 images, this for loop will run for 10 times, right? This is the code which creates a subplot, right? And this plots the image. Do you understand now? Is this function clear to you? Please take a minute, read the code. It is very important. Before you say anything to me, please read the code, right? And then ask your question. I will explain it to you 2 times, 3 times, 4 times, but please read this thing. These are the, let's say, your x-ticks of the graph, right? You all remember what is x-ticks? These are X ticks of your graph, and these X ticks are written in such a way that what is the size of your image. So your earlier your image was plotted like this. If you go on the top, you can see these labels over here: 0, 5, 10, 15, 20, 25. These are called as ticks, right? And this is coming here because the image size is 28 cross 28. So that's why you can't see 28 over here, but it says that it is more than 25 image, right? So it's just the scale of the image. Collect all images with digit 6. Correct? Let's say this is the objective. My friend, be with me. I will not take your name, but be with me, right? Okay. So what was the code? The code was very simple. We will say np.where x underscore train is equal to 6. It means wherever the label is written as 6, it will give me all the indexes. Correct? Correct? Am I correct? And if I run this thing, my friend, you should not be surprised to note that it returns your results inside a array. Sorry, inside a tuple. Do you see? That it returns you the answer in a tuple. That is why I had to write down a 0, that please unravel this tuple now. Now you can access the array. Correct? Do you understand? Understood now why there's a 0 over there in the end? Because we want to open up that tuple and read it through this thing. We are reading from a tuple. And why does it returns a tuple? That's also an interesting story, because np.where actually works in a dual dimension manner. Right? So that's why you have to write down a 0 over here, because we are working in a single dimension only. Right? See, we are not modifying the tuple, my friend, so don't worry about this thing, right? We are just opening the tuple and reading it from over there.
Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with iHub Divya Samparka, IIT Roorkee, and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence, and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
How many features are there in this particular data set? But yes, so the number of features can be 10 out of this. Some might not be useful, some might be useful, but okay, very good point. So all of you understand, right, that let's say if a data set has 1 million rows and 10 columns, this data set has 10 features. Similarly, if you have a image data set of 60,000 images and each image is of 28 cross 28, which is 786. So how many features does your data set have? How many features does your image data set has? 786. Very good, right? This is clear to everyone, right? That 60,000 is actually representing the number of rows and 786 is acting as a kind of an column over there, correct? So the very first thing that you will do, my friends, as a deep learning or a machine learning engineer, what is the very first thing that you will do? Tell me, based on the life cycle, what is the first thing? Let's say you have done the client conversation, the client have explained you, they have given you the data also. Now what you will do? The very first thing is, okay, let's say you have done the problem understanding also. In this particular case, I've already explained you, right, that the US postal code came to you and Yanli has already got the data. It done all the things. Okay, load the data set. Okay, second, my friend says standard scalar, then EDA, then data collection. Okay, so let's do it one by one. First of all, let's say load data. tf.keras.datasets, right? .datasets .MNIST .load data. Correct? Fortunately, Keras has already given us this flexibility that we don't need to do this thing. But in next problems, right, you will see that we will not be using this. We will be using real data from Kaggle itself, right? What is Kaggle? You already know. We'll not talk about it right now. But what we have done is we have gained the data. So the very first thing that I can do from my behalf is that I can show you these two shapes. Correct? Now, next thing, tell me what should we do now? Check for null value. Okay. So check for null value. This data set does not have any null value. I mean, you can't check it over here like this, but all the images do render, right? Because this is the shape of 60,000, 28, 28, it renders. So technically, the point that I want to bring out over here is, my friend, that right now, this particular data is already given to you, but very good that as all of you have brought up, right, that we will try to do the same kind of aspect that we do in machine learning, right? Check for null data, check for some anomalies, right? Check for other things. Same things you could do. So right now, this data set, I'll tell you how now you can do these, how can you achieve these things on images. Now, in this particular set, fortunately, this is all done. But unfortunately, in your next coming data sets, what is going to happen? All the images will not be of the same shape. So how do you decide that what the shape will you go with? That's a question for you right now. Resize all to 28 cross 28. Okay, how do you decide that? Okay, let me give you an example. Let's say that there is a certain data set where you have, let's say, 3 different sizes of images. One is 90 cross 90, other one is 100 cross 100, and the other one is 120 x 120. Right? There are 10,000 images for each size. Now, which size will you go with finally? Will you drop the other size images? If you will, now see over here, my friends, right? You want to keep 90 and you want to resize to the lowest one. Now I know most of you are thinking that, Shivam, we should actually, let's say, bring a upper size dimension image to a lower size, right? That is more beneficial. Why? Because then we are losing information. Whereas if you add a 90 to a bigger, let's say 100, right? What is going to happen? You're adding some additional. That this is where, let's say, the gap is between. I think you guys are confusing between cropping and resizing. Resizing can be done of any dimension, my friend. A 90 can also be stretched to make a 120. How many of you agree with this point? First of all, say this thing. How many of you understand this thing that resizing means that I can actually bring a 90 image and stretch it to make it 120. And resizing also means that I can take a 120 and squeeze it into a 90 also. Is this correct? Because see, now when you are saying, my friend, that I will make every image 90, what you're saying is that I want to squeeze down all these images and bring them, reduce their quality, or not pixelate them. Pixelate is actually when you're expanding them. You want to condense that information and put it into a lower pixel value image. There you might lose info. Correct? I am not saying that you will not lose info when you're doing 90 to 100. But what would I suggest you is that you bring these 90 to 100 and you bring those 120 to 100 also. Correct? Do you all understand? This is where the concept of this data comes in. Now, this is not just dependent on the size, right? This is just one angle that I've shown you, one dimension that I've shown you. The other dimension might be that there are certain images which are belonging to a particular category, which are coming as 90 only. It might happen, right? Let's say that these images, they belong to cat, dog, and let's say rabbit. It might happen. Now, this is your responsibility as a data scientist to look at from different angles. It might happen that all the images from the rabbit are coming to be 120. Now, this might act as another feature. Correct? Do you all agree? This might act as another feature over here also, that a particular category dimension is this only. So you need to look from multiple angles. But again, I saw that some of you are struggling in understanding this thing, that resizing can only be done from bigger to smaller. No. To smaller to bigger can also be done. Correct? So these kinds of challenges, my friend, they will come to you when you're talking about images. Right? I just wanted to give you a familiarization, a taste of what is going to come next to you. Right? One of my friends says that then should we resize the images? Can't we categorize the images? See, I just gave you an angle, right? Just a thought to think around, that the angle of categorization might also come up, right? This might be true, this might not be true. Okay, one of my friends says, how do we know that the data set has images of these dimension only? Okay, who can answer this question? One of our friends is saying that, Shivam, how did you know that a particular data set will have these kinds of images? How can I know this thing? If let's say my friend, they have given me the images, can't I open up the images and can say that the image dot shape? Can't I do that? I can, right? So I will know this thing. And don't worry, this is coming very early to you guys. This thing of multi-shaped images, this is coming to you very quickly. And I want you guys to answer me this in a just 1 second. Yes, I am saying that this data set is coming very quickly towards you, very quickly. I think in next week, we'll talk about, next to next week, we'll talk about this data set also. Okay, fantastic. So where we were talking about images. Okay, so let's say you have done the images, you have looked, I'll just write it down, check for class imbalance. Right? Images can't be null, but you can check them. How do you check for null data point over here, my friends? You guys were mentioning that check for nulls. How do you check for null in images? Is NA? One of my friend is saying, okay. My friend, okay. So I'll tell you how do you make, you can make a standard check on every image. What you can do is you can check for the minimum value and the maximum value, correct? Of every image. If it is a grayscale image, I know that there will be 0 till 255 and everywhere over there. Similarly, you can do it for colored images also, right? Do you all agree with the statement? Rather than checking for null, I think we should check for what is the maximum and the minimum value of that particular image, because that will give you an idea. If an image has a negative value, then you will open up and check it. What is the issue? If that value has more than 255, that cannot actually happen. Correct? Very good. So you will check for class imbalance. You will check for pixel values. What else? You were saying something else also. Also, outlier detection can't be done over here because I mean, an image of a darker progression will have higher values, brighter will have lower values. So you can't. Anything else that you want to check for EDA? I am giving you an exercise for this week, right? What I want you to do is I want you to calculate the mean pixel value for each image and then plot it category wise. Do you understand what I'm trying to say over here? What I want you to do is, my friend, I want you to calculate for every image. What you will do is for every image, right? You can have a simple pixel value, correct? That is the average pixel value. Do I need to tell you what is the average pixel value of every image? My friend, average pixel value of an image is nothing but this thing. Let's say this is the image that you're dealing with, right? And if you want to calculate the average, can't you just say it like this? So for this particular first image in the extreme, the average value is 35. Now, what I want you to do is figure out, is there a correlation? Is there a correlation which exists? And it might be true that, let's say if the average value of the image is between 30 to 40, then this particular image is of 0 or let's say 8. And you will notice this kind of pattern. Why? Because how is the average pixel value determined? The average pixel value of an image is determined that how the digit is written over there. How much, let's say, pixel values are activated. Correct? Am I correct? Am I correct or not? See, I'll explain it to you. Give me 1 second, I'll explain it to you. What is this average value? This average value means that generally whenever there is an activated pixel, the value is 35. Correct? If I plot this image, plt dot im show and then x underscore train 0 and cmap is equal to gray. Now, what is this 35? See, everywhere else this is 0, correct? Am I right? This is all 0. This is all 0. Wherever it is black, this is all 0. And we can open up this image and see also everywhere this will be 0, right? And what are the values? Actually not 0. If I just show it to you, extreme 0, right? Not 0, sorry. So see over here, it's all filled up with zeros over on the top because it is all black. Top. You can see everything is black on the top rows, and you can see over here all these top rows are black. Correct? Now, the moment it starts coming, the color starts coming, you can see 18, 126, 137, 175. So what is this 35 telling you? The 35 value is telling you that on an average, the spread of this 5 is this much, right? And other than that, this is all 0. Say yes or no, right? So there are two things that you can do. Now, while I am saying this thing to you, this makes sense to me also now. There are two things actually that we can do. One is obviously find the average, right? Pixel value. You can also actually do this thing, count the number of zeros. Count the number of zeros in this particular pixel, in this particular image, right? So what is 0? Wherever it is 0, it means that the digit is not present over there, correct? And please listen to me for just 5 minutes. Drop whatever you're doing. Just listen to me for 5 simple minutes. This is how you would also apply your brains in machine learning also. We are doing the same thing in deep learning. I know I said this thing that in deep learning, you don't need to apply your brains. You don't need to, let's say, apply your features over here. But sometimes it's important to understand that you spend time with data, right? Now, okay, listen to me now. What is this 0 telling you? This 0 tells you that out of the 784 places, how many places it is zeros were found, correct? Or can I say it in the other way, that wherever the area of this particular digit was not present. Now, some of the digits are like this, some are like this, some are like this, right? So their area might be same, but orientation might be different. So what we're trying to figure out is we are trying to figure out the coverage of that particular image. Again, I'm saying this might be helpful, might not be helpful, but it is good to do your exploratory analysis. Do you understand what we are trying to do over here? One of my friends says that now again, it depends on the orientation, which means 6 can also yield the same pixel value. Correct. Yes, it can. And that is what exactly I wrote over here, my friend, some time ago. If I can find my writing, I said the same thing also over here. Let's see over here. I told you that this particular, let's say 35 to 40 average that is coming, right? It might be for 0 and it might be for 8 also, right? Understood? Is it clear? Again, I'm saying this might not be concrete. Again, I'm saying this might be concrete, this might not be concrete, but it is your job to look at this from this angle. One of my friends says, but in images like this, I mean, for 1 will be far different from 8, isn't it? That is what exactly I want you to figure out. See, what is the end objective? Your end objective is to find a differentiation between 5, 4, 3, 2, and 1 digits, correct? My friend who asked this question about this, the means for 1 is far different from 8, isn't it? Why are we using this thing? We are using this thing to find a differentiator that we can feed to our neural network, correct? One of my other friends says, are we trying to find out the outlier images? No, no outlier images. No, that's not what we're doing. But 6 and 9 could have similar means. Yes, they might have. They might have. I'm not saying no, they might have. We are trying to develop a heuristic system across your deep learning machines, correct? Let me show you one example over here. Give me 1 second. I'll tell you why I'm asking you this thing is. Okay. So this was one of the competitions that was happening in 2000. Again, I'm just diverting from the topic, right? But there is this one assignment I was doing some time back, right? It is a Kaggle competition that came out where I had to find the diseases in the leaves. You can see over here. Do you see that a leaf contains these things, right? Now, I could have directly gone and I could have directly made a deep learning model, but I actually went inside these things and I wanted to understand what is actually happening. And I saw that these images have yellow and orange colors, dots over here, and then some brown dots. I don't know if you can see in the second row, first column, these images, non-healthy images, which the label are there. And you know what happened? I went inside and I tried to darken these areas. Now, if you can see, right, I have tried to darken these areas and I'm actually figuring out what is happening over there. See now. And at one point, I go inside and I figure out what is the color range of these values. And I just simply made a model that, if I can figure out this value inside it, without even making a deep learning model, my friend, I was able to achieve some, I think 70, 75 accuracy, right? Now, obviously, I'm not saying that is a replacement for my deep learning model, but when I made my deep learning model, I wrapped this heuristic model also around it so that my false negatives were now being taken care of, right? Or true negatives were being taken care of. Do you all understand what we're trying to do over here? See, this is the same objective that's why we do EDA also. Agree? Today, you might not be able to correlate with this thing right now, but tomorrow you will, right? Please don't leave the habit of EDA. I can tell you very clearly over here today, if you want to become a super data scientist one day, your best friend is EDA. Don't leave him, right? Don't leave him. Okay. So yes, we were talking about images. Let's say we did some EDA. Now what? What do you want to do? In your machine learning terminologies, what would you do? What would you do next? Data selection. Okay, very good. Fortunately, data is already selected for us. Data, the trained data and the test data is already divided for us. Pre-processing. Okay. Pre-processing what now? What pre-processing do you do in your machine learning? Standardize. Okay. Resizing. So resizing, my friend, fortunately, again, all the images are 28 cross 28. So I don't need to resize the images. They are already resized. Our pixel values, what is the range of pixel values? Do you think this is very wide range, 0 till 255? Should we bring it to 0 to 1? It's fine. Okay. How do you decide it's fine and it's not fine? How do you say this thing? Okay. In machine learning also, how do you decide that this feature should be normalized and this should not be normalized? How do you decide this thing? How do you say that this range is, oh, it's very big, it's small? By comparing it with other feature range. Okay. So here you have 786 features and all feature can go in the range of 0 till 255. Depending on variance. Okay. Like for click metrics are in thousands, well important millions. Okay. All features have the same characteristics. 5 to 100 is the standard will be. Okay. So let me tell you, my friend, the answer is in machine learning also, if you have a continuous variable, you don't normalize based on your biases. Never, ever, ever in your life you will do this thing, right? You cannot decide that something has to go with normalized range, or you think 0 to 10 is good, or let's say 0 to 100 is good. No, you and I don't decide this thing. The same problem is coming when your range is 0 till 1 million. The same issue is going to come when you have 0 to 1000 also. It's not that 1 to 1000, 0 to 1000 is a fine number. I can go with it. No, it's also wrong. Correct? This is also wrong. So the generalized number that we have, let me tell you, and based on the normalizations that you do, what are the 2-3 normalization schemes that you have learned in machine learning? One is min-max and the other one is standard scaler. Very good. One is called as min-max. Now, what is the range of min-max? And standard scaler. These are two types of scaling, my friend, and each scaling's job is to make sure to bring data into a range, right? Min-max will always make sure that is in the range of 0 to 1, whereas standard scaler can have anything. Did you notice this thing? Standard scaler can have anything, but it is in the range of mean plus standard deviation, mean minus standard deviation. Correct? Do you agree with this statement? This is very important. See, you and I will never decide that somebody has to go through scalar, or sorry, somebody has to go through normalization or not. Everybody has to go to normalization. 0 till 255 is also a very broad range. What is going to happen is this 255 will get more weightage by machine learning. Because what is machine learning? Or forget about machine learning. What is deep learning? Deep learning is nothing but, let's say, multiplication of some numbers, right? Multiplication of some numbers and then addition of some other numbers, correct? So obviously 255 will get more weightage as compared to somebody like a 1 or a 2 or a 3, correct? That is why we have to bring everybody in the same range. And today we are not going to use any kind of, let's say, your standard scaler or your min-max scaler. Today we will use a very simple technique. Very simple technique is what? Let's say if I ask you, there are, actually, let's write down. Let's say there are 3 numbers. a list. Let's say there are three numbers, 5, 10, and 15. And your job is to make sure that they come in the range of almost 0 to 1. Forget about min-max, forget about standard scalar. Just answer my question. If you have to normalize this thing into a range of 0 till 1, let's say the maximum number can be 1. What is the one thing that comes into your mind? You have to make the maximum number 1 divided by their sum. Are you sure, my friend? Divide by maximum value, divide by 15. Okay, median. What median? Isn't the simple answer is that you go by this thing, a list divide by a list dot max. Isn't it what everybody is thinking? Obviously, it's a list. You can't do this thing. So what I'm going to do is I'm going to say np dot array. This is what we will also do exactly. We will say that we are not going to do any kind of min-max scalar. We will just simply say that we will take our data, xtrain, and we will say xtrain is equal to xtrain divided by 255.0. Do you all agree? This will normalize the data. One of my friends says if minimum is 0 and you divide by its maximum, it's min-max scalar. Exactly. Yes. Exactly. Yes. Yes. That's a very valid point. Do you all agree that by this, what I'm doing is I am normalizing my data. Normalizing data. Okay. Now, most of you might have a question, Shivam. Now the images might have distorted. Correct? And let me show it to you. The data has actually changed. Now it is no more zeros and 255. Now it is in the range of 0 till 1. Correct? In the range. Do you all agree? Right? Now let's try to plot an image. What do you think what is going to happen? If I plot the same image as above, this one, what is going to happen? What do you think? All black remain same. Okay, let's try to run this thing. Same image, blur. It will be the same. Compress, no change, no clear image. Because we have rescaled, we will get same image, no change. It will be depicted the same number, same image, no different intensity, all black, all white. Okay, shift, enter, and you will see there are two things which happens. One, there is this thing over here, and the image does not change. Let me do the same CMap so that you can compare. The image is intact as it is. No aspect ratio change, nothing changed. It is all 5 and like this. Nothing changed. Why? See, I'll explain it to you. There are actually two things that have happened over here. One is that, it should have given you the a warning over here that images can either be in the range of 0 till 255 or 0 to 1. So all the images are in the 0 to 1. I was expecting that some images might go 0.000000, so it might throw error, which is not in this case. Second thing is that the image has not changed even in the tint. The shades have not changed. Nothing has changed. It is as it is, as it is. And why is it? Because the ratio between the adjacent pixels have not changed. And this is why we normalize the data. And this is why we say that the normalizing the data never distorts the data. Now, the same question can be asked in machine learning also that, hey, when you are normalizing my house pricing data, obviously you have changed the data. No. When you are normalizing the data, my friend, the ratio between the data is still intact. And this is what is happening in your case. See, the ratio between 5, 10, and 15. Is it the same between 0.33, 0.6, and 1? Say yes or no. If the images are not changing, why are we normalizing them? Why are we normalizing? My friend, for you as a human, for you as your retina, for you as your brain, this image is rendered as it is. But is this image the same mathematically? Is the NumPy matrix same mathematically? Say yes or no. No, it is not. It is not the same now. Mathematically, the image has totally changed. The matrix has totally changed. If I will take the average of that image right now, will the average be 35? Will the average be 35? The answer is no, it can never be 35 because the maximum number is 1 over 10. Correct? So mathematically, the image has changed. Geometrically, the image remains the same over here. Do you all understand? Because my friends were asking the question that Shivam, this way we have changed the data. I can ask you the same thing in machine learning also. When you were doing those house pricing models, you normalize them. There you never ask these questions. Why? Today you can aesthetically see this image. That's why you are saying, oh Shivam, we have changed all these things. Yesterday, when you were doing machine learning, you could not visualize that data. Then that day you are not asking these questions, right? So my friend, the answer to this question is the ratio between the data never changes, right? If you do standard scalar, if you do min-max scalar, the ratio between the image or the data is still intact and still it is as it is, right? Okay. I can see some of you are saying amazing, very good. Thank you for explaining. One of my friends says scalar multiplication on picture doesn't change anything. For additional changes required, you need to multiply the matrix by other vector. Okay. But if we use standard scalar, will this be a bit distorted? So again, the answer is no. One of my friends says based on the ratio, the image pixels are getting plotted. But what about the colors? 0 is for black, and then shouldn't the numbers be 0 point? Does this be darker and not white? See, my friend, 0 is still black and 1 is still, let's say, the darker point. And that is why this image is getting plotted. This image is getting plotted because of the same thing, because 1 is now representing 255 and 0 is still representing the 0. Correct? Is EDA not included to enrich the images with some common filters such as smoothing to extract or enhancement to rich? No. See, EDA is, you guys are confusing between EDA and pre-processing. EDA's job is only to extract out insights from it. And based on the EDA, we take some actions like pre-processing or let's say feature extraction, those things are there. EDA's job is just to find insights from the data, hidden insights from data. And the same thing applies to your machine learning also. Correct? One of my friends says that ratio is agreed, but when we created our own image and then put different values in the color will change. No, it will not change. Because there also, my friend, you are changing when the scale was 0 till 255. Do it 0 to 1 and then check. My friend was saying that why are we normalizing the images if there is no change? My friend, do you all also understand now that for you as a human, this image is still rendered as the same, but mathematically this image has changed a lot, right? You agree? Very good. Fantastic. Okay, let's say you are into your machine learning world and what you have done is you have done the EDA, you have done the pre-processing, you have done the feature engineering. What next now? Train the model. Okay. Before you train the model, do you want to pre-process your output also? Have you done ever any pre-processing on output? This is how your white train looks like. Do you think we should do any kind of pre-processing over here? No. Okay, fantastic. Okay. Very good. Okay, tell me. Very good, very good, very good. Let's say, okay, I have a question for you. Very good, very good. Data scientists, please come up. Okay, let's say you are working on a machine learning model. And this is like this, that you have some attributes of house, right? And at the end, it is written what type of house it is. Let's say this is a beach house, right? Second one is, let's say, a farmhouse. And the third one is an apartment. Correct. Similarly, you have 3 categories over there, and then you have millions of rows. 1, 2, 3, 4, 5, 6, 7. You have 1 million. This kind of data is there. You have 3 features for houses, like what is the area of the house, the floors in the house, and let's say parking. These 3 features do exist. This is a typical data set. Any issues? Right. This is the input 1, 2, 3. And this is the output given to you. My question is simple. Listen to my question carefully and then try to answer. Will you do any kind of pre-processing on your, or let's say any kind of processing on your output data over here? So let's say I did a label encoding over here. Let's say I'm a real estate person. I don't know what, let's say this machine learning is. So I am saying the beach house, I will call it as 1. Farmhouse, I will call it as 2. And apartment, I will call it as 3. Now this is okay. Do you all agree? This is fine. Now we can send it to machine learning model. Is this a categorization problem or a regression problem? Categorization. Very good. Very good. Can I send numerical numbers 1, 2, and 3 inside a categorization problem? So then what I need to do? Isn't the same thing over here responsible also? Will the same thing not be a problem over here? That you are sending numerical data to your machine deep learning model. How will the deep learning model understand? Okay. And now I'll tell you the answer. Right? I thought you guys will understand when I'll give you an issue. Okay. Let me ask you a question. How many of you agree with this statement? What I'm saying is I am proposing that we do a one hot encoding of this thing. One hot encoding of 5 of all these labels. And sending this kind of data inside deep learning is not correct. How many of you agree to this point? And how many? Actually, those of you agree, it's fine. Those of you don't agree, say no in the chat. Okay, let's see now. I know some of you are confused. What is one hot encoding? I will quickly give you an intro and then we will do. Let's say there is the output field and some of you have, let's say one of this thing is called, let's say, beach house. Other one is called as, let's say, a farmhouse. And the third one is called as apartment, correct? And let's say again, it is repeating. Let's say apartment and again apartment and then a beach house. So how do we do this thing? What do we do is for each output, right? Each output, what do we do this? Sorry, I am not keeping track of chat. Just give me 2 minutes, right? We'll read this thing. And then we'll talk about this thing. Okay, so let's say you have these many options, right? This is your rows. Let's say you have only 6 rows of data. So how do you do this thing? You will go and you will first of all make how many number of options do you have? Let's say the output is written over here. How many options do you have? You have 3 options. So you will write down O1, then O2, and then O3. Okay, so the first one is what? Beach. So you will give this one as, let's say, 1 and everything is 0. Actually, let me remove this. This becomes much more easier. Beach, farm, and app. So is this a farmhouse? No. Is this an apartment? No. Correct. Also, please forgive me when I'm dropping these dots over there, right? Okay. What is the next output says? Next output says that you're a farmhouse. Are you a beach? No. 0. Are you a farm? Yes. 1. Are you apartment? No. Next. Are you apartment? Next row is apartment. So are you a beach? 0. Are you a farm? 0. Are you apartment? Yes, sir. I am apartment. So 0. Next is again apartment. So what will you do? You will say again 0, 0, and then 0. Correct. Third is again apartment. So again you will say 0, 0, and then 0. Sorry, 1. Sorry, 1. Sorry, 1. And then again this is beach. So what you will say, this is beach, 1, 0, and a 0. Okay, right? This is how, my friends, you convert your human understandable English type labels into a machine learning oriented labels, right? I know some of you are getting confused. Shivam, how do you decide the 0 and 1? Now do you understand? This is how simply we decide 0 and 1. Understood? I know some of you already know this thing and then do this thing, but I wanted to just give you a glimpse that this is how it is done. Understood? Fantastic. Fantastic. Now, obviously, you don't need to, let's say, sit down and do this manually, right? Like how I have done. There are certain libraries. How do we do this thing? We just simply say PD dot get dummies. PD dot get dummies. Change third row. Okay. Yes. Sorry. My bad. Thank you. Thank you. Thank you. PD dot get dummies is one of the functions in pandas that can actually help you do this thing. Now, please focus over here. How does Y-train look like? Y-train currently has 60,000 data points, and this is how they look like. Correct? 60,000 data points. The first one is called 5. Now, how should this be converted? This should be converted into 0, 0, 0, 0, 1, 0, 0, 0, 0, 0. Correct? Let me write it down. If this is a 5, it should actually look like this. 0, 1, 2, 3, 4, and then 5, 6, 7, 8, and then 9. Correct? Correct. Do you all agree? 5 should look like this. Similarly, 3 should look like what? 3 should look like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct? And you will see this is exactly what happens. Okay, before I show you, can somebody please tell me what will be the resultant shape? Let's say if we store it back into y underscore train underscore encoded. What should be the shape of this thing? Tell me. Very good. Very good. Sometimes this will be 60,000. And for each number now, there are 10 digits through which we will represent you. Correct? So now if I show you Y train, so if you see, what is the first digit of Y train? It was 5. And you will see now how this is converted. Sorry, I have to write encoded. But I should actually write down both the things. This is what the original number is, and this is how it looks like. You should not write it like this. Correct? Do you all understand, my friends? Give me just 1 second. Can you explain why it is 10? Okay. I think now it is clear when you see it like this. Okay. Okay, so one of my friends is saying why it is 10. My friend, how many options do we have when we are solving the MNIST problem? You know what is MNIST problem, right? Let's say if there is an image that comes out, how many possible answers are there? And especially, see, when you're asking a question, my friend, you should answer it also, please, because otherwise then only I understand, right? Very good. See now, what is the first digit written over here? Can you say it? 5, right? The first is 5. Now see how 5 is represented in one hot encoding. What do we write down? The first digit is 5. Is this 0? No. Is this 1? No. Is this 2? No. Is this 3? No. Is this 4? No. Is this 5? Yes. Is this 6? No. 7? No. 8? No. 9? No. What is the second digit? The second digit is 0 itself. It means at 0 it is 1 and everywhere else it is 0, 0, 0, 0, 0. Do you understand now? My friends, 2, 3 friends who were saying we don't understand. Do you understand now how it is working? Just did X train divided by X train and I looked at, I could see all the values floating point, including the zeros. Okay. So for that, I can explain it to you. Why this happened for you and this might not happen for you is because whenever you define a array, my friend, right? So let's say you define an array like this, np.ones. Okay, before I do this question, right, let me answer what am I trying to say over here. One of our friends has a question and he says, Shivam, no, you are wrong. I did this like this. And this is also giving me correct answer. So my friend, it depends on 2 things. Whenever you prepare let's say a matrix, right? There is an option called D types. And by default, you will notice that this is float in nature. Do you see a dot after 1, everyone? Why this is? This is because this is a float in nature, and yeah, I can show it to you in the help also. That if you don't pass the D type, the D type is given to it as float. You can see over here, if you read this thing, it says D type optional. The desired D type of the array is float 64. Right? You can give it int 88, but the default is float 64. That is why. So your D type for the X train might be, let's say, float 64. That's why it's not working. But if you use it like this, like a integer, this is a integer. And when you divide an integer by an integer, it will yield a integer for you. Do you understand now? Why did I say to always keep divided by 255.0 and not that? Understood? We are doing a modeling because we need to create a system, right? We need to create a model which will take a image from MNIST data set and will yield a digit. This is the objective, my friend. Correct? Yield a digit. So I would suggest you first, let's read about these things, and in next session I'll tell you when to use standard scale and when to use min-max. But I'm pretty sure when you read about them, you'll understand this thing also. Is it a certain kind of AI model? I would not call it as an AI model. It is just a deep learning based model, right? A neural network based model. Correct? Very good. Okay. So where we have done the pre-processing of input. We have done the pre-processing of output. What should we do now? Both the girl and the boy are ready. We should go for the marriage. Correct? We should marry both of them. Right? Okay. So the point here is that we will start with modeling. Exactly. As most of you are saying, modeling, we'll do modeling. Now see, before we go for modeling, right, what I want is, I want you to give me 10 minutes of yours, because then I will explain you softmax. What is softmax? And how will we actually connect those dots that we have done? Correct? Do you agree? So, okay, give me your 10 minutes. We have learned that there are these circular things, right? These circular kinds of things, right? These are called as input. And then we made again these circular things, right? These were called as what? Hidden layers. And then we again made these circular things, Shivam, and these were called as output layers. Correct? I will quickly write it down. This is called as output. This is called as hidden. And this is called as input. Correct. Now the point is, then next, Shivam, you told us that, you know, if you connect these dots, if the inputs are connected to the hidden layer like this, right? And if we perform a affine equation in this thing, right? And what is the affine equation? A affine equation is nothing which can be written like this, that H1 hidden layer is nothing but W11 X1, right? Plus W21 X2 and W31 X3. Correct? And very good. One of my friend very quickly says activation function also. Okay, very good. So we will put it under the activation function also. Correct? And then this will give some output, and we will connect it to the output layer, output layer, output layer, output layer. Correct? Is this clear to everyone? This is clear to all of us. Correct? Okay, I have a question for you. How many neurons will be there in the input layer? Again, please listen to me. My question is, how many neurons will be there in the input layer if you are building MNIST? What is the input to your machine learning model? Please tell me. What is the input feature? What is the input to your machine learning model? I am talking about machine learning model right now. You guys have done machine learning, right? So what is the input to your machine learning model? Features. Very good. What are the features of an image? How many features does an image have in MNIST? Is the answer 784? If it is, then yes, you are totally correct. If it is something else, you are wrong. 784 neurons will be present in the input layer, my friends. Because these many features are there in one image. These many features are there in one image. Okay, very good. Now, my friends, tell me one thing. We were talking about this. All of you remember this beach question, this beach, apartment, and farmhouse question? Tell me one thing. 784. Won't 784 be the input? That's exactly what I'm saying, right? How many neurons in the input layer? Let's say you are building a class categorization model for machine learning, right? and you have three inputs, and let's say you have the outputs like this: beach house, farmhouse, apartment, apartment, beach house. These three options are there. Let's say you have trained the model and tomorrow you are giving it a input feature. Let's say tomorrow you gave it into an input. How many possible answers do exist? Forget about you don't know what is the input, right? Just tell me how many outputs can be exist. Three, correct? Apartment, it can be either apartment, either a beach house or a farmhouse, correct? Very good. Now tell me, if you are working on MNIST problem, a particular digit can have how many outputs? Forget about what is inside the image. You don't know what is inside the image. How many possible outcomes can exist? The answer is 10. So can I say that this particular, again, now I am saying that this particular architecture will have 784 neurons in the input layer, right? This will have 784. And in output, it will have only 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. How many of you don't agree for this thing? Please say no in the chat and I will explain it. First of all, let's talk about that how many input neurons are there, right? Let's talk about input neurons. Input, what is the input to your machine learning model? The number of features, correct? In machine learning world, what is the input? The input is nothing but the number of features that you have. Our image, one single image has 28 height and 28 width, correct? Which means that in total, it has 784 values inside it, correct? So what I'm saying is all these values will become the input parameter for the model. Is this understanding clear to you? This is what I'm saying. I am saying that the number of features of a machine learning model will be equal to the number of elements inside a NumPy array, or let's say the number of features inside a image. Do you understand the input part? Input part is clear? Very good. Now let's talk about output part. Take any random image, any random, forget it is 1, 2, 3, 4, 5, anything. How many possible outcomes it can be? When you roll a dice, my friend, how many possible outcomes can come for a dice? 6, right? Very good. When you flip a coin, how many outcomes can be there? 2. Similarly, my question is, if I take any one random image out of 60,000 MNIST images, what are the possible outcomes? It can be either a 0 or a 1 or a 2, 3, 4, 5, 6, 7, 8, 9, and 9, correct? So it means 10 options are there, correct? One of my friends says 60,000. Why 60,000? I am saying if I randomly pick up any one image out of those 60,000 images, what are the options that that image can be? Only 10, right? Is this clear now? Why there are 10 inputs and 784 outputs? Now, one of my friends says it should be 100 because of one hot encoding. So the answer is no. I'll tell you why. Please see over here. Please see over here, and especially to my friend. Can I say that this one row is nothing but, let's say, one random image that I've picked up? Correct? Now, how many outputs do you see? Count these 0, 1, 0, 0, 0, 0, 0, 0, 0, 0. Count them. How many are there? 10. Are there 100? No. Right? A particular image can have only 10 options. And that is what we are saying. Correct? I'll explain you more into details, right? I'll explain you more into details now. Is this clear to everyone? What is input and output? Because if you don't understand this thing, why 1? Output is equal to 10 plus 1, 11. 1 for inclusive. System should account for this thing. No, it will not account. So it means you are saying when you flip a coin, it should give you 3 answers: head, tail, and something else also. Is this true?
Let's have a quick quiz question, guys. And the question is, which algorithm is commonly used for training deep neural networks? And your options are k-means, random forest, gradient descent, or principal component analysis. Please mention your answers in the comment section below. Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with iHub Divya Samparka, IIT Roorkee and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence, and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
When you flip a coin, my friend, are there 3 possible outcomes? No, the possible outcome is only 2. When you roll a dice, are the options 7? No, only 6. That is exactly what is going to happen. When you have a MNIST image, it will have only 10 options. Why will it have 11? Right? Okay, now please, all of you, please focus here. Please, 2 minutes. Forget about what previous things are. Forget about what we have talked about right now. Please focus here. This is very important. When I say that we have 10 neurons in the output layer, my friend, it means that this one is going to represent 0. This one is going to represent 1. Similarly, this 2, this 3, this 4, this 5, this 6, 7, 8, and 9. Correct? Now, every time, let's say you are sending a image like this, right? An image like this is sent. So what is happening, my friend? Your model will regress the probability of what is this thing. Let me first of all ask you guys, please do not write any question on chat for 10 minutes. See, I always give you time for questions. See, when you type in question, I also get digressed because I have to look at you guys. You guys also miss what I'm teaching right now, and then you go into the past. Just for 10 minutes, please. Right? Just for 10 minutes. Please see over here. My friends, whenever you send an image, right? This image like this, 7 image, right? This goes inside to your model like this, right? 784 things. Then they go inside the hidden layer, and then they go inside the output layer. Now, what is the output layer telling you? Now, as all of us can see that this image is actually an image of a 7. So technically, only 7 should be activated, all of them should not be. But that is not what the case is. Neural network actually regresses the probability of this image being 0, this image being 1, this image being 2, 3, 4, 5, 6, and similarly all these things, right? So it tells you the probability that, see, based on my learning, I think that this image is, let's say, 0.01% 0. 0.2% is 1. 0. Let's say some percentage is this, right? So it will give you probabilities over here. We as a human will say that whichever is the highest probability, we will take that one, right? Let me give you an example. Let's say this model says that I think that this is 80% probability, right? This is 80% probability that this is a 7. I told you guys no chat for 5 minutes, please. This is, let's say, 80%, this is 7. And let's say this is 0.01, 0.02, 0.0 some 4, 0.04. Again, right, we'll fill all these numbers over here, some 0.000, right? And let's say this also looks as a 4. So this is 0.1. It means 10% probability. It also looks like a 4. Right, so I'll fill up these numbers just randomly. 0.00003, 0.002, and 0.001. So after multiple iterations of phase 1, 2, and 3, after multiple iterations of feed-forward network, backpropagation, feed-forward, backpropagation, my friend, the model will regress this thing that, hey, this image looks like to me as a 7. Why? Because I have the highest probability. So what we will do, we will pick up this particular digit as our answer. Right? I'll explain again. What is happening is we take this image called 7. This 7 image has 784 different inputs. We will send these inputs. They will go inside the hidden layer. They will do their affine, then they will come to output. Now in output, we have a special device. This special device, actually what it does is, it actually regresses a probability in the range of 0 to 1. And these probabilities are nothing but that whether this digit, whether this image that you have sent is matching to this particular neuron or not, right? Now, who is responsible for this special thing? Is our friend called softmax. Softmax. Now, softmax says a very interesting thing. Softmax says that I am an activation function. I am an activation function, and I am generally applied in the last layer of categorization problems. Let me repeat again. I am generally applied in the last layer of categorization problems. Now, why is softmax so smart? Why is softmax so, how can softmax do this thing? See, softmax is not just converting them into probability. Softmax is also making sure one more thing. Softmax makes sure that if you add up all these probabilities, if you add up all these 10 different probabilities, my friend, they will sum. If you take a sum of them, they will add up to 1. Right? Now, why this thing? You might ask me a question, Shivam, why is this thing necessary? Right? Why is this necessary that you have to do? Okay, tell me. Is this probability better 70, or is this probability better, let's say 70? 1 and 75. You can't compare them, right? Until and unless I tell you that they both the numbers are, let's say, on the basis of 100, then you can decide that, okay, 75 is greater, right? This is why, my friends, we need to normalize these into probabilities and make sure that when you take a sum of them, it is equal to 1. It means the total confidence is 1, and whichever is shown the maximum confidence, that will be taken as the answer. Now I'll take a pause, and now I will take your questions. Tell me, do you understand this thing now? What is a softmax and how is it doing this thing? And this thing is actually helping you in understanding one more thing. See, obviously, when we send this image 7 over here, we are understanding that this is a 7, but we also know this thing that which is the second highest probability, where it is getting confused, right? So let's say if I send a image like this, like, let's say like this. Now, it might say that 6 has the highest probability and 0 as the second highest probability. It means the model is confusing between 6 and 0. This time the model has won the battle and it is correctly predicting it as a 6. But for tomorrow, for your future understanding, you will know that the data is somehow mixing of 6 and 0s, right? Do you all understand now? Softmax is solving the probability? Yes. What happens when we get both as 0.8, 0.8? You can never get both as 0.8, 0.8. Why? Because the sum has to be equal to 1, my friend. So if you take both as 0.8, 0.8, right, that becomes 1.6, which is not true, right? Softmax will always make sure that the sum is equal to 1. Because it is doing such a nice job for you. That's why you use softmax, right? See, ReLU is a very blindfolded activation function. It will give you any number greater than 0, correct? So will that work for you? No. Can you choose sigmoid or tanh? They will always give you numbers in the range of 0 to 1, right? Actually, tanh will give you negative numbers also. Can you have negative probabilities? No. That is why this particular activation function came into picture, which said that I am not just converting them into probabilities, I am also converting them into measurable, let's say, probabilities, right? So while we were talking about activation function, my friend, do you remember I told you that we will generally use ReLU for images because images do not have negative part to this thing, and softmax and tanh has a probability of giving us negative numbers. So ReLU actually makes sure two things. One, that it does not regress as negative values, and you will notice that most of our learnings, they come from research papers, right? So you will notice that all major vision models that are made, right, they are made with ReLU activation function. Imagine pie chart for those who are having difficulties. Okay, my friends, in mathematics over here and in statistics, we never write like this 80%. we always write 0.8 to denote this thing. 0.8 is called as 80%, right? We never multiply it by 100 over here. If this is new thing, it's totally fine. I'll tell you. So generally in probability world or statistics world, we never multiply it by 100 and then put a sign over here, right? We just simply write 0.8 and we say it's the PCT. But chances are getting of 0.5, 0.5 and rest is 0. That's a valid case. Rest cannot be 0. That's what I'm saying, right? It is up to 7th decimal, 9th decimal digit. That cannot happen. But in your case, let's assume you are saying that two numbers are matching over there. So it will give higher precedence to one of them. And then it will give you. If the highest probability level is tied by two figures, okay, same question, okay. I've given this one. How one output neuron maintains the total probability ratio individually in each neuron to sum as 1 for output. Very good. So, okay, one of my friends is saying how is, let's say, actually, let's say, softmax working on this thing? Very good question. See, this is a very interesting question. My friend says, how is softmax able to do? See, softmax is nothing but a very simple mathematical equation, right? It is e to the power summation of e to the power x. If I will show it to you, activation function Wikipedia page, this is what it is. Those of you who are from mathematical background should appreciate softmax. And those of you who are not from mathematical background, they should write a function for this thing. What is this thing? This thing says e to the power x divided by summation of e to the power x. Your coin flip will always tell you either a head or a tail. Why? Because there is a contract between you and the coin flip that the coin flip has only two options. It can be either a zero or a head or a tail. Similarly, MNIST has done a contract with you. If you are saying that no, Shivam, I'm trying to build a real world use case outside of MNIST, then yes, it is required, but not over here, my friend, right? Because how will the model learn about this 11th output that you're saying? Tell me. How will the model learn over there? If there are no learning examples in the data set, how can it learn? Correct? If you are from tech world, right, you know that everything is a contract, right? If you are from the tech world, right, that's true, right? Like you are saying coin flip is different. No, coin flip is not different. Coin flip also has a contract with you, which says that coin can have either a head or a tail. Similarly, MNIST data set has also done a contract with you that it will give you 0, 1, 2, 3, 4. Correct? Even in an unbiased coin also, my friend, it will only have a head or a tail. It does not bring in a third aspect to it, this thing. Akash, that's a very good point. Unbiased coin says that it is biased towards a head because it's a heavy side. But does it say that it can bring in a third category, like a head, tail, and something else? No. Let's say if somebody passes a very, let's say, non-random, let's say they pass a random image. Your MNIST cannot solve this problem, and I'll tell you why. Because MNIST, this machine learning model is not trained on that thing. Correct? Do you agree? Instead of a digit, there are 10,000, 100,000 things that this image can be. Correct? How will you teach that thing to your model? Are you providing any samples to your model? Let's say somebody took commerce. Right? They are studying economics, they are studying business studies, they are studying mathematics. Can you ask them physics question in their paper? The answer is no, right? That is what the point. I am going to write the y actual for this thing. For this particular image, like this, right? The y actual is 0, 0, 0, 0, 0, 0, 1, 0, 0, and 0. If I write it like this, is this correct or not? And I think my friend who was saying that there should be 100 options. Is this clear to you now, my friend? Why there should be only 10 options? For this particular image, my friend, like this, which looks like a 6, the options will be like this, where in front of the 6th neuron, or actually the 7th neuron, it will say 1, and other than that, every place it will say 0. Now, what is going to happen? See this interesting thing now. Because of softmax, when the very first time your model is predicting something, now obviously when it is going for the first time, it will, let's say it says 0.1 over here, 0.1 over here, and 0. Let's say 1 over here again, and let's say this is given 0. Let's say 6. Just again, just a random example and take, and then similarly over here. Now this loss, my friend, remember we have talked about loss. What was loss? Loss was y predicted minus y actual. Now this loss is, my friend, not taken at a sample level, but taken at a cell level now. Do you all agree now? What is happening? We are saying, the machine learning model says that, hey, listen, my friend, you neural network, listen to me now. What is happening over here is, you are saying that this is equal to 0.1. No, this is actually 0. You are saying this should be 0.6. No, this should be 0. And you are saying this should be 0.03. No, this should be what? This should be 1. So the error is calculated at all the 10 levels now. Do you understand? So now your loss will also change, and it will not just be like this yp minus ya to a whole square. This will become into something called as cross entropy loss. It means that we will calculate this loss at all the 10 levels, for 0, for 1, for 2, for 3, for 4, for 5. And that is called as categorical cross entropy loss, which is nothing but simple, something like this: y log y plus 1 minus y log y, log 1 minus y. And I will explain you more into details, but I just wanted to give you an idea what two things will change. One is this softmax, and second thing is your loss will now no more be a simple loss, but it will be a categorical cross entropy. First of all, did you understand the concept now? Why we went from a simple ya minus yp to a simple categorical cross entropy, or why did we move over there? The simple question over here. Do you understand that logic? First of all, very good. Now what we are saying is, we are saying that these losses, right, the range of yp and ya could be anything. Do you all agree? Y actual can either be a 0 or can be a 1, correct? Similarly, your y predicted can be in the range of 0 till 1. These are decimal values between 0 to 1, correct? Understood? One thing that has changed. Two things that have changed. One is that now for each image, there are 10 options, and each option has a certain limit or a certain range. Very good. Very good. Now let's keep this topic aside. Now, can you please tell me, why do you take a log? In your machine learning, you might have taken some features, you might have taken a log of those features. Why do you take a log? Very fundamental question that I'm asking to you. This is how a graph of log looks like. This point is 1, and right now you might say that, Shivam, this point over here is a 10, right? And this point over here might be, let's say, a 20, right? But this number have changed over here, and I will show it to you by example also. So what is log doing over here? The log, my friend, is actually takes very large values, right? And dampens them and saturates them. Very good. It saturates those values, right? So if you take, let's say, very big values of, let's say this is 100, right? So you know what has happened? 10 on a base of log of 10, it is 1, and this is 2 only. So your x-axis has moved from 10 to 100, but your y-axis has moved only from 1 to 2. And even if you take 1,000 number, this will only be 3. On a log base of 10, again, I'm saying log base of 10, this is how it is. So your x has moved from 10 to 100, 100 to 1,000 it has moved, but my friend, on the y-axis, it has only moved from 1, 2, and 3. Do you understand now what log is doing? Log, we only do log transformation where we have, let's say, a column which can be of very high ranges, right? I'll give you an example. Let's say you're working with house prices. Now, some houses in New York can go up to 230 million, 250 million, 240 million. But whereas, let's say, if you go on a suburban area, it might come to 1 million, it might come to, let's say, 500,000 also. And if you go in the suburban areas of Texas, right, there you might get houses in 50,000 also for the same square area. For the same square area in 60,000, 50,000 also, correct? So for the same square feet of area, right, the house prices are very high. So the machine learning model now get confused, right? It says that everything is same, that you have the area same, you have the bedroom same, and how is the pricing different? So sometimes, min-max scalar is one way to damp it. Standard scale is one way to damp it. Log is also one of the data transformation techniques. We use it only when we know that there are certain very high values and certain low values also. And those high values are not anomalies. They're not anomalies. They are true values. And they do exist. Now, this is why we are saying this thing. Okay, understood. Now I will take back to you that particular picture. Actually, let's not take to that picture. Now let's write down what is categorical cross entropy. Now, categorical cross entropy says that, let's say if your y, so let's say if your model is, let's say, saying something as category A as the answer. Now, your job is not just to tell it that, hey, listen, you are predicting it as category A, but actually the answer is category B. Let's say the answer is category B. So your job is not just to teach this model that category B is the correct answer, but also to teach it that this is not category A and not category C. Correct? So this is our job to make it understand. This is why cross entropy model comes in. Cross entropy says that y log y. Y log y is a kind of a error calculation that we do. Similarly, like what we did, remember we said that yp minus ya is not one of the best ways. We should take a square of it because then we are penalizing more. Here also we take a log loss. This is called as log loss. Log loss. Log loss is also one of the ways to tackle this thing. This says y into log y plus 1 minus y log y. Now, why are we doing this thing? See, again, as I told you, let's say you're flipping a coin, right? And the model says this is a head, right? So our job is to tell it, no, it is a tail. First of all, understand that this is a tail. This is the part where you're telling it that this is a tail. And this is the part where you're telling it that this is not a head, right? So we are teaching both the aspect of this thing to our model. We are penalizing the model not just because it is a tail, but we also want you to understand that this is not a head. This is called as categorical cross entropy, my friends. Do you understand this thing? This categorical cross entropy will now be applied to every an output neuron in your MNIST, right? So you will have 10, you will take an average of it, and then it will be done. The equation is applicable to 2-class output to every neuron, because every neuron, my friend, if I go back very quickly, I know it should not take time, but let's go quickly. Okay, here it is. See, now at this point, you are trying to teach it two things. First of all, that you should not be 0.1. You should be 0. There are two things that you have to teaching over here. That's what the log loss is doing. The log loss is, first of all, penalizing it for not being 0, and then telling it that 0.1 is also wrong.
Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with IHUB Divya Samparka, IIT Roorkee, and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence, and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
Okay, so the very first thing that I remember was to collect the data, right? Data collection. Okay, so I will quickly make X train, Y train, X test, and Y test, and we will say tf dot keras dot data sets. So fantastic thing. Let's quickly check the shape of X train and Y train. And what next should we do now? We have 60,000 images of train, 60,000 images labels, and 10,000 images for testing. Right? What should we do next now? Data collection, then what? This we have done with respect to. Okay, very good. We will pre-processing. Very good. Pre-processing. Okay, so let's do it for input first of all. So for input, what kind of pre-processing do you guys suggest over here? Because the pixel values can go from 0 till 255. The range is very wide. And you all are proposing that I should do what? Standard scaler. Are you sure? Can't I just simply do a 255.0 normalization? Very good. Very good. And do I need to do any kind of pre-processing for output also? One hot encoding. Very good. So let's write it down. Normalization. And let's write it down. One hot encoding. Y underscore train is equal to y pd dot get dummies. Correct? Y underscore. Correct? Let's quickly check if something has changed. The X train shape and the Y train shape. So X train shape should not change, right? Because technically we are not changing the shape. We are rather changing the content inside that shape. But for Y train, what is going to happen? For Y train, these 60,000 labels that we have, each label will now have 10 dimensions. Correct? Agreed? This we have done last time also, but again, everybody understands this thing. Line number 4, line number 5. In line number 4, what we did two types of operations. For input, we did normalization. For output, we did one hot encoding. Correct? Okay. In the input one, what we are saying is we're just saying that whatever pixel values that you had, now those pixel values will be changed. So the shape of the content is going to be the same, but the content inside that array has changed. And for Y train, the labels that you had originally, 1, 2, 3, 6, 7, 0, 9, 5, right? Those have changed now. And each one has become 10 array long, right? 10 dimension long array where it will be activated only for that digit, which is the correct answer. And for every place else, it is going to be 0. Understood? Very good. See, I'm not going to repeat that again because we've already done that, but all of you understood. Again, asking anybody, any question? Very good. Fantastic. So what now? We took the data, we did this thing, we saw, let's say, everything. Now, next what? We should go to modeling. Very good. Okay. Now, before I start modeling, how many layers have we talked about? We have talked about one hidden layer and one output layer is for sure. Correct? Do you all agree that 2 layers are confirmed? Input layer and output layer. Now in between we have hidden layers also. Correct? Now my particular question to you is, what is the input? How many number of neurons will be there in this neural network? So again, what am I asking you? Let me tell you that let's say this is a kind of a neural network system that you see in front of you. Right? So on the extreme left-hand side and on the extreme right-hand side, what are these? On the extreme left-hand side, this is the input layer. This is the output layer. And this one is the hidden layer. Correct? These are layers collectively, right? Now, how many neurons or how many dots should they contain inside them, right? These circles, dots, pairs, whatever you want to call them. I call them neurons. How many neurons should be there? So let's talk about the very first layer, which is the input layer. So who, my friend, can tell very quickly, and again, we have done this thing last time also, how many number of neurons should be there in the input layer? 784. And can somebody very quickly tell me why 784? Very good, because it is the image dimension. An image is 28 height, 28 width. It means that image contains 786 pixel values. 84, sorry, 84. Is this correct? Is this Is this clear to everyone? Now, can you please tell me how many output neurons will be there? 10. Now let's come to the third one, which is the hidden layer. Okay, before I write this down, I'm going to write down L1, L2, and L3. Now, what does this L1, L2, L3 means? Nothing, simply layer 1, layer 2, layer 3. Correct? Now, how many neurons should be there in the hidden layer? How many neurons should be there in the hidden layer? This is one question that we don't know, right? I mean, we know for sure that how many will be in the input, correct? We know for sure how many there should be in the output. Now, some of my friends are saying 784 into 10. We don't know. This can be anything, right? This is a hyperparameter. Very good. As one of our friends says, this is a hyperparameter, my friend. Can you, by just seeing the data, can you decide that how many number of trees do you want in the random forest? Can you guys tell me, just seeing by the data, that how many number of trees do you want in the random forest? The answer is no. Shivam, we don't know. This is an iterative process, correct? It can be fine-tuned. Very good. It's an iterative process, right? You start with something very reasonable and then you start moving it. That is why the name is there, fine-tuned. It means you tune that particular parameter in such a way that you get minimum losses or maximum accuracy. Correct? Okay. So this, what I was telling you is that this L2 layer, this hidden layer is a hyperparameter we don't know. So what will we do now here? What will we do now? 784 and 10. So what should I take? So see now, I'll tell you how to make this system. Now there are two kinds of, let's say, networks that you can make. One is like a opening up kind of a layer, and then other one is a, let's say, shallowing down kind of a network. What do I mean? See. So we are saying that we start with 784 neurons, right? And we have to drop them till 10, correct? You have to start from 784 and drop till 10. So what we are suggesting you is that this should be in somewhere middle. This number should be somewhere in middle. Now it can be anything. Again, you can choose anything, but what I would do is, I would suggest is to go with any number which is in the form of 2 to the power n, right? Now, most of you are thinking, what does this mean? It means any number like this, 2, 8, 16, sorry, I missed 4 in between, 4, 16, 32, 128, 512, 1024, right? So what I'm suggesting is that pick up any number which is in between, which can be represented in the form of 2 to the power n. Now I know most of you are thinking, why Shivam, why this new thing? See, because what did we understood while we have done all these things? When we did neural network from scratch, right? We just made a single layer neural network. What we understood one thing, that these are nothing but just, let's say, matrix multiplications. Do you all agree? Let's see what is happening in these neurons. They are just a bunch of neurons, right? And they are doing multiplication, addition, activation, multiplication, addition, activation. Correct? So what I am suggesting is that because of this complex matrix multiplication, when you take it in the form of 2 to the power n, the computation becomes less for you. The computation becomes less for you. That is it. See, again, I am not saying that a number 100 will not work over there. It will definitely work. It's just that there is a notion of taking 2 to the power n so that the computation is taken less. Correct? So, okay. So now what would I do? If I would have been in your place, I can fill any number in between 174 till 10. But there is one more thing to remember, that if I put this number is X number very high, my number of weights and biases will also increase. Do you all agree? Let's say if I take this number X as 500, can you please tell me how many weights and biases will be there in between these two layers? This layer has 784, this layer has 500. Very good. So can I say that the number of weights is 784 multiplied by 500? Correct? So if I reduce this number X, right, my number of weights are reduced. So it means my model is less complex. Correct? But you might say, Shivam, then let's make it 11 simply. Right? If you want to make it very less, then see, We don't want to make it so less that the model cannot learn from those parameters also. Correct? Do you understand? That we have to bring this number somewhere in between, right? We have to fine tune it. Do you all understand? This number should not be very high. This number should not be very low. So what I will do is, right, just for the sake of this particular example, and if I have to start, right, because I can't go very low, I can't go very high. So what I'm doing is I will just take this number as 128. Yeah. Exactly. I will take it this as 128. Now, because I'm taking 128, it's the smallest, I mean, I could take, right? I mean, I can go more low, but I'll just go with a middle in between number. My weights are not so many, so that the computation is also not very high. Somewhere in between. Correct? And let's see this thing. So I am proposing we will go with 128. Very simple thing that I just told you. That see, we need to find a middle number. Now, I am sure that some of you might think Shivam take a 512, or some of you might say that Shivam takes 16 also, which is totally fine. You can start with that. But I don't want to go with a very high number and increase my number of weights and overdo my capacity of the model and then overfit it. And I don't want to take very less numbers and underfit also. So I'm taking in between. Again, this is not the correct number. We don't know this correct number, right? Do you agree? This is just simple ANN? Yes. The number of neurons in hidden layer can't be larger than input layer. No, there is no such rule. It can be. You can make. See, my friend, the question is, can you prick a balloon by a sword? The answer is, yes, we can. But is this logical? To prick a balloon with a sword? The answer might be no, right? I mean, can you prick the balloon? Yes, definitely. You can burst a balloon by a sword. But is that practical? Is that you would do in your day-to-day life? The answer is no. That is what exactly I'm saying. That can you make a number larger over here? Yes, you can. You can. There is no problem. This model will, let's say, allow you. The only thing that you need to see is that how is it reacting to the accuracy part. 256 is like killing a fly with a machine gun. Okay, right? So do you all understand now what we have done is I just simply gave you two things, right? First is that we are making a narrow down option. And again, this might work for you. This might not work for you, right? For some people, you might come to me and say, Shivam, I did this, we did this, features experiment, and I saw that 300 and some 24 numbers working for me, which might be true, right? How do we know 128 is not machine gun 2? Because we'll check this with the parameters. How do you check if it is underfitting or overfitting in machine learning? You make the model and then you test it on the test data or validation data, correct? The same thing we'll do it over here also. One of our friends says if dimensionality required to be increased, then we should increase the number of neurons. See, dimensionality is not increased by number of neurons. Who is responsible for increasing the dimension? Who is responsible for increasing the dimensionality of data? Do you remember that image that I showed you where you have concentric circles, but concentric circles were not giving me a linear answer? So we increase one dimension. Bringing in non-linearity in the data, increasing the dimensionality and making it into a single range. Who is responsible in a neural network for all these things? Activation function. Activation function is a function that is applied after affine equation, where we say that you are responsible for increasing the dimensionality, introducing non-linearity, and decreasing the range, or let's say fixing the whole data into a range. Do you all remember? Is it all gone? ReLU, TANH, sigmoid. Then there was a special activation function, softmax. Abba, don't do these things. Okay. One of my friends says we are finding the right formula, y is equal to mx plus c, which connects input and output trace. Yes, exactly. Okay. So let's now build a model, right? I now want your undivided attention, my friends. Please, right? Otherwise, this is going to be difficult. See, we have learned the theoretical part. Now we will do the practical part. Now I will show you The whole theory that you have learned, the whole phase 1, phase 2, phase 3, see now how magically that can be written in just 5 to 6 lines of code. Okay, so we have decided that input layer 784, hidden layer 128, and output layer 10. These are all fixed things, right? So now, okay. Now all of you, please focus over here, right? So we are asking Keras, we want to make a DL model, right? So Keras says that there are two ways to make a model. One is the functional way, and the other one is the sequential way. Now, what are these two ways? Very simple. Actually, let me put it sequential on the top and functional on the left. Let's first of all understand sequential. Sequential, nothing. It means that, whenever I am putting a layer, this layer will talk only to the next layer. This will talk to only this layer, right? And if there is a next layer, this layer will talk to this layer only, correct? And then this layer will talk to this layer and then talk to this layer, right? So it's a sequence. It means nobody can, let's say, just jump these things and go over there, correct? Sequence by sequence. And all of us have seen, let's say, we have made those diagrams. Remember, we have made these diagrams like this. And you have always noticed that I have connected one neuron in one layer to the next only. I have never connected input directly to the output, correct? We have never done that, right? So what is happening is we are saying that, hey, listen, we will make a sequential model. Sequential model means that L1 layer can only talk to L2 and L2 can only talk to L3. It means L1 can't directly talk to L3. It means there is a sequence that we will define and based on that it will work. Correct? Now what is functional? Functional, as I told you, that sometimes we want something called as skip connection. Skip connection. Skip connection means sometimes you want, and I will teach you some architecture where you directly want to talk to L3. Or let's say you directly want to talk to a L4. Right? Those kinds of network do exist. Right? So as of today, and not just today, right? I think for next 2 weeks, we will focus only on sequential. And then later on, I will also teach you how to make we will together look how to make a functional model also. Understood? Okay. So we will go to Keras and we will say, Keras, buddy, I want to make a model. Now see over here, please focus. Keras is one of your best of the best friend, right? See now, the Keras library is arranged in such a simple way that, see, you just say keras.models and you will automatically see that all the options are available over here. So there will be something called as sequential model. And done. This will create a sequential model. Create a empty sequential Keras model. Now what we'll do is we will add our first layer. Is it fine now? The font size? No, I can't see. Okay. So we are adding the first layer. Now, how do you add a first layer? You say model.add directly like this. Model.add. Right? And then we will say tf.keras.layers. All the layers are arranged inside this keras.layers, right? And we will say we want a input layer. We want a input layer like this. Now, what is the input that you guys are sending over here? What is the shape of the image that is going to come into this thing? 28, 28. Correct? So I am telling my model that, hey, listen, model, I am going to send a image to you, which is going to be of the shape 28, 28. Correct? Right? Okay. Now, my friends, focus over here, right? Very simply focus over here. Whenever I have drawn this kind of layer architecture for you, right? Keras architecture, I have simply made a model like this, right? That the input layer should look like this. Correct? Can I say this is one dimensional? Correct? This is one dimensional kind of a structure that I have made. And you are passing an image which is a square image like this. How can you pass a square image into this 784? How can you pass a 28 cross 28 two-dimensional image into this 784 1D lookalike? Series, reshape. Some people are saying stack features, flatten automatically, cross connection. What will we do now, my friends? Reshape. So, but how do I reshape? I mean, how do I do this thing? So for that, my friend, please very carefully see over here. The answer to this particular question is that we will flatten up this image. Now, what is flattening of image? Flattening means that because this kind of structure is a one-dimensional structure and we have to send a 2D image, we can't send it, right? So what we will say is, we will say it like this, that, hey friend, listen, please cut this image. We will cut this image into columns like this. Column 1, column 2, column 3, column 4, 5, 6, 7, 8, and column 28, correct? We will have 28 columns. Do you all agree? And now I will put one column 1, column 2, column 3, column 4, column 5, and then column 28. Will it become like this? Do you all agree? 28, each column has 28 cells, and now you have 28 such columns. 28 cross 28. It means 784. Do you agree now? This concept is called as flattening concept. Understood? My question to you is that every time, whenever I have, let's say, drawn a neural network for you, I have drawn it like this, correct? This is your input layer. Do you all agree? But the problem is that the image that you are sending is a 28 cross 28 image. It is a 28 cross 28 image. So how will you send a 2D 28 cross 28 image inside this particular, let's say, one-dimensional array? How will you achieve this thing? Especially my friends who are facing issues. Do you understand the issue now? That the input layer that you are expecting is that you are building is expecting a 784 neurons, whereas the image that you're entering is 28 cross 28. It's a 2D image. So our responsibility is to make sure that we somehow convert this 28 cross 28 image into 784. Correct? Now, how do we do this thing? Right? What we are suggesting is that you go and you divide this image into columns. Column 1, column 2, column 3, column 4, column 5, column 6, and then column 28. Correct? A 28 cross 28 image will have 28 columns. Do you all agree? What I'm asking you is that you go and arrange these columns like this. Column C1, and then put the column C2 behind it. And then column C3, C4, C5, C6, and then ultimately C28. Can you all do this thing? Correct? It means you have 28 columns now stacked one below the another, and each column has 28 elements. Correct? C1 is a neuron. No, my friend, C1 is the column. Column 1, column 2, column 3, column 4. Okay, so who is responsible for this particular thing? Who is going to help us to achieve this thing? For that, my friend, we have a thing called flattening layer. Right? Flattening layer. We will just ask Keras. I told you, right? Keras is our best friend. Keras can do almost anything. So what we are saying is that, hey, Keras, listen. The image that I'm sending my friend is actually a 28 cross 28. Will you be able to flatten this thing? He will say, yeah, why not? Sure.
Keras will say, why not? Sure, I'll do this for you. I will flatten up this 28 cross 28 image into 784 for you. How is system will be able to read and arrange these columns? Why? You can do this thing, right? You can just take a array, put all the columns one behind another. Can't you? Right? If the image is not just single channel, let's say it was 120, let's say it was 28, 28, 3. So what is going to happen? 28, 28, and then 3. So what is going to happen is, my friend, this will flatten up into a very big, let's say this kind of array, and it will become 784 into 3, which is what? Can somebody please be a mathematical giant and tell me this is what? 2, 4, 3 are 12, 1, 8, 24, 5, 2, correct? What is this? 2, 3, correct? 2, 3, 5, 2. So 784 into 3 is 253. So this will become, first of all, you will arrange all the red, then the blue, then the green. Correct? So it is not that the flattening is only done for grayscale. It can be done for RGB images also, my friend. That was a very good question, and I think, did I answer your question, my friend? Input should be specified as 28, 28, 3. Is that correct? If it was 28, 28, 3, do you think that the MNIST images are 28, 28, 3? MNIST images are not RGB. They are grayscale in nature, right? That is why I have not written 3 over there. In case of RGB, yes. In case of RGB, you will write a 3 over there. Okay, understood? Everybody understood? Just 2 things. First of all, we made a model and we asked our Keras that, Keras, hey, listen, buddy, we have an input image coming that is called as 28, 28. It says, okay, fantastic. But then you realize that, okay, I can't send this a square image, right? I have to make it like a big, a rectangle, right? A very big rectangle with just only one column. So then what do? You make it column major and you flatten this up. Again, you just say flatten and it will do this thing for you. Correct? I'll just give this layer a name. One of my friends was asking, what is this name? So my friend, this naming is nothing, but this is a layer name. So you can layer each you can name each layer also. Correct? So I am saying this is input layer, this is flattening layer, right? Now what has happened? We have made the input layer now, right? And we have made the flattening. So now 784 is available. This 784 thing is done, correct? What is the next thing? We need a hidden layer. We need a hidden layer. So what we will do, we will say model.add tf.keras.layers. Now all of you might be thinking, Shivam, we will now just write down hidden over here, correct? No, we don't need to write down hidden. We will say dense. The name is called dense. Dense means that any layer which will connect to the right next layer, that is called as a dense layer. So you don't need to call it as hidden. It is just dense, right? Now, what is the first thing that a dense is asking you? The very first thing that a dense is asking you is that how many number of neurons do you want, right? How many number of neurons do you want? See, if you want to learn about any function in Python, not just deep learning, and if you are in your Jupyter notebook or Colab, just put a question mark in front of it. Put up a question mark and it will open up this kind of a help for you. Correct? It is going to open up a help for you. Now, the very first thing it tells you, my friend, whenever you're adding, let's say a layer, the very first thing that they're asking you is that how many neurons do you want, or how many units? Units and neurons are the same thing. And then they're asking you is what kind of activation function do you want? So let's say how many neurons, how many units do we want? We will say that we want 128 units, right? And what activation function will we use? Activation function we will use over here, tf.keras, because this is images. I told you we will use relu over here. So you can see, where do we find activation function? That is again in Keras. that ReLU as a activation function is the only exception function which says that if you are a positive number, be my guest. If you are a positive number, be my guest and I will return you as it is. I will not change you. But if you are a negative number, you will be made 0 over there. Correct? Remember? And then I told you, my friend, that not recently, but let's say lately, we have been using ReLU as our main activation function in middle layers. ReLU is non-linear in nature. I am saying that ReLU is non-linear function. This is how a ReLU looks like. Do you all agree? That for any, it will return x and it will return 0. It will return x if x is greater than 0, and it will return 0 if it is less than equal to 0. Now, how many of you think that this is a linear graph, right? Most of you might say, Shivam, that's a straight line. It's a linear graph. Correct? No, it's not. It's not linear. It is not linear. Is this still linear? Do you see? The problem is that this half part of this linear function is hidden in this x-axis. So we think that this is a straight line. But is this a straight line? Is this a straight line? The answer is no. It's a trick question. Sometimes it is also asked in some, not interviews, but some now people have started using these coding websites, right, where they take your interview. So and I've seen in some of the MCQs, they're asking you this kind of question. That is ReLU a linear function? And most of people like you who don't revise say, yes, it's a linear function, right? The answer is no, it's not linear. It's not linear. Do you all agree? Do you all agree that ReLU is not linear? Very good. Okay. Coming back to our topic. One of our friends says, why didn't you name the layer which needs to be flattened? Is it that the syntax works by default for input layer only? No. See, I have put name over here also. I have put name over flattening also. And I have put name over here also. I have put name for all of them. Correct? Okay, what next now? You have added your first layer. You told them that I have an image. Then you flattened that image and then you made a hidden layer. What next now? Input, hidden, last is output. Fantastic. Fantastic. So output layer. Again, I will go and I will say that, hey, listen, I want to add a third layer. Actually, fourth layer, right? Because we have added a flattening also. So I will say tf.keras.layers.dense. And how many units should I ask him, or how many neurons should I ask them for output layer? 10. And activation should be softmax. Is there anyone who says other than softmax? Now what I'm going to do is I am going to say model.summary. It means you used ReLU. Okay. Sorry. Thank you. Now I am going to say that, hey, model, whatever you have done, can you please tell me whatever your summary is? And you will be surprised to see this kind of table, where on the left-hand side, let's start reading. It tells you the layer name. In the middle section that you see, it tells you what is the output what output should you expect from that particular layer. And at the very end, on the right-hand side, it tells you parameters, right? What are these parameters? These parameters are nothing, but these are the trainable weights and biases that will be used for this particular neuron. This particular layer, not neuron, sorry. Weights and biases for this particular layer. Please read this thing. Flatten layer, very good. The expected output is 784, very good. Hidden layer, it says 128, yes. And then output layer, it says 10. Now, See, will you only send one image? Or will you send two image? Or will you send 10 image? Will you send 20 image? Or will you send 1000 images? Nobody knows this thing, right? Your data set might have 60,000 images. Your data set might have 10,000 images only, correct? That is why this none is over there. It says that, see, I know for one image, the dimension is 784, but how many images are coming? I don't know. Do you understand this thing? So this none dimension is kept empty. Why? Because the user might send one image, two image, three image, 10,000 image, 60,000 image. Nobody knows. Why it is called none? Because nobody knows that value right now. That is why Keras is saying, hey, listen, I don't know. The user might send 60,000 images. The user might send only 10 images. I don't know. That is why it is saying none over there. Understood? Just for recall, let me tell you, parameters are nothing but, let's say, the number of weights and biases that are required in this particular layer. See, my friend, as I told you, parameters are nothing but weights and biases which are required in this particular layer. Correct? So now what is this layer? This layer is nothing but input layer of 784. Correct? Like this. And then in the middle one, it has 100, somewhere like this. Right? So how many connections will be made? 784 multiplied by 128. Correct? 784 connections into 128 connections. Correct? Plus how many biases? It means how many layers, how many neurons are here? 128. So this is the maths for your number 100480. Make sense? Similarly for the last one also, 1290. 180 into 10 into plus 10. And we saw some heavy mathematics that, you have to multiply input with the weight, random weight, then add bias and activation, and then do all these things. And when we were doing those things, right, I told you that you will never do this again in your life. Why? Because you have frameworks like TensorFlow, or you have wrappers like Keras, which will take care of all these things. Correct? And as you can see over here, you just literally wrote down 4 lines of code, and you made layers for your model, right? Input layer, flattening layer, hidden layer, and output layer. We're calling them dense layers, right? And you made a small architecture over here. Correct? See, what is softmax? Softmax is kind of an activation function, right? It's a special activation function which we will use in the last layer, always in the last layer of categorization problem. Again, listen to me. I am saying categorization problem. Don't say that, Shivam, you said use softmax every time. No, I am saying it is generally used in the last layers of categorization problems. Why do we use softmax? Because softmax has this very wonderful ability. It takes 10 different numbers, convert them into probability, and it makes them into comparable probabilities, right? So that we can very quickly compare that, okay, out of these 10, you have, let's say, this one has the highest probability of being the correct answer, right? So what is the job of softmax? The job of softmax is to convert big numbers into small probabilities, right? And that to comparable probabilities. It means that if you add all the probabilities, their sum will be equal to. Understood what is softmax? So what we have done is, can I say that we have done the phase 1 of our neural network system? Okay, can I say that we have done the phase 1 of feed forward neural network, right? We have made the layers, we have made the structure, and the structure looks good. Now we need to do the phase 2 error calculation kind of thing, right? We need to do that error calculation and then backpropagation, correct? So what does Keras says? Keras says, I will merge both the operations. You just tell me what kind of optimizer do you want to use and what kind of loss do you want to use. So see over here now, what I'm going to do is I'm going to say model.compile. Model.compile. Now model.compile means this is the place where we will tell them that what do we want. So the first thing that they're asking you is that what kind of optimizer do you want to use, right? What kind of optimizer do you want to use? Optimizer is nothing but, let's say, that mechanism where you want to do backpropagation. So we have learned one, and that's name is cross entropy. No, that is loss. Gradient descent. Very good. Very good. Gradient descent. And that is why I am going to write down something called as SGD, right? I'm going to write down SGD. So TF dot Keras dot optimizers dot SGD. Now you might ask me, Shivam, that should be GD. Why is it SGD? SGD means stochastic gradient descent. Now, what is this stochastic gradient descent? What is gradient descent? What is mini batch gradient descent? What is this RMS prop? Why all these things? Don't worry right now. There is a separate topic that we will do, which is called as optimizers. One complete, I think 2 sessions will be there only on trying different optimizers, right? So don't fret about that thing. Understood? But just to tell you, the English meaning of the word stochastic is just random, right? So we are saying that instead of using gradient descent, I am using stochastic gradient descent. And those of my friend who are saying, Shivam, we want to use learning rate. Where is the learning rate? So my friend, learning rate was a function of optimizers, correct? Learning rate was a function of SGD. Remember, gradient descent. That is the place where we will use it. So as you can see over here, the very first parameter of SGD is learning rate. And you can see by default, it is already filled up for you. It is using a default rate, and the default rate is 0.01, which, if you remember, I also taught you that learning rate. You guys are asking me, Shivam, what learning rate should I take? I said not very low, otherwise the model will not move, and not very fast so that it misses the value point. We should come in between. And you can see over here, I told you 0.01. The same value is being used by Keras as its default value. Shivam, I want to change this learning rate. Can I change it? The answer is you are most welcome. Okay. So we talked about optimizer. The second thing that this particular thing is asking us is that, hey, Shivam, what kind of loss function, or hey, data scientist, what kind of loss function are you taking? So what is the loss function that we will use? Will we use a simple one? No. Will we use that squared one? No. We will use something different, which is categorical cross entropy. Very good. Categorical cross entropy. And if I write it down over here. And the third thing it asks us is that what metrics do you want to see, Shivam, when this is running? So we just tell it that, hey, listen, we are a simple thing. We just want to see the accuracy metrics, right? We want to just see the accuracy metrics. So what we've done is we have combined the phase 1 and phase 2, and we have told the model that, hey, listen, we want to make losses of categorical cross entropy. Once you have those losses, then apply stochastic gradient descent or gradient descent over there and run this kind of model. Will it run this model? The answer is no. This will not run the model. This will just put the model ready, right? It will just make the model ready. What is the command to run a model in machine learning? Here you can say that define loss function, right? What optimizer to use? Correct. Okay. So now we will use, what is ACC over here? ACC is nothing. I want to make a joke over here. ACC cement. No. ACC means air accuracy. Sorry, don't mind my joke. Accuracy, right? Okay. So what is this model.fit? See, model.fit is nothing. So what do you pass in your model.fit when you do machine learning? You pass in your input and output, correct? So what is the input for yourself? What is the input for X underscore train? Very good. Very good. What is the Y? It means what is the output for you guys? The output is Y train. Very good. And then we will tell it that how many epochs do we want. Is this correct? X train, Y train. Yes. Then how many epochs? Now what is epoch? Do you remember? Epoch is nothing but, let's say, when you complete a phase one, when your complete data completes the phase one, then it goes to phase two, and then it goes to phase three, updates the weight, right? After this thing, when you run again a second iteration, that thing is called as a epoch. This from this is called as epoch. Is that fine? One iteration, one cycle, exactly. But this one cycle will take all the data, not just one data, one image. No, all the 60,000 images when they do a feed forward, error calculation, and then back propagation. That thing is called as one epoch. Now, I don't know how many epochs will be used. It might happen that our model might run in just 10 or might not run it in 100 also. So what I'll do is I'll take a small epoch of, let's say, 20. It means run it 20 times. Correct? Are iterations and epoch the same? I'll clear this doubt. Give me just 5 minutes. Okay. High epoch could lead to overfitting. Very valid point. I was just about to say this thing that, hey, listen, shouldn't we just use the maximum highest number available, right? We can use 10,000 number over here also, but that's not true, right? If you use a very high epoch, it means it is similar to like you have caught a child and you're just saying that, hey, memorize 2 plus 2, 4, 2 plus 2, 4, 2 plus 2, 4, 3 plus 3, 6. Will the child understand the mathematics? No. Your child is understanding 2 plus 2, 4, 3 plus 3, 6. But tomorrow, if you ask them 2 plus 3, they will fumble around, correct? So we don't want our model to let it memorize the data, correct? That is why we will not use a very high epoch. Now, obviously, you will not use a smaller epoch also. So then, Shivam, what should we use? How do we find this thing? If this is your question, give me 10 minutes. I will explain it to you, right? One of our friends says, but why not 15, 25, and why choose 20? This is a random number, my friend. See, okay, you said 15, I'll choose 15, right? And shift enter. And this is running. This is exactly what it is doing. It takes your 60,000 images and you can see the accuracy numbers are printed in front of you. 83% accuracy in the first, 90 in the second, 91.90 in third. Very good. I know how much you guys have waited for this day, but it is here. And as you all can see, your model has ended up with 96.35% accuracy. That's a good number, right? I mean, that's pretty good number, 96.52. Okay, my friend, you won the case. Sorry, I lost. 96.52. I lost. So what just happened over here? When we ran this model.fit x is equal to x train, y is equal to y train, epoch equal to 15. What happened over here is, my friend, the model was told that, see, based on this particular architecture, on this particular architecture, and based on these optimizers and losses, right, we'll make a model and we will run it 15 times, right? So it means 60,000 images will go feed forward, error calculation, backprop, feed forward, error calculation, backprop 15 times, right? This is the input data X train. This is the Y train data across which the error will be calculated, correct? So what is happening now? As you can, let's read the first line, right? So the first line says 1 out of 15. It means very simple that out of those 15 epochs, this is the first epoch. Now it says something 1875, something, something, something. Then it makes a progress bar. It tells you that it took 6 seconds to run this complete thing. and 3 milliseconds to run one step. Now, what is this step? It took a loss of 0.6445 and an accuracy of 83.91%. Correct? Now, the very first thing is, what is this 1875? Right? So see, my friends, this is your complete data, right? Data. And it has 60,000 images. Currently, we are very fortunate enough that this data is very small. Correct? 60,000 images, this data is very small. And on the other hand, the dimensions of this image is very, very, very small, right? Today, 28 cross 28, even if you take what? Even the very untidy image, right? If you take away dot of an image, that is not 28 cross 28, right? They are much bigger. So 28 cross 28 is a very, 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 very small kind of an image that you're looking, right? So what is the whole story that I'm building? The whole story that I'm building today is that the data that you have, my friend, today is very small, right? Very small. And generally, when you'll work for industry, it is not that small, right? The number of images might increase. Obviously, the dimension will increase. Do you all agree, right? That 28 cross 28 is not a very industry dimension, right? It will go somewhere around 1000 cross 1000 into 3. Correct? It is not going to be a grayscale image. It is going to be a 3-dimensional image. So now, why am I talking about all these things is that, my friend, it is not sometimes feasible to take all the 60,000 images with you and push them into the data. What is going to happen? Your laptop will crash, right? Your RAM will crash. Your system might crash with the error called as OOM, just out of memory, right? If you take this much amount of data, see, we all are not born with some, let's say 10 terabytes of RAM. Do you all agree, right? We have limited amount of RAM on our systems, 16 gigabyte, 32 gigabyte if we are on the domestic side. And even if we go on a commercial side, we have 512 gigabytes, or let's say even 1 terabyte of RAM. That's the maximum, right? Then you have to go to servers to get more higher, but there also it is limited. So we can't just say that any amount of data should be directly sent to the model. So what we are suggesting is, my friend, Keras says that, hey, you should not send your complete data. Rather, you should send data into batches. I want all of your attention over here. And if you notice here, my friend, if you give 1 second for the autocomplete to come up, here it is. If you notice over here, and if I scroll down it a little bit, and I just show it to you, that if you don't pass a batch size, right? If you don't give it any batch size, what happens is that Keras by default takes a batch size of 32. Give me a second. Can you all see this highlighted text? I'll read it up for you. It says that batch size is one of the parameters of model.fit. It says it is an integer or a none. It means that the number of images per gradient update. And it says if unspecified, it means if you have not given anything over here, batch size will default to 32. Batch size will default to 32. It means that in one cycle now, your complete data will not go and only 32 images will go. And it will make buckets of data, right? So earlier, you guys were imagining that all your data is in this very big bucket, right? Which is 60,000 images. Now they are saying, no, we have made small buckets, which will contain 32 images, 32 images, 32 images, and 32 images, correct? So if each bucket contains 32 images, which is also known as the bucket size or the batch size, how many buckets will be required, my friend? If each bucket can handle only 32 images, how many buckets will be required? If you divide this thing, this number will come out to be 1875. Remember to take it as an integer if this is decimal. And this is why this 18758. It says that I will take 60,000 images. I am not declining that I will not take. I will take them, but I will take them into small buckets so that your RAM does not crash. And also we are not feeding in just one go. We are not feeding all the data, right? The model might also get confused. So we are spoon feeding slowly, some amount of data so that the gradients can learn slowly. Do you agree? And do you understand the concept of batch size? So this will contain 3, this will contain 3, and this will contain 3. And there will be a fourth bucket which will contain only 1. So how many buckets are there? 4. And that is what I told you, when you are dividing that number by 3, this answer is 3.333. Make it an integer and make it a 4, right? Take the ceiling of this thing. Do you understand? Think from a bucket perspective, right? When we say batch size equal to 32, does it mean that one epoch will carry only 32 images? No, that is not true. That is not true. One epoch will still carry all the 60,000 images. Please understand this thing. One epoch will carry all the images. It is just that we are saying don't take them into ones, rather divide them into small buckets. We were at this particular line. Okay, so the very first thing that we have understood is that out of 15 epochs, one epoch is done. And in each epoch, we have 1,875 steps are there. Sometimes it is also called as steps. Correct? Right? Okay. Now, one thing that I think all of you will agree to me is that this is the training accuracy and the training losses. Should I rely on this number? No, you need to validate it. Each epoch is going to carry 60,000 images. Nothing is changing, right? Nothing is changing. It is still carrying 60,000 images. The only thing is that earlier it would have taken 60,000 images all together. Now what we are saying is that please don't take them all together. Take them into small buckets because it is very heavy to carry, right? So that is what is this 1875 is. And each 1875 carries 32 images. So if you multiply 32 image by the number of buckets or number of steps, this number is going to be 60,000 only. So the same thing is happening, right, my friend? How and why the accuracy is gradually increased for the same set, I'll tell you. Validation to be taken. Very good. Validation to be taken. Very good. And that is where, my friend, your best friend, who is your best friend? Your best friend is Keras. Remember, today your best friend has changed. It is only Keras. Keras gives you this fantastic ability. Now see over here. It gives you a fantastic ability. It says that, hey, listen, Shivam, you have 60,000 images. I say, yes, I have 60,000 images, my friend, but I need a validation data set and I don't have a validation. Remember, we have only something called as X train and X test. Correct? We have only X train and X test. There is no X validation, my friend. So Keras says, don't worry. Don't worry. It is my responsibility now that out of those 60,000 images, I will reserve some images for validation also. I will reserve some images from this 60,000 into this thing. So what I can do is I can say validation split equal to 0.1. It means that 10% of the images should be kept in validation. That's what I'm saying. It means 60,000 images are there in grand total, out of which I am saying 6,000 you keep it into validation and the remaining 54,000 will go into training. Do you agree? This is such a fantastic feature that Keras is saying that you don't need to worry. If you don't have validation data, don't worry. I will help you. I will help you. Correct? He's saying that I will take all the responsibility. You don't need to worry. Is the accuracy coming from the validation test or training set? So right now, the one that you see is coming from training. And if I run this thing now, you will notice something different over here. You will notice that your regular accuracy is coming, but do you see now 2 more terms coming over there? Do you all see two more fantastic features coming up to you? Now, one thing wrong has happened over here. What is that? That our model was already trained, right? And I started the training again. So whenever you have this kind of feature, right, go above in your model and delete your model like this, and then rerun it again. So this is now the correct accuracy. Just learning from the starting now. As you can see, your 82 is your, even if you run one epoch, then you have covered complete data. But when you read a, let's say, when you read a particular subject, do you understand that thing in the very first reading? No, you don't. That is why we have to read it again and again, 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 right? To understand those and to update our weights, correct? But again, to your question, my friend, complete data is taken care of in just one epoch. Is there anyone except our friend who has any issue in understanding this thing? That in one epoch, complete data is taken care of. I'll explain you what is this. See, 54,000 data is there, right? This data is fed into the model. And model, whatever is the limited capacity, based on that, the model has learned something, correct? The model has learned something. Now, whatever has the model learned, we run that model on those 6,000 images, and whatever the accuracy and the loss comes out, we say that is validation loss and validation accuracy. And whatever is the answer coming from this thing, this is train loss and train accuracy. But this train loss and train accuracy should not be considered as the final thing, because it's somewhat like that you have given a book to a child and you are saying that, yes, you can look the answers from this book, and then you're saying, yes, this kid knows a lot of things. No, that's not true, right? So that is why we work on those images which are never shown to the model, right? These 6,000 images were not shown while this model was trained. Well, we will use it once we have done all our hyperparameter tuning and everything. And then later on for an end-to-end testing, then we use test data. All of you are aware of this concept, right? Train, validation, and test. In this 4 second that you see over here, 100,770. I'm saying something a little bit wrong, right? This 101770 matrix multiplication are happening, my friend. And I can guarantee you, you cannot do even a simple 3x3 matrix in 4 seconds. A very simple matrix calculation, if I give you matrix multiplication, you can't do it. And you are expecting this guy to do 100,000, more than 100,000 matrix multiplication in 4 seconds. And you are saying it takes so much time. It's not, my friend. It's not, right? I don't think that you are appreciating the fact that what has happened now. You have, I think you have taught a model. You have taught somebody that what does a 1 look like? What does a 2 look like? 3 look like? 4 look like? Tomorrow, if you give any image to this particular model of digits, it will tell you that. It takes the same process, right? The same process that you're doing, my friend. If you have to teach a kid this thing, those of you who have kids, right? You can tell me that just to teach them 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, how many months have you spent? If there is any experienced parent that can help us, right? It takes ages, right? See, what I'm doing is I'm going to plot these two for you, and I'm going to help you exactly when to stop your training and when to continue your training. Now, do you see over here two things? plt.legend first of all, right? And also plt.title accuracy of model. What is the x-axis? X-axis is the epochs, and plt.y label. See over here now, what has happened is I just made this a little bit look fancy. Now, Do you see what is happening over here, my friends? That your training accuracy, all of you, please see over here. Your training accuracy is going above. It goes above, and it keeps on increasing. And if you see, right, I think if you run it for 200, 300 epochs, I think it will touch 100% also. But did you notice other of your friend? The name is validation accuracy. It starts to saturate over here. It goes up at one point. It saturates now, right? Do you all agree? It is saturating. So the fact is happening is that this is hallucinating you. It is fooling you into listing that your model is learning something, right? The kid is actually fooling you that, yeah, I'm learning, but actually they're not, right? The validation accuracy or the unit tests are telling you that, yes, they are not learning. They are flattened up. When they say study time, they're not actually studying. Right? It's a mugging up. Yeah, exactly, right? So do you understand now where to stop your modeling? Because if you continue doing this thing, my friend, it will actually go down. And this trend, I think all of you might have seen in your machine learning things also. This is exactly similar thing. Correct? So there's one thing that we do differently in deep learning is that we don't focus a lot on accuracy. We actually focus a lot on losses, right? Losses are something that we focus a lot. So I'm going to the history, right? And I am asking it to give me the loss, right? Loss plt.plot model.history val loss and label is equal to validation loss plt.legend, and you can see over here similar story. Now this blue line is the loss, your training losses, right? It looks like it's going down, and at one point still going down, right? And if you'll run this thing, it is going to go down, and I think at some point it might touch 0 also. But is this really true? Is this really that the losses are decreasing? That's not the true case. If you see, your validation losses starts decreasing. Yes, they decrease, but at one point they start saturating now. Do you see? In the last 10 epochs, after I think 40, 30, 38, 37, right, they've started saturating, right? This is how you decide the number of epochs, my friend. Do you agree? Now I get it why you used validation set despite having test set. Exactly. Very good. Thank you. Training accuracy is model and validation accuracy is test data. No, validation accuracy is not coming from test data, but you can say that we have created our own small validation data from the test itself. One of our friends says, what if validation accuracy is more than test accuracy? There's no concern in that. I mean, it is, so it's not a problem. And you can see in early stages, it was, because the samples that have come, because you see, my friend, what is validation accuracy? Validation accuracy is the performance of the model on validation data, right? Those 6,000 images. Now, fortunate or unfortunately, let's say it might have come into favor that those 6,000 images are easy images. So earlier it has started going up, but later on you can see it goes down, right? So there's no such concern over there. One of our friends says, would the enrichment of data or get more data will improve the losses? Yeah, definitely. And not just that. See, what you have to do this week now. This week, I told you some hyperparameters, right? I gave you some hyperparameters. Let's go up and I will tell you what are the hyperparameters. The very first hyperparameter is this 128, right? This 128 can be 150, this can be 500, this can be 2000, nobody knows. You will, let's say, make an Excel sheet for me, somewhat like this. I'll just show you an example. This one is a little bit complex for you guys, but somewhat like this, right? That you will make all your models, you will write your batch size, you will write your epochs, you will write what you've done. And at the end, you will give me your losses, accuracy, losses, validation accuracy, and validation losses. Correct? And you will not just do that, but you will also write what is your observation. This is the pattern that we follow over here, my friends, in my sessions. That see, I will teach you the concept, right? But it is your responsibility to replicate it back, correct? So all of you will make a Excel like this, batch size, epoch, and then if you want how many, let's say neurons you have taken in the dense layer, and then what kind of, I mean, optimizer is the same for you guys right now, but what is this thing, correct? Do you all understand? This is the task for you this week. So what are the hyperparameters? The first is the number of neurons in the hidden layer. Now, some of you might say, forget about those inception VGG. Please don't focus on that sheet, right? I was just showing you an example. Okay. The second hyperparameter for you is that you might say, Shivam, I want to, instead of ReLU, I want to use sigmoid and 10H. Go ahead, use them. Don't change the softmax, but in the last layer, you will use softmax only, correct? Okay. What is other hyperparameter for you? Batch size, right? Go make this batch size 32, 64, 128, 512, 1000, 10,000, and look around and see that how is this, let's say, accuracy behaving for you, correct? You can't change SGD for now. You will use SGD only. You will use categorical cross entropy only. But yes, epoch is not a hyperparameter technically, but you can use it as, I mean, 30, 40, just tell me whatever the answers are, right? Run experiments, at least run 50 experiments. And I can tell you the old batch, see, somehow you guys are fantastic, right? You guys are performing good, but again, I don't see that revision part. See, all of you remember good things, all of you are active also, but you guys are not proactive in practicing. So please do that. Other batches till wherever stage we are right now, right? In my previous batches, kids have gone mad, right? Mad. When I say make Python, when I say make neural network in Python, they would go mad. So that's what I'm saying. Please do it over here, right? So yeah, take this kind of model, make this model, and enjoy this model.
Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with iHub Divya Samparka, IIT Roorkee, and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence, and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
So if you take a very small number over here, what is going to happen? These are 784, your input neurons, right? 784. This is your output neurons, which are only 10, correct? Let's say 10. And in the middle, let's say this is the hidden layer. Now, obviously, all the learning is happening in the hidden layer, correct? All the learnings or whatever it has to learn is going to happen over here. Now, if you take a very small number, let's say only 16, right? If you take a number called 16. So how many weights will be there? There will be 784 into 16 weights only. Now, these weights are responsible for learning everything, correct? Majorly, all the learnings are responsible for these weights. So what I would suggest is this is a very small number. Now, you might ask me, Shivam, why should not I take a 512 number? Some of you might ask me, who are extreme north-south people, right? They might ask me 512. So then the point is that there are 784 into 512 neurons. Now, first of all, there are so many neurons that your time is going to increase, right? The capacity of the network is going to increase. Everything is going to increase over here. Now, does it mean that I should not take a larger network? Because larger is better, right? That's what all of us have learned. But that's not the point. If you take a larger network, right, then your model is too big to learn about, let's say, small things, right? These big things become so smaller, it might not even learn about those things. So my friend, the neurons in the hidden layer is a hyperparameter, as I have told you multiple times. This is a hyperparameter. Please take this number and change this number accordingly. Most of my friends have actually given a good rationale also, and they all resonate with the same thing. Is this what your analysis is? That if you take a very large number also, it takes times, it takes more time to reach the accuracy also. And if you take a very small number, it's underfitting. Your model is not capable of learning so much about data. See, again, I've told you multiple times this question, multiple times, that start with a baseline model and then improve it. There is no accuracy number, my friend. I'm telling you, there is no. Please do not fall into the rabbit hole of this number. Please don't think that 90 is a bad number and 95 is a good number. There is no such benchmark over here, right? Running on this thing is wrong, and it is not just wrong in deep learning. This is also wrong in machine learning also. Have you guys been chasing this number all your life? If that is what you have done, you are wrong. Please don't do this thing. Start with the baseline model and then keep improving that model. Now the number of the baseline can be as low as 60%, right? But you keep on improving it. But I told you that ReLU works better in cases of images. Why? Because ReLU negates the negative numbers, right? You can try the same model with the softmax, sigmoid also, and you will notice that it takes much higher time to achieve the accuracy. What I would suggest the guys who are doing the same thing, right? Keep everything constant, right? Just do a model with, let's say, ReLU and softmax. And you will notice that the loss dropping for ReLU is very sharp, right? The losses drop very quickly. Whereas if you take, let's say, the same model, it's same, everything same, right? Then don't change anything. Just make the activation function instead of ReLU, just make it sigmoid. You'll notice that the losses decrease, but do not exponentially, right? They'll decrease like this. That is the difference using the activation function. This will be your sigmoid, and this is your ReLU, correct? Why do we do pd dot get dummies, my friend? Now there are two things, right? One that you could have seen in the sheet also, we have written that this is the pre-processing for your output, right? Pre-processing for your output. Your output Y train, my friend, was written in this way, that the first image is a 0, then a 5, then a 4, then a 3, then a 2, and then a 1. The problem is you can't send these numbers to the deep learning model. Why? Because they are numerical right now in nature, and the model needs category, right? That's a categorical model. It needs category. So you will say, Shivam, let's convert them into this thing, right? You can call this as 0, this thing as a 5. Now they have converted into categorical. The problem is, no, your model can't understand these strings also. So that's why, and again, we have spent almost a good amount of this thing also. But again, we'll do this thing. So the point is we convert them into one hot encoding. This is called as one hot encoding. One hot encoding. One hot encoding means that you take how many options that you have, right? So let's say in our case, how many options do we have? A particular image can be 0, can be 1, can be 2, can be 3, can be 4, can be 5, 6, 7, 8, 9, and right? These 10 options can be there. So what you will do is, let's say if the answer is 3. So what you will do? You will say 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is what you will do. Now, what does this signify? You have converted this 3 into an array of zeros and ones. Now, you might ask me, Shivam, what is this? How you have done this logic? So the answer is very simple. What we have done over here, my friend, we are saying that this represents for 0, this represents 1, this represents 2, this represents 3, this 4, this 5, this 6, this 7, this 8, and this 9. So whatever label comes in, we activate that label, we put a 1 over there, and except everywhere else, we put a 0. So if tomorrow somebody comes to you and say you have to label it as 7, so how will you do? You will say 0, 2, 3, 4, 5, 6, 7, and 0, 0. Understood? So I'm going to import our 3 friends. NumPy, Pandas, and Matplotlib. And our friend TensorFlow also. Correct? Okay, so friends, till now we have used a dataset called MNIST, right? MNIST, you know all the story of MNIST, 0 till 9, these are digits. They were used for postal cards. Scientists came up, wanted to make something. The problem is that MNIST was being used for so many times. So these new scientists or the new age scientists, these people came up with something called as fashion MNIST. Now this is again a dataset that you can see over here. A fantastic one that they have made, but this is around fashion clothing. But again, it's the same 28 cross 28 grayscale images. They are not again real world images. These are very small patches of data. I know most of you might be thinking, Shivam, let's handle real world data and I want to make a model, right? Most of you thinking, right? If you're thinking like this, very good, keep up the spirit, but hold your horses also. Today, you're not capable to render an image of even 150, 153, right? That's the point. So let's first understand what is the pre-modeling of the clothes we have already done. Today, we will do post-modeling analysis, right? That what do we do once you make a model? So this data set is available here, my friends. This is a data set which contains 10 categories. These are all apparels like t-shirts, tops, trousers, pullovers, dresses, coats, sandals, shirts, sneaker, bag, and ankle boots. Link of the data set, yes, I can give it to you. Always remember we have a friend, and this friend's name is Keras. Keras is going to help us with data, don't worry, right? So what we'll do is I'll just copy this over here so that we remember these definitions. See, my friend, I highly appreciate that you coming up with these ideas and all these things. But the point is that do you first learn how to drive on the streets and then do you go to highway, or do you go to highway first and then learn on the streets? Right? So Keras Tuner, there are multiple things. Today there's something called as Auto ML, right? That can directly take your model and do everything for you. You don't even need to do anything. So Keras Tuner you should not use. I am not allowing you to use Keras Tuner in this class, right? You should learn each hyperparameter. What is the value of each hyperparameter? So this is the data set over here. We will use this one. I need your help, right? Very quickly, I will again do the same thing. That's how the data is available to us in Keras. Your screen is very small. I think you turn on your camera. No, my camera is off. I know for the same fact. So where were we? We were talking to Keras and we were saying that Keras, can you give us the fashion MNIST data? And Keras said, sure, I will give it to you. And you can see over here, it has given us the data, right? You don't need to download it from somewhere. You don't need to get it from somewhere. Just directly say tf.keras.datasets.fashionMNIST.load data and it will give you the data. This should not be a surprise to you. 60,000 images with 28 cross 28 height and width, right? And then similarly, if I do a shape of Y train, you will notice that there are 60,000 elements in this very big array. And these elements are nothing but 0, 1, 2, 3, 4, 5 till 9, correct? But this time 9 signifies something. 9 signifies ankle boot. 0 signifies a t-shirt, top, correct? Any questions still here? We have just simply downloaded the data, right? And we are saying, what is the problem statement here? Oh, that's a very good question. So yes, I forgot that this data set, my friend, MNIST, right? Fashion MNIST, they will give you images. What images? I'll just show it to you, right? They will give you some images like this. Let's take 5151. PLT dot I am show X train 0, CMAP, gray. So what I just simply written over here is that what I've simply written over here is that give me top the first 6 images over here, the 5 images, sorry, over here. Right, that's it. I've just written it into a subplot. All of you are aware of subplots, right? Very good, fantastic, fantastic. So as you can see, these are the things over here. I will do one thing. I will also plot the title so that all of us can see what this thing is, correct? Because that's also important. PLT dot figure size, we'll make it 10,8. Should be too big, but let's try. Okay, fantastic. You can see this is label 0, 0, 3, 0, 2. Fantastic. But what is this 0, 1, 2, 3? I don't understand, right? So what I'll do is I'll create a label encoder, a dictionary, correct? And I will make a dictionary in such a way that these are the keys and these are the responses, correct? Just give me a second. I will do it quickly over here. So what I've done is, my friends, I have made a very simple dictionary over here where the key is the number and the value is the label of that thing. So instead of this thing, what I can do is I can say label encoder, and then I can put this thing over here like this, correct? And then if I do, should see this thing. Understood? You can randomize it also. Obviously, you can put a random number over here and then get it. But I just wanted to play with this number. So that's why I put it up over here. But you can see. So see what I've done is I just wanted to show you what kind of data is coming in, right? What kind of data is coming on the chat, on the data set, right? So what I've done is I said that, hey, I want to plot 5 images. What is subplot? Subplot is how many number of rows do you want to make? How many number of columns do you want to make? And then what image is coming in? So I said I want to plot 1 row with 5 images inside it, right? And then I want to put up the images over here. So I said plt.imshow and plt.title, their labels, their correct labels that are over here. That's what I've done. Just try to plot the first 5 images. Okay, we'll see this later. Okay, so this kind of data is there, my friend. This is a little bit kind of different data as compared to your digits, right? Here you have fashion apparels over here, right? I will not try to plot those 5 different images for you. I want you guys to do this thing on your own. Do a simple question for you is, and I think we have done this in MNIST also, but I'll just give it to you. Plot 6 images of each category, and images should be random every time, right? So what I'm asking you to do is just simply make up a kind of this kind of let's say analysis, where what I'm saying is that this is, let's say, your trousers, this is your pullovers, this is your jeans, right? And then you have 6 images over here, 6 images, 6 images, 6 images, 6 images, right? I wanted to do this thing, all the 10 categories over here. We have done this thing in MNIST also, right? Problem statement is simple. These are images. You need to identify those images. That's it. Simple. Regarding the story behind this data set, see nothing. There were just some kids in China. They said that MNIST is boring. So they said that we will come up with this thing. You can read this over here. Right? Nothing. There is no like story behind it. Nothing over there. Right? Okay, so these are the images, my friend. Again, 28 cross 28 images, single channel images, 10 different categories for us. Tell me what should we do first now? We have the data with us ready. The very first step that I should take is pre-processing. Okay, so pre-processing. First of all, for input, I will do, what is this? X train is equal to X train divided by 255.0. And then for output, what should I do? For output, I should pd.getDummies. Fantastic, fantastic. pd.getDummies. Why isn't it loading? Very good. Wide train. Once you have done this thing, the data set remains the same. The X train is still the same, but there is a major difference now in Y train. Why? Y train has now converted from 60,000 to 60,000, 10. For each label, what we have done is we have converted that into a big array of 10 digits. Do you all understand? We just talked about pd.getDummies. That's what we have done over there. Okay, so the data is prepared. Now what we'll do? We will create modeling part. We will create the model. Now what is the model? Increase the font size. Sure, I will do it. Give me just 1 second. Do you see it now? So we are going to create a model. We will ask our friend Keras that, hey Keras, listen, I want to make a model. So Keras will say, sure, there are two types of modeling, right? There are two types of models that you can make. One is sequential and one is functional. So we will say we will use a sequential one because we know that each layer is going to connect to the previous one. So we will use the sequential modeling over here. Now, the very first thing that you do once you have made a model is to add layers, correct? What is the first layer that we will add? Input layer. So we will say model.add now because this is a sequential model. We will add the layers. So we will say model.add. Now we will say, hey, Keras, give me some layers, right? Give me some layers. Keras will say, sure, take your layers. Which layer do you want? We will say we want the input layer, correct? We want the input layer. Now, what does the input layer asks you? Input layer asks you that, hey, listen, whatever image is going to come in, please tell me the shape of that image. So we will say the image that is coming in is that of the shape of 28, 28. Understood? And then we will give it a name also so that we can recognize this thing that is called as input layer. What is the next layer that we will add? Now, because we have add a layer of 28 cross 28 image inside it, sorry, not layer, image inside this thing, this very good hidden layer, right? No, flattening. Then we will use flattening. Why flattening? Because see the image that we have added over here, my friend, that's a 2D image that has a height and a width. But remember, whenever we have made those circles, right? Those are like this. We have always made a 1D circular for input layer. So how is this going to help us? So we need to convert that into a flattening layer. So what we will say, we will call our friend flattening and we will say, hey, can you flatten the image for me? Can you flatten the image for me? What is the next layer? Okay. What if I change the sequence of the code? Okay. What is going to happen if I teach you, let's say, college studies first, then I teach you school, and then I teach you ABCD? What is going to happen? Will you understand? The answer is no. That's why there is a sequence, right? And that is why this layer is there. That is why this model is there, sequential model. So that the layers are added into the order. If you change the order, you have messed up with the model. My question is mostly for flattened. Then also, my friend, it is flattened only. How to know if image is already flattened? Obviously, images will never be flattened. See, if they are real world images, they will always at least be two-dimensional. At least, I am saying at least. Right? They can never be flattened. It's just a random question that came from my random friend and I just answered it. Please listen to me. Right? Number gave you a good response in terms of time and yeah, unit. That's what exactly I'm asking. 128 activation function. Anybody has any preference? Let's say if the model cannot, let's say, activate itself in 128. So what I'll do is I'll add up one more over here and I will make it 16. I will again use an activation of ReLU and I will say hidden layer 2. With second number of new units in first 2B 256 and second 32 with ReLU. Should we do it later on, right? Should we do it later on, right? Adding second layer? No, you can add the second layer here only. You can't add the second layer after the output. Okay, friends, all of you understand this thing, right? That the way you are writing the code, this is how your layers will be stacked. It's not that the model will automatically understand that this is the last layer, this is the second layer, this is the first layer. The model will not automatically understand. I am getting this sense from some of you that you guys are thinking that this layers will automatically Keras will understand. No, sequential model, as the name suggests, the order in which you are adding, my friend, in the same order Keras will arrange it. Is this a thumbs up from everyone? Everybody understands this thing. In every hidden layer, do we have to add the same activation function? My friend, see now, I am adding this layer, right? I am adding this layer over here called dense. And you will notice that this time when I'm using an activation function, I am not using ReLU over here. And you will tell me why, right? Can't we change the activation function in the hidden layer? That's a good question. That can I not make it sigmoid? The answer is no, right? You should not try to do it. Stick with just one activation function because see, I'll tell you why. I'll tell you why also. Listen to me. I'll tell you why also. The why is that your ReLU has now negated all the negative numbers. It has done some very hard work. Do you all agree? It has done some really hard work to make sure that there are no negative numbers. But then suddenly you pick up a sigmoid over here and then sigmoid allows everything. Sigmoid says go take 0 to 1. I don't minus 0 to 1 go. I don't care. Right? There is no upper limit around there. Correct? So I would say stick to the same activation function, at least in hidden layers. That's what I will suggest. But again, you can try this thing also. And those of you who have replied for softmax, very good, very good. This might require me 3 layers. This might require me 4 layers. I will know this thing using my post modeling analysis. I will check those graphs, right? I will check all those graphs. I will check all those analysis and then I will do. Why 16 in the second layer? So I am trying to use something called as the shallow down modeling technique, where I am using that I will shallow my model like this. Again, this number might be wrong, but this is how I am doing. I am fitting this number over here. This is 16 and this is 256 and this bigger one is 784. That's what I'm doing. Again, this might be 32 also. I don't know. Again, I'm saying this can be 32 also. This is a hyperparameter. I know most of you are frustrated now and you are saying, Shivam, what is this? For every question you are saying hyperparameter, hyperparameter, hyperparameter. But that is what a life of a data scientist is. See, because ultimately what you are doing over here, you are just sitting and you are just writing this code and then you're expecting that this will work for you. No, that's not a day in the life of a data scientist, right? A data scientist where she or he has to iterate over these models. That's what our life is. Right? We are not sitting here doing matrix multiplication because Keras has taken that responsibility already. You as a data scientist are responsible for optimizing these hyperparameters according to your data. There is no playbook. Again, I'm saying there is no playbook. And if somebody is saying to you in any Medium article or in any YouTube video that, you can have a playbook, I can tell you that, go with 3216 like this. There's nothing, right? Every data set will have its own unique characteristics, which will require a unique model. Do you get it? And I think the only thing that will help you is your experience, right? The more modeling techniques you will make, you will get answers to this slowly. That why 28 is working over here is because I think this is sufficient for the data that we have. So we have a data where we have 784 points. and 128 modeling weight is enough for them. Again, this will take time to develop for you guys. Understood? Shallow down technique is nothing. See, shallow down means that, let's say my data, I know that my images are not very, let's say, very expensive, right? I know that my images are very simple, right? I know my images, they contain some digits, or right now they contain some, let's say, kind of t-shirts like this. They're very simple. So what's the point is that I am saying is that they will never require, let's say, any kind of a special learning technique. So that's why I'm use a model where I decrease my number of layers till this number. That is what is shallow technique. That's why automation for tuning is provided by friend Keras himself. Again, see, there are multiple things that you can do. I would avoid, if I would have been at your stage, I would have avoided using Keras tuner or any kind of auto ML kind of a model over here, right? Okay, so what next now? What is the next thing that we will do is model dot summary. Very good. We will run this thing and we will see that our model is like this. Okay, so you can see a very simple model. We start with 784, we drop down to 128, we drop down to 16, we drop down to 10. Can somebody quickly tell me what is the mathematics for this? First of all, for this 100480 and then this 2064. Very good. Very good. So this mathematics for this 10048 is 784 neurons getting into 128 plus 128. That's the mathematics for your 1048. And then the second mathematics is 2064 into, sorry, 128 into 16 plus 16. Correct? And then the last one is 16 into 10 plus 10. Fantastic, fantastic. All of us understand this thing, right? Why 18 over here? This should be 10, sorry. Now, why does Keras shows you these parameters? See, I think you will not understand. Let's wait for one more session, but okay, I'll give you a hint over here. These are also called as total parameters. And every time you make up a model, right, they ask you a simple question that draw a balance between your data and parameter, right? See, I'll give you an example. See, based on the weight that we have, again, I'm not talking about the weight and biases. I'm talking about the real weight that we have, right? Based on the weight that you have, you call the crane, right? If you guys have ever seen a large shipping container being offloaded from a train, there's a crane, right? The crane actually like this, right? And based on the weight, right, the hooks are attached over here, and then this very big crane comes up and pulls this container, right? But there are different types of cranes and different types of containers. Now the containers, their height and width are constant, but the weight inside them can be different. Why? Because somebody might have filled iron in it, somebody is exporting aluminum in it, somebody is exporting wool in it, right? So the weight of that container can vary. The size and shape is the same. So the point that I'm making over here is that based on the data that you're bringing in and the complexity that you're bringing in. And again, today, we do not have a very complex data set, but in one of the problems called as dog breed, right? You will face this challenge over there where your data looks very simple, but it's very complicated in terms of classifying. And I'll give you an example right now also. Based on that, you have to build the parameters. That's what I'm saying right now. And that is the one simple answer to all your solutions, right? I'll ask you a question. Tell me, will the model understand very quickly between a elephant? Let's say you have to make a model between an elephant versus a, let's say, a small rabbit. One is this categorization problem. And the other one is that you have to make a model between two similar looking objects, like let's say a golden retriever and a Labrador. Which model do you think is much more easier to train? And why do you say so? I mean, see, dogs are of similar size. I mean, they both will be smaller in shape. They are easier to find. It's good, na? The B will be the better option. The separability of the classes. Very good point. Very, very good point. Easy to differentiate. Exactly. The point is that the model A is going to be much more easier for the model to learn. Why? Because the characteristics of an elephant are totally different from a rabbit, right? So there is a very sizable difference between these two, and the model will it's much easier for the model to learn these things. Whereas when you're trying to make a model between a golden retriever and a Labrador, the point is that both of them are dogs, both of them have the same feature, same height and same way, and in some senses same color also. At one point, I also used to get confused between them, as of today also. So the point is that the more similar features they have, the much difficult task it is for you, right? So as one of my friend was saying that, hey, what is complexity? See, complexity is not just about data, right? Complexity is also, complexity can also be defined at how similar your two categories are. Do you understand? Do you all agree? See, I can't quantify the term complexity over here. Some of you I know are very rigorous on this point that, hey, Shivam, quantify what is complex. Tell us what is complex, right? Most of you are saying this thing. But the point is you can't subjectify or you can't quantify the term complexity. I mean, I can give you very simple images also, but then also I can tell you that this data is complex. And you might say, Shivam, why they're complex? It's very simple. I knew somebody is going to come up. And there is one of my friend in the chat, he says that golden retrievers have big fur as compared to Labradors. I knew somebody is going to come up and teach me this thing. And my friend, my family is trying to teach me this thing for ages. I still haven't figured out. Right? Okay. So coming back to topic, do you all agree, right, that complexity of data is something that even if I give you simple images, it also depends on the subject of that image that we are trying to compare, right? One of our friends gives us a very good example. He says that it's simple as teaching a kid. That's a very good point, right? I always say that, whenever you're making a deep learning model, just think of it as a small kid, right? That's how deep learning models, they behave. So what we have done is, my friends, we have done this thing. One of our friends says, can you please answer my question? Sure. There are 60,000 images. So are we going to label 60,000 images manually as we did for 10K in label encoder? No, my friend, their labels are already available to us. Why would you manually sit down and do it? See, when you get this data white train, right, it already contains the label. Right? 60,000 images, we already have the label. You did the labeling. No, I did not do the labeling. I just gave those numbers a text over here. That's it. The label was already available to me. Okay, is this clear to everyone? Did I try to label this particular data over here? If you are thinking that I have labeled the data over here, no, that's not the case, right? I have not labeled. What I've just done is that because Keras gave me a data set which had numbers in it, I just converted those numbers into text for you so that you can easily understand the labels. You don't have to worry and go back again and again that, see, what is this 0, what is this 4, what is this 5? That's it. Okay. So you have done, let's say, the first phase of the modeling part. You have prepared a feed forward network. The next thing is compiling the model, right? One of my friend was saying that, Shivam, I'm getting error when I try to compile my model. See over here now, we will try to do this thing. So I am using something called as, for optimizers, I am using which optimizer? Break, please. Sure, we'll take a break, but we'll first of all make a model. SGD, right? SGD is stochastic gradient descent. Very good. Then what kind of loss we are using? We are using something called as categorical cross entropy, because this is a categorical problem, right? We have multiple categories over here, and we want the model to learn not just to identify the correct things, but also to penalize that why are you identifying the wrong things, correct? And what matrix should we use? We should use accuracy as the matrix. We need accuracy as the matrix. You can ask for other metrics also if you think, right, they're optimized. And I run this thing, you will see that it is working over there. Model ran for me. Sorry, the model compiled for me, right? A learning rate needs to be given as well. See, the learning rate by default is already set in SGD, right? And if the help pops up, I'll show it to you. Very good, 0.01. Very good, very good. So in SGD, you will see this learning rate is already set up. I don't think that you are in a stage right now that you need to change, but again, you should, let's say, change it a little bit and check it as a hyperparameter optimizer. You can do it. Okay, I am trying to fit the data over here. Very simply, I will say that my data is X-trained and Y-trained. We learned about epochs last time. Do you all remember? One epoch is one data completely sent for one iteration, correct? I'm going to run it for 10 epochs. And then we used something called as batch size also. Remember that how many batches of images. Okay, and the next thing that I'm going to do is that is validation split. Validation split is that I do not have the validation data with me, Keras. I have only training data and testing data. Can you please make sure that when I run my model, 10% of that data goes into validation. So out of 60,000, now only 54,000 images will go for training, and 1%, 10%, it means 6,000 images will go for validation, right? So what is going to happen? I'm going to press Shift Enter, and you will see that this modeling starts running. Who can quickly tell me the mathematics of this 884? Very good. 54,000 divided by 64. It means there are 54,000 images, out of which 54 I'm taking for training, and I'm making one batch for 64 images. So there are 844 batches over there. Fantastic, fantastic. So I'll explain it to you what is happening over here. See, when first time the data goes in, the training data is taken and some weights are optimized, correct? Some weights are optimized. So it will tell you the training accuracy and the training losses. Now we have, let's say, also separated some 6K images. 6K images. Now, whatever weights are over here, these weights are taken to, let's say, run it on the 6K images, and then you get what? Then you get validation accuracy and validation losses. Understood? Again, when the second epoch goes, second epoch again takes those 54,000 images, tries to optimize this weight. Now this weight, which was W1, has now converted into W2. It will again give you training accuracy, training losses. It will again take this 6K images and make up a validation accuracy, validation loss. Epoch doesn't use the same set. No, one epoch uses the same set. In the next epoch, it again shuffles this thing. So listen to me now. What is happening is, before the starting of every epoch, right? This is decided that, okay, these images will be training, these images will be validation. Before every epoch, once the epoch is over and the next epoch is ready, we again switch that data, we randomize the data, and we get next 6,000 images, right? Totally random in nature. Can we fix the random state? Yes, I think this question was asked to me last time also, and I told you I'll check. I forgot to check. I'll just give it to you. It's in model.fit only. It's called as random_state only. I'll just help it with you to you. Model.compile. Do you really think I should explain you? See, model.compile is a very simple thing where you're telling that, hey, model, we have done the feed forward. Now, please optimize the, let's say, do you remember the three phases of neural networks? The first phase was feed forward. The second was, one was error calculation. And the third one was optimizing the weights back, or the backpropagation, correct? This is what exactly you're doing over here. You're telling your model that, hey, model, I want to calculate the loss. Please calculate the loss using tf.keras.losses.categorical loss. And please do the back propagation using this algorithm called as SGD. That is it. So see, we don't know because they're taken randomly, right? It might happen that they might exactly copy as it is, or they might be totally different. That's random. That's why we take them random. We don't want to bring any bias over there. For each epoch, all the batches are taken. See this 884. Do you see this? That 844 batches were created and all of them were done. For each epoch, all the batches are done. And when I say all the batches, I mean all the images were done. Please understand this thing, my friend.
Let's have a quick quiz question, guys. And the question is, what does the term overfitting refer to in machine learning? And your options are, when a model performs well on the training data but poorly on the new unseen data, or when a model underestimates the complexity of the data, or when a model is perfectly generalized to all the data. Please mention your answers in the comment section below. Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with IHUB Divya Samparka, IIT Roorkee and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
In first epoch, you have taken 60,000 images. And in second epoch, we have taken 56. No, that's not. That's not. Right? That's not the case. Second question is batch size. Is this to prevent RAM overloading? That's a very good question. So see, batch size is, I think I answered this last time also. Batch size is used for two things. One, obviously, sorry. So sorry. One, obviously for RAM overloading. Today you have, let's say, very small images. Tomorrow when you will have very big images, this thing will fail. So one is obviously for RAM. Second thing is, do you really think that, let's say, if I teach, let's say you are in 10th standard, right? You are in 10th standard and let's say what is going to happen? You have your exams in science, social sciences, maths, English, and some optional language that you have taken, and then physical education. What if I teach you all the subject in just one day and ask you to prepare? Is this more efficient? Or sequentially, we decide every day that today on Monday, you will learn English completely. On Tuesdays, you will do social sciences. Next day, you'll do maths and then science. Which approach do you think is much better? The A or the B one? The B one, right? Exactly. So now what is happening is A, one of my friends says A also. Okay, very good. We'll teach you all the things in one go only. Okay, so now listen over here now. What I'm trying to say is that when you throw all the data, 60,000 images all at once to the algorithm, right? The algorithm is now trying to optimize for all the images, right? Everybody's trying to bring the weights left and right and center, right? Some of the images are saying, hey, come down. Some are saying come up. Some are saying come right. So the resultant movement of the weight is not in a very balanced position. So then you might say, Shivam, then we should give only one image at a time. Because then what is going to happen? We will only, let's say, focus on one image. Then also there's a problem. When you take only one image per iteration, what is going to happen? Every time the weight will be optimized in very upside down manner. I'll tell you why. See, this is, let's say, your gradient, right? So earlier, the image was, let's say, getting optimized for that one cat image. So it said, okay, we should go down. Next time, a image of a dog came in. So now it is saying that, hey, no, you should come down over here also. So the weights, they are like jumbling very fast here and there if you send only one image. So to avoid this noise in the nature, what we do is we send some images together and we call it as a batch, right? We send a batch of images so that the model learns continuously and also slowly. Do you understand? It's a hybrid approach that we have taken. Neither we are sending all the images, neither we are sending one image. We are going in the between one. You can bring whatever link you want to, but listen to me, two things, right? Two things. And not just to Naveen, but to everybody. When I say that there is one epoch, what does one epoch signifies? One epoch signifies that this is your feed forward, this is your error calculation, and then this is your back propagation. It means that if your data has 60,000 images, one epoch means that you have taken all the images, all the 60,000 images, and they have gone from feed forward to error calculation to back propagation. They have completed this one cycle. One cycle. It does not matter if you have 60,000 images, if you have 600,000 images, it does not matter. Listen to me, right? One epoch means one iteration is complete with all data. Let me write down in caps lock on all data, right? Now this batch concept, listen to me now, this batch concept, please listen to me now what this batch concept is. The batch concept is, see, the problem with you guys is you guys don't focus when somebody else is asking a question. The answer to your question was actually hidden in somebody else's question also. See, when I say one epoch, right, now I have 60,000 images. Right now, one way is that I can send all these images together. I can send all the images together, but I will never do that. So what I do is, instead of taking all these images together, what I say is that I will divide them into small buckets. And let's say if I make a bucket, if I make one bucket of 100 images, let's take an example. So how many buckets will be required to contain all the 60,000 images? Anybody? Any mathematics champion over here? 600. Very good. 600 buckets are required. Okay. So this is your model. This is again your feed forward. And this is your back error calculation. And this is your back propagation. Right? Now, instead of taking all your 60,000 images, what we are saying is that we will take one bucket. And this one bucket contains 100 images. So bucket one will go, it will update the weights, it will come back. Then we will send bucket two will go. So how many images we have done now with bucket two? We have done 200 images only. Then we will send bucket three, bucket four, bucket five, bucket six, and we will do bucket 600. When this bucket 600 is going, it has some optimized weights over here. It will go and it will tell you. Once this bucket 600 is done, then we will say epoch 1 is completed. Epoch 1 is completed. Do you understand my term over here? Does everybody understand this concept of epoch batch size? So what we have done is we have taken, okay, so we have to go for a break also, class. But okay, today we'll skip the break. Sorry, right? Sorry, we'll skip the break and we'll come back. For every epoch, it's calculating accuracy, right? Yes, right? So you can see over here, after every epoch, it is reporting you these numbers, right? It is reporting you these losses. It is reporting you the accuracy over here. Do you understand? One of my friends says in single epoch, we are running all the images. Then why there are so many epochs? Very good. So my friend, when you go to school, right? On the very first day, let's say this is your 10th standard. This is your 10th standard. And on the very first day of your school, you have, let's say, subjects of all the classes, correct? You have your maths classes. The first lecture is of maths. Second lecture is of science. Second lecture is of, third lecture is of social science, right? You have done all the subjects today. Why do you want to come to school tomorrow? Should you come to school tomorrow? The answer is yes. Why? Because you have not learned everything. You just today understood about this maths and science today. Tomorrow you'll go into more details. There are multiple things to learn about maths, right? You can't learn it in one day. That is why you do multiple epochs also. In the first epoch, yes, all the images have gone, but have you understood about them? The answer is no. We have not understood about those images over there. That we might have taken less epochs also. Yeah, that's it. That is true. because I don't see that our model is overfitting, right? See the weights, the loss is going down 48, 46, 45, 43, 41, 42. It increased a little bit over here, but I think this is good. We should do more. Again, I am saying to you, this second layer is necessary. I don't know, not necessary. I don't know, right? You figure out and tell me. Can we know that where is the model trying to focus over there? And the answer to your question is yes. There exists a technique, and I have a paper for me. Just give me a second. I have my own sheet. I'll share it with you. Give me 1 second. GitHub. So see now, this was the image that we sent to the model, right? And now we want to understand that where is it focusing? Is it focusing on the top left, top right? Where is it doing? So for that, you can see over here, what I did is I made this particular model. I went inside the layers and I asked each layer that, hey, layer, where are you focusing? It converted all that one bird image. Now you can see over here, it tries multiple things. You can see sometimes it's trying to center the whiten up the area. Sometimes it's trying to find the edges of the bird. Sometimes it's trying to bring in the full contrast. You can see over there are multiple regions over there. Sometimes it's just trying to make it all black, right? And bringing the gradients. Sometimes you see in this specific picture, what it has done is it is trying to whiten up the area where the region of interest is. Do you agree? That's, my friend, the answer to your question, that you can do it. You can do it and it is possible. What is the problem statement? The question was that, the question I'll read as it is. Our friend says that, is there a way to find out the most important features the model extracted and considered for categorization? This is somewhat like when you do in your machine learning model and you're trying to find the shape and the line value. That's what is doing over here. Extraction feature is done automatically. Yes, that's the beauty of deep learning, right? That you don't need to manually fetch the features. See, if you think, and I'll tell you the rationale over here. So one of my friends says, Shivam, rather than decreasing it to 16, can I keep it to 128 only? I would say for this particular data set, no. And again, see, my answer is an informed answer. But let's say what our friend is saying, that can I keep it 128 over here? And yes, that is one of the techniques where we say a constant measured model, where we say that we will keep the hidden layer neurons as same. Why? Because the degree of the complexity of the data is so high that we want to retain that capacity of the model. So yes, if you think that the data is complex, you should keep it as 128 also. You can. I mean, again, there is no limitation that you can't keep. Again, the shallow technique that I have taken is just a simple approach, right? But you can keep it 128 also. In this particular case, I don't think you will need 128, but. So, okay. So what we have done over here is, see, we took all the data, we understood this particular model, fancy model, all those things. Now let's try to understand that how can we do prediction from this particular model, right? Right. First of all, before that is saving the models. The very first thing that you should do is save your model. So model can be saved by this thing called model.save. The moment you will do this thing, it will ask you for a folder name. See over here, right now, there is no such folder. But right now, if I say fashion MNIST model, you will notice that it will create a folder structure over here and it will save two things for us. One is the structure of this particular model, that this is how it was made. And the second thing is, one is the structure of the model. The second important thing for the model is weights and biases. Very good. The second important thing is the optimized weights and biases. So as you can see over here, if I refresh this thing, you can see this model fashion underscore MNIST underscore model is there. And this is your weights and biases over here. And if you open up this PB file, this contains the skeleton, right? Is it saving a pickle file? No, it used to save it into a pickle file in the very old formats of Keras, but now it saves it into a folder kind of a structure, right? It's a protobuf protocol called as protobuf, That's a Google's own protocol. One of my friends was asking, can I see the weights? Yes, you can see the weights. And I think we saw it last time also. You can see over here, this is your weights, right? I don't think that it will make any sense to you. And if you want to see the skeleton of the model, that is there in something called as 2JSON. So if you do this thing, this will produce a JSON file for you. And this JSON file contains everything. And I'll show it to you. It contains everything. What this model is, what does it contain, and all these things. And if you see over here, what I've done is I copied that particular JSON thing. And you can see over here, it tells you that this is a sequential kind of a model that is built on Keras version 2.12.0 with a TensorFlow backend. And it has multiple configurations. The name is sequential. There are 5 layers, 0, 1, 2, 3, 4. What is the first layer? The first layer is called input layer. It tells you that what is the input shape. It contains null 28, 28. In the first layer also, this is a flattening layer. The second layer is the dense layer. With this configuration, you can see name is hidden layer, trainable equal to true, 128 units. Similarly, in the third also, you can see this is called as hidden layer 2 with units 12 only. Activation is relu over here, correct? So this complete thing is called as the skeleton of your model, and you can reconstruct your model using just this information, correct? Okay. So now once you have saved the model, you will do the predictions. Let's start the predictions. How do you predict, right? Prediction can be done by using something called as model.predict as your machine learning models, scikit-learn, like this. And in this particular thing, you have to give your input. Now, do you remember what have you sent as the input to your image? Now, you might not remember. So for that thing, right, what we will do is we will ask the model, hey model, what is the input shape that you take? What is the input shape that you take? And you will be surprised to notice that this is the shape that your model takes, right? You're surprised. Why 784? Did you enter 784 image into the model? The answer is no. You entered a 28,28 image. Later on, you flattened this. That is your problem. But what is the input to the model? It is none, 28, 28. Now, what is this none over here? Who can tell me? So see now, all of us know that the height and width of the model was 28, 28. Now, what is this none? See, the model does not know that how many images will come in, right? The model does not know how many images will come in. There might be 60,000 images. There might be one image only. There might be some batch size. We don't know. That is why the model puts a none over here. It says, I don't know how many images. Whatever number of images are coming, we will just put it over here as a placeholder. Very good. Very good. So if you are sending 60,000, it will become 60,000, 28, 28. If you are sending only one, it will become 1, 28, 28. Remember this thing. If you are sending one image, it will become 1, 28, 28. So see now, this is the process. We will take this image. Let's say test image, X test, 0. I will take this image. I will plot this image, plt.imshow test underscore image, and I will try to show you the label also. So this is the image. Okay, you can see this is the ankle boot, and this is an ankle boot. Yeah, that's it, right? Okay, so if I try to send this image directly, see over here, called as test image. First of all, tell me, do you find any issue over here? Do you find any issue over here? Okay, what is the answer to the yes? Why do you see an issue? Normalize. Very good point. Very, very excellent point. See, the image that you have right now, this test image, this is not a normalized image. Whereas your model is trained on the data set where all the images were normalized. Remember? So you need to normalize your image first of all. Very good point. Normalize the image. So what we will do? We will say test image is equal to test image divided by 255.0. Is this still ready to go? The answer is, say the answer, yes or no. It's ready, right? No, it's not ready. What is the shape of this image? 28, 28. Is this what your model will take? No. Your model actually requires this shape to be just converted to like this. 1, 28, 28. Correct? No, not flattening, Baba. First of all, please understand this one thing. We will not do flattening. Why? Because the model will take care of flattening. Flattening was the part of modeling. Flattening will take care of that thing. Please understand, those of my friends who are saying flattening, please understand this thing. Flattening is a part of the model. Model will do that thing. It is not your responsibility anymore. Anything that you have done before this modeling is your problem. After that is not your problem. See, this normalization you did earlier. So your model does not know about this thing. But flattening is something that your model knows. So it will take care. That is why the input shape is 28, 28 over here. Otherwise, this would have been none, 784. Do you all agree? Very good. So what we are going to do over here is need to introduce a new dimension. And for that, what we will use? We will use, you guys might have used this thing. This thing is called as expand dims. NP has a function called as expand dimension. This expand dimension feature actually just helps you to put up a newer dimension. I am going to print the first dimension before this thing and notice what happens after this thing. Do you notice? Before NP expand, right? And this is after NP dot expand. Right? Also, I will read the image again because we have already divided it by 255. Read image. Test image is equal to x test 0. Do you all understand? See over here. So first we read the image, then we normalize the image, then this was the shape 28, 28. After NP expand, this has become 1, 28, 28. That's it. Right? And now we will. Are we ready to go now? Yes? Okay. If you guys are showing the confidence, we will send this image. Test underscore image and we will get our answer. Ankle boot, right? Written over there. We have been waiting for this thing. Yes, yeah, I know you have been patiently waiting for this thing. And the answer will come as ankle boot, right? Very good. And boom, this is not the answer. What is this thing? Who can tell me? What is this thing? This is the result of the softmax that you have put in the NAS layer. Get dummies? No, this is not get dummies. This is the result of softmax. Do you remember? You have put up in the last layer, you have put up an activation function called as softmax. We will use softmax. Why did you use softmax? So that it gives you 10 different probabilities of all the things, right? Now, this thing we know that for sure is the ankle boot, but this can be anything, right? This can be a t-shirt, this can be a trouser, this can be anything, right? So those 10 different probabilities are over here, right? Let's store them into something called as result. And now how do we know which one is our result, which is the maximum, correct? So we will obviously go manually and we will see this is the maximum, correct? We'll do it manually, obviously. Is this the lower one or is this the lower one? No, we will never do manually. In NP, there is something called as argmax. Argmax means that don't give me the maximum position. See, if you use max, right, it will tell you that what is the maximum number. 0.59, this number was the maximum number, but I don't want the maximum probability. I actually want the result. I actually want the index. Very good. So what I will do is I will say np.argmax, that tell me where it is the maximum. Now I will say this is what? This is the index. As you can see, the index is obviously the 9th. This is 9. Now what is 9? How do we know? We can ask our friend label encoder and he will tell us what is this 9. The 9 is ankle boot. Clap for everybody, clap for yourselves. You have achieved a milestone in your life. You ran your first model and you saw that this is. One of my friends says, so the sum of results should be equal to 1. Yes, it is. It is. It is, my friend. If you do a sum, if you do a not sum like this, it is 1. See? Clap for yourselves. Very good. Right? I now know this process is very like, over here. What we can do is we can quickly just make a function. Predict, right? And we can expect a image over here. The very first thing that we will do with image is that pre-process that image, right? Second thing that we need to do with that image is np.expand image, right? I'll just copy paste it from here, right? Then what we need to do is result is equal to model.predict and then image. Now this result, we will again take it into result np.argmax into result. And then we will return what? Return label encoder and send it through result. And if I make it like this, now today or tomorrow, I can just send any image over here and you can see that the answer comes out to be dress, right? You can actually plot this image also if you want. I'll plot this image also plt.imshow image, and I will actually say plt.title. This fantastic. And now if I push up any image, this is a pullover, right? Actually, also let me do one thing. This is the correct label, and now if I let's say send you image 400, you can see that this is a t-shirt that our model is saying, right? Can we please call the predict for multiple images? Yes, you can call multiple images also. Why did the concept of normalize? Okay, so my friend, let's say you have taught your kids that whenever you have to eat chocolate, you have to remove the wrapper. That's how you have taught them, right? You always give them the chocolate unwrapped, right? You always throw the wrapper first of all, and then you give it to them. If one day randomly you will give your kids, small kids I'm talking about, right? If you will give them chocolates without the wrapper, they'll try to eat it with the wrapper only. That's the behavior, because your model is trained on normalized images. Your model only knows about normalized images. It will perform better only on normalized images. And forget about better. It will perform only on normalized images. That is why we give the model normalized images. Can we train it to pull and show all the numbers of tops? And yes, you can. Yes, you can. You can. Can we take some random images from internet, resize, and then predict our model? Unfortunately, it will not perform better. I'll tell you why. Because the images on which it is trained versus the images which are available on internet, they're not the same. So in that case, it will not work. But what you can do is, you have plethora of images. You have 10,000 test images. Take them, have fun with them. I'm using test images only. But don't worry, that is not just the case, right? What we will do is, my friend, we will also, in the next data set, you can use directly the images. You can directly use internet images, right? Okay. So one of my friend was saying, Shivam, I want to use multiple images. Can you show it to me? Yes, I can. So let's say we have taken top 5, let's say test 5 images. So what I'm doing is, I am giving it, what if I have to give, let's say 5 images to it? Can I do it like this? Can I do it like this? Yes, we can. So see what has happened over here. If I do it like this, it will give me 5 images, right? So what I'm doing is, I'm taking it up over there. I run it like this. Okay, so now I have 5 images and I can show it to you also. For I in test 5 images. plt.py show I, that is it, and you will notice that it does not work. And why it is not working? It says invalid shape for data. Figure fixed size. Give me 1 second. Give me 1 second. Give me 1 second. Oh, somehow our this test 5 image is not. See, if you will do it like this, you will be stupid like me. What we have done is silly mistake. We have done silly mistake. See over here, and now it is overriding all those things. So what I have to do is, I have to put up a plt.subplot. Subplot 1,5, index. This should be fine. Okay, so you can see over here, your images are, those images are plotted over here. Correct. And okay, so these are the images. Now, if you want to predict the model, the very first thing that you will do is take these test 5 images and normalize them. The second thing is, should I add, okay, let me ask you a question. Should I add a np.expand dims over here? The answer is yes. No, very good. Why? Because they're already there. This 5 is already over there. Because these images are combined together, this 5 is already over there, right? So I can send it directly like this. So I will say model.predict and I will send my test 5 images. And I will store it into something called as result, and I will show you the result. Now you tell me, what is this result? This is a very big array, and for all the 5 images, my friend, you have the 10 probabilities. Correct? So what I will do, I will say np.argmax and I will say result, and you will get your answer. Correct? You will get your 5 answers. The answer is no. You don't get it. Why do you don't get it? Shivam, np.argmax should give me all these things. The answer is you have to tell it that across which axis to do. Right? Which axis to do. So what is the axis? Tell me. 1. Very good. So you can see it gave me 5 over there. Is this correct? That is not correct. Did we took a wrong result? Is it giving us the correct answer? 0, 1, 2, 3, 4, 5. Yeah, that's what we have done. We have find the argmax of these things only. But somehow the probabilities are coming out to be same. What have we missed over here? Somehow the answer is coming out to be 5 for everything. And 5 is what? Label, encoder, 5. Sandals. So it says sandal to everything. Where they are not. Okay, so let's run it again. Let's run it again. Try axis is equal to 0. This is not a hit and trial, my friend. Axis is equal to 0. We'll do it for all the columns, whereas we want it for the row level. Let's try. We got all the images. Then we just drew the images. Right? Nothing very fancy over here. Then I'm just worried that I've taken a wrong variable name. Okay, that's correct. The correct name is correct. Okay, I'll just copy this line over here again. See, we messed up something over there. Sorry. We messed up. I think the variable name got messed up somewhere here, but now it is correct. Right? Now you can see the variables are changing over there. And now it is 926116. Right? And what is the correct answer? Let's see that also. The correct answer is available to us in Y test 0 till 5. Let's see it over there. The correct answer was 92116. That's a good thing, right? Good accuracy over there. All correctly found answers. Right? Okay, now let me take your questions. One of my friends says in np.expand dims, we have not mentioned where to expand the dimension. It can be 1, 28, 28. It can be 28, 1, 1. Is it correct question? The question is correct, but you forgot to see one thing, my friend, that when we do np.expand dims, we actually tell it that where we are doing. See over here, we say axis is equal to 0. It means expand the dimensions at the very starting. We tell it. So what I will do is I will take the complete data set x test normalized is equal to x test 255.0. And now I will send this complete data to model for prediction. See now, and what I will do is I will say np.argmax and axis is equal to 1, correct? Yes. So this is the answer. You can see over here that np.argmax ran, and it is now I have answers for each image now. Each image. What I will do is, and I also have the correct answers with me also, right? I also have the correct answers with me. What I will do, I will see wherever my answer is correct. And you will see it gives me this thing kind of thing. And I will say dot sum. And you will notice that only 8421 times my answer is correct out of 10,000. So it means our model is 84% correct only. Do you notice what just happened over here? I will explain you again. All of you, please focus here. What I did is I took all the test data, and I normalized it, and I called it X test normalized. I send this complete X test normalized to model.predict, right? Now model.predict is going to return me those probabilities. So I said, I don't want probabilities, just give me the argmax. So I did a argmax over there and I said, now it will give me only directly labels. So you can see over here in Y predicted, I have labels over here 9, 2, 1, 8, 1, 5. Similarly, I have the correct answers also. I have the correct answers also. Y test 9, 2, 1, 8, 1, 5. And I asked it that wherever my answers are correct, please tell me wherever they both are equal. And you can see 88,421 images, they were correct. Now, how do I know? Please tell me, how do I know which images did not classify correctly? Which images failed the prediction? How should I know this thing? np.where y predicted is not equal to y true. And it will give you what? It will give you what? It will give you indexes. It will give you positions. Index of images where prediction is not as y test or not as actual. Do you all agree that this is the image now, y12? So let's plot this thing. plt.im show x test 12th image, right? Let's write down print f actual label was label encoder y test 12, correct? Whereas the predicted one is what? Y pred 12. Sorry, this is not actual, this is predicted label. See over here now. What does your label says? It says sneaker, and the model is confused with sandals. Right? Let's talk to the next one, 20th. So if I change it to index, let's see this image now. This is sorry, my mistake. This is actually a pullover, but your model is calling it as a t-shirt. So this is a wrong thing, right? So you can see all those images. I'll pull up one more example for you. Right? See now, this is a shirt t-shirt. Those of you who are saying that Shivam, we can use confusion matrix, definitely yes, you can use confusion matrix. Who can tell me where is confusion matrix? From sklearn.matrix import confusion matrix. Confusion matrix. What is the first thing that it asks you? It asks you what is the y true. So y true in our case is y test, and what is the predicted? Y pred. And if I run it like this, you will see that, see, these labels are getting confused. I know that you can pass your labels also. Here is this labels is equal to label encoder dot values array. This dot list. Just give me 1 second. Huh? Just give me 1 second. I just want to bring up that label for you so that you don't have to read that 0, 1, 2, 3, 4. Huh? Just give me 1 second. What does it say is a stupid thing? This is fantastic. Fantastic. Array. At least one label must be specified in y true. Hey, that's what I've done now. Acha, this is just
Oh, sorry. We can't do it over here. Sorry. We can't do it over here because that's an array over there. Okay. So then we need to manually do it. Sorry, my friends. I just raised your hopes, but we can actually do it over here also. I'll show it to you. But okay, let's see now. So the majority of the this thing can actually be, I can actually do one more thing for you. Put SNS and SNS dot heat map. Heat map. Okay, here it is. Let's say n non equal to true and the C map equal to grays. It's grays, I know. It is not called anon, it is called anode. Sorry. It's anode. Sorry. My mistake. Yeah. And C map is also grays. I know I'm writing it wrong. Oh no, it's correct. Oh, fantastic. You can see over here that these numbers are the problematic ones. Actually, let me make it greens. Green. What is this greens now? Fantastic. Okay. So see, the major problem is these two only, these two heat maps only, or this one. These two numbers are big. So okay, let's check what these numbers are. Okay, this is 156 is the biggest number over here. And it is getting confused between 0, 1, 2, 3, 4, 5, 6. Is between shirts, and it is getting confused with your 1, 2, 3, 4, 5, 6, 7. This is a 7 1, right? 2, 3, 4, 5, 6, 7, 7. Yeah, okay. So shirts are getting confused with sneakers. That's not a good thing. I can see that sneakers and sandals are getting confused, which makes sense, but this is problematic thing. This 144 and this 104. 104 means that your 0, 1, 2, 3, 4, 5, 6. It means your shirts are getting confused with t-shirts, which also makes sense. So okay, yeah, that's what you can do. Can we check the second highest probability in the model that predicted? Yes, you can. Why not? You can. You can put up this thing over here where you can ask the model to give it second probability also. So right now we are just returning the result. You can also ask it to return the probability also. Pro is equal to np dot max result, and then you can send it the prob also. So this particular shirt that comes up, 73% is the accuracy. You can call the second best also. Initially, pullovers were getting confused with shirts. That's exactly what is happening over here also, my friend. If you see, this 104 actually says that your t-shirts and tops are getting confused with shirts. And you are saying pullovers were getting, oh, okay. Pullovers were getting confused with shirts. So you are saying two and shirts. Let me do one thing. Give me just 1 second. I know we have crossed time and I don't want to increase more, but that is what the funda is. Do you understand? That the model is not just stopped over there when you stop your training. It's ahead also. Go and learn that what mistakes we have done. This all ideally should be all 0. This all. Do you all know how to read our confusion matrix, right? This all should be 0. And the larger the number, the more problematic thing it is telling you. What does it tell you? This is 0, 1, 2, 3, and 4. It tells you that 4 and 2 are getting confused. Trousers and coats are getting confused. Now that's a very stupid thing, but that's what is happening with our model, right? And then accordingly, we'll take those decisions that what to do, what not to do, right? But your objective, my objective for today's class was to tell you, first of all, how to do prediction. How can you make a function around it, right? Didn't get the confusion matrix here. Why? See, confusion matrix is nothing but, let's say, I'll help you. Confusion matrix is nothing but a table kind of thing that you try to make. Let's say instead of these 10 categories, you had only 3 categories. So this is how your table should look like, right? Where you make it like this. This is category A, this is category B, this is category C, this is category A, this is category B, this is category C, right? These are actuals and these are predicted. Again, I would say if you want to learn more about confusion metrics, you should learn from the Wikipedia page. That has a fantastic display of what is true, positive, false, negative, all those things, right? Now, ideally, in an ideal world situation, all the data should be filled over here because there is no other confusion, right? So your diagonals should contain everything, and this other top triangle and lower triangle should not contain any number, right? So let's say if a number is written over here like this, that let's say this is 20 and this is 0 and this is, let's say, 5. So it means that there were in total 25 B items. There were in total 25, actually 25 items were there for the category B, but your model correctly identified only 20 of them, right? This is the recall of your model, that how many was it able to identify correctly, right? Now, what does this 5 signifies? The 5 signifies that the model actually confused them with C. A was fine, but your model thinks that these 5 items, which are originally or actually B, were called as C over here. Correct? And let's say here also it is 0 and here also it is 4. Now this is called as 20 divided by 24. This is called as precision of your model. It means that the model predicted 24 Bs. It predicted 24 Bs, but out of them, actually, there were only 20. 4 of them were C. Do you understand? This is a very important metric that all of you should know in your machine learning domain. Also, what is recall, what is precision, what is F1, what is confusion metrics, right? So for today, right, and I think if you can give me 10 more minutes, I just want to close and wrap up this thing, right? What we have done, how we have done. Can you please explain how the confusion matrix is here in our example? Yes, over here. Give me just 1 second. I'll just do it for you only. Sample normalized. Give me just 1 second. Just 1 second. Okay. Is equal to range of 11. It should work. No, not 11. Only 10. It is working, but why is it not working? You have to give it manually. 0, 1, 2, 3, 4, 5, 6, 7, 9. It's a stupid thing. Why is it not working? Give me 1 second. 1 second. I will just show this to all of you. This is not working. You've given the labels normalize. Okay. Somehow they're not printing it, which is fine. I will do this for you. Wait. We will call it as CM. We will say CM. No worries. The number should be in quotes. Yeah, no worries, no worries, no worries. We will do it. PD dot data frame CM, and the columns should be a range of, actually if we don't even give it, it should come over here. Okay, can you see these numbers now? All of you can see these numbers? Okay, so now I will explain you. Those of you who know, very good. Those of you who don't know, please focus here. What this is trying to say is that what it is trying to say over here is that, see, listen, right? What does this 745 means? 745 means that these 745 were actually 0 and they were also predicted as 0. See over here, whenever you have confusion, my friend, please see for this particular thing, right? Open up this particular, let's say, selection and read over here. What does it say? It says that I return a ND array of shape n classes, confusion matrix whose ith row and jth column entry indicates the number of samples with true label being the ith class, which is the ith row, right? It means this is the actual on the top, right? Oh, sorry, actuals is on the column side and predicted is on the column side. Sorry, I did said it wrong. Read over here. What it says, ith row, and it is the true label. So row means this number. This is actual, and this is predicted. These kinds of questions I should actually ask you. Fantastic. This is the, any confusions over here? Now see over here how to read this thing quickly. Now what is this line saying? This line says that the category 0. Category 0 is what category? Category 0 is this t-shirts category, right? So this t-shirts category had these many actual answers, right? These many actual answers. 754 plus 2 plus 9 plus 58 plus 9 plus 2 plus 56 plus 0 plus 18. This is the total actual number of zeros, right? Actual number of zeros. But the model was only able to categorize 740 of them correctly. The model was able to, let's say, identify them correctly, only 745 of them. Do you all understand this thing? Now this 156, what does this mean? It means that these were actually 0, but the model predicted them as 6. Do you understand now? Let's take a simple example, one more, which is the category 6. Category 6 is your shirts. Category 0 was your t-shirts, and category 6 is your shirts now. So what is happening? These many were actual shirts, my friend, right? And out of them, only 643 of them were correctly identified. Only 643 of them were correctly identified, and others were wrongly identified. You can see that 117 of them were called as this category 4, right? 104 of them were called as category 0, which is your t-shirts. So shirts are getting confused with t-shirts. Do you understand now how to read it? And again, I would say, please go to this particular Wikipedia. This is the best resource ever. Nobody can beat anything. Just read this thing. You'll understand what is actually a true positive, true negative, false positive, false negative, and then you'll understand. Understood? What will you do now is you will optimize your data now. You will optimize, not the data, but your model now, and you will try to improve it to get somewhere around 90, 92, 93, somewhere around that, right? Again, I have done this model, so I know it goes up to upwards of 95. So that's the whole funda.
Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with iHub Divya Samparka, IIT Roorkee, and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence, and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
Okay, so I think most of you are thinking that loss is something that should be in the range of 0 to 1, right? Is this what you're thinking? Then you're absolutely not correct over here. Because if you notice, right, we are not using a normal loss. We are using a categorical cross entropy loss over here. So that might go above 1 also, right? But if you want to understand that thing, it is like the larger the number, the worse it is. The smaller the number, the better it is. Understood? This is not your normal loss. This is not your normal loss like this, where you say that my error is nothing but y actual minus y predicted. Do you remember this was the first original? Yes, this one is in the range of 0 till 1. If let's say you have this YA and YP are the probability. So Y actual is going to be 1 and YP, whatever the number is coming. So yes, this can be between 0 to 1. But if you notice, then we learned multiple iterations of this thing. We learned about a squared log. Remember, not log, sorry, error. Squared error to penalize it more. Now there this number might go, might be equal to 1 also. Right? But then later on, we came to use something called as log of loss. Remember categorical cross entropy? What is that? Does anybody remember the formula? What is categorical cross entropy? Categorical cross entropy says that I am not only going to penalize you for not giving me the correct answer because you are not what I said, but also that why are you saying something else, right? So very good, very good. Y of log y plus 1 minus y of log of 1 minus y. Very good, fantastic. Right? So we took this new data set called fashion MNIST, right? It is similar to what MNIST was, but instead of digits, it has clothing articles like t-shirts, tops, dresses, pullovers, your footwears like sneakers and shoes, right? Those kinds of 10 categories are here. You can see those 10 categories over here. Again, the same data, 28 cross 28 images, or grayscale images, right? Right. Okay. So what I've done over here is we made the model very quickly. We just made a very simple baseline model over here. We just took 2 hidden layers just to show you how to do that. And then we went around, then we trained the model. You see, we trained the model, took the same optimizer as HGD, losses as categorical. And what we did is we took this metrics as accuracy. And then we tried to learn how to save the model. Very simple, just say model.save. When you save the model, it saves 2 things. One is the architecture or the skeleton of the model. And the second thing is the weights. You can see the weights by saying model.getWeights. And if you want to see the skeleton, you can say model.toJSON, and it will give you the complete skeleton. Right now, it's in a dictionary or a JSON format, right? Also very similar to dictionary format. You can copy it into a online dictionary viewer or online JSON viewer, and you can see this like we saw yesterday. Then we learned about that how to predict images using the model.predict, right? If I have a new image now, test image, how do I check it? So we saw this thing that, there are 2 things that are required. First of all, that you have to normalize your images, right? And the second thing was that you have to expand the dimensions of the images. Why? Because the model has an expectation that it will that it is expecting something called as none, 28, 28, where none is nothing but, let's say, the number of images which is going to come. So if you are sending 1 image, you have to explicitly say 1, 28, 28. Correct? Okay, so then we did this thing. Then we used, that when you do a model.predict, it will not return you the answer as you're thinking like ankle boot. No, it will return you probabilities, right? It will return you 10 different probabilities for all the different categories, right? So all the 10 categories, it has probability. Our job is to pick up the probability, which is the maximum. You can see as softmax promised that all the sum of all the probabilities is going to be 1. You can see over here, it is equal to 1. Right, you can check for probability. It is 59% in our case. And how to get the index? That is np.argmax. np.argmax will give you the position at which the highest probability is. And then we figured out that, okay, it was ankle boot, right? So this was the image that we gave in, and this is the answer that came out. Then we made it into a function, much more simple thing. Now you can pass it to your function, and you can see that this was a t-shirt and top, and the model said it with the 73% confidence. Correct. Then we try to do multiple images. Can I predict? Yes, you can predict multiple images also. We did that also. And then finally, we also predicted that what are the wrong images which are predicted, right? So this is actually a sandal, but the model is saying this is a sneaker.
Right? This is very important to understand that yes, your model is getting somewhere around 84% accuracy, but what is the remaining 16% accuracy, 16% of the data where the model is not correctly identifying, right? So then we tried to make a function over here, which said that plot wrong images, and you can see over here, it is now plotting those wrong images. We saw these examples, 12, 21, 20, 12, 20, 21, you can enter them over here and you can see those images. Then we went into and draw the confusion matrix, right? This was the basic confusion matrix that we drew into the class yesterday, but then I went inside because I forgot. We can also do something called as confusion matrix display. What is confusion matrix display? This is just a, let's say, a fancier way of putting this rather than into a much more box like this. So I did into the sklearn. This is into sklearn matrix. I used confusion matrix display. I entered the confusion matrix over here. I said plot this particular thing, do the rotations as vertical because in horizontal they were overlapping with each other. I said the C map is going to be grays and the color bar is equal to false. Otherwise, that will show you on the right hand side a color bar, which is not required. So you can very easily see over here and demonstrate that this is where problems are happening. And one more good thing that is happening in confusion matrix display is that it also displays the true label and the predicted label. It tells you that this is the prediction and this is the true label. So now how do I read this 156? Can anybody help me? What is this 156? What is this 156 that is there on the screen? Wrong classification. But how do I read this thing? Very good, very good. That there were 156 t-shirts, actual t-shirts, which were counted as shirts, right? Which were counted as shirts. Very good. And how do I read this 104? This 104, how do I read this thing? These 104 were really shirts and they were confused with t-shirts. The model said that they are t-shirt. So you can either draw this, or I really like this one, right? It is confusion matrix display. Confusion matrix display directly displays everything, right? It gives you a very good view of what is confused and what is not confused, correct? 30% of the pullovers were wrongly predicted as others. Exactly, exactly. So for each category, right, you can do this thing. And I would just take an example. So our friend data pre-processing step can be rechecked. Okay, my 2 cents are that the categories are similar with minor differences, which means that either we need to get more training. Okay, a shirt versus pullover, sandal versus sneaker problem will happen anyways. Okay, so then what is the solution? Okay, very good. So you guys, first of all, understood that the problem is not always the balancing, right? Balancing is the first thing that we should check. You checked it and you said, no, Shivam, the data is balanced. Okay, the second thing that you are saying is that as a human level, they look very similar. Is this true at a data level also? You as a human say that, Shivam, these 2 images are very similar, t-shirts and pullover, they look similar. Your sandals and sneakers, they look very similar. How will you relate this back to the data point? Extra sandal shoe example, okay, but we forgot, correct? Do you remember, anybody of you remember that I specifically told you that there are some EDAs that need to be performed at image level? Those of you who are getting error, very good. See, first of all, let me write down what you need to do on Kaggle. The very first step is create an account on Kaggle. Go to settings and verify your phone, right? Third thing is in settings, create a new API and save the Kaggle.json file with you on your system. Correct. Now we will come to collab. First of all, upload your Kaggle.json file on collab. Second thing, import Kaggle.
it will fail, right? Move the kaggle.json file to /root/.kaggle, right? Import kaggle again. This time it will work, correct? Then what next? Go to the Kaggle competition and copy the download command, correct? Paste the download command and enjoy. That's it, nothing else. Okay, I will show it to you, all of you, once again, right? I mean, I will not show it to you that, that where my other things are. I mean, my account is already there, but I will just download a new token for you so that I can show it to you. Not working for me. Please wait, listen. You guys don't listen, Baba. Listen, 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 listen. Wait, right? First of all, let this runtime connect, obviously. Also, can I reduce my font size to this one? Font size to this one? Will it work for you? Now see, what I'm going to do is, first of all, see, what I'm doing is I am going to upload my kaggle.json. And you can see over here, the moment I have done this thing, it is over here. So first thing is upload your kaggle.json file on Colab. Listen to me now, right? How did you open the Colab? This Colab where I am right now. My friend, we have been doing this thing for some time, but this is the link. Click on this link, click on file, click on new, and this will open up a new Colab for you. Can we do it on Jupyter? This particular data set you can do, but I don't think you can do the next one. It will blow up your system. And it is your responsibility if some fire or your laptop crashes, right? No, just joking. Your system will not crash. Okay. So first of all, no was asking from, it was open from Kaggle or directly from Colab. No. See, this kaggle.json file you will get from Kaggle, correct? You have to upload it on Colab. Understood? Now I am going to say import Kaggle, and you will see it will fail for me. What I will say it is failing because it cannot find my file over here. I do this thing, and if I show it to you, this file is gone, right? And if I import this again, done. What we have done is we have downloaded and it has given us a zip file. So first of all, we need to unzip this thing and we need to see what is in this particular thing, right? I am using something called as -q. -q means that please do it quietly. Don't show me everything, right? Whatever you're doing. So if I do this thing, my friend, you will notice it takes some time, and this zip file process is, and if I refresh my folder structure, you will notice that it has given me three things. Sample submission.csv. Sorry. So sorry. And test1.zip, right? Train.zip. So see, because Kaggle is a competition oriented file, right? It's a competition led thing, right? So they ask you is that whenever your model is done, send your answers to us using this sample submission. So sample submission is of no use. You can delete it. Sample submission and CSV and test1.zip is of no use for us until and unless you are submitting your results on Kaggle back, which we will not do probably. What is this hyphen Q? As I told you, you guys don't listen, but hyphen Q to make the process non-verbose. See, try to do the same thing without a hyphen Q and you will understand. What is going to happen? It will tell you every progress it is doing. It is unzipping file 1, file 2, file 3, and there are 25,000 files over here. So you don't want to see that, right? But again, even if we see, right, it has given us these zip files again. So what I will do is I will zip this train file again and I will get rid of these two files. Delete and delete. I don't want these two files. The only one that I'm concerned is train.zip. So I will again do train.zip. And you will notice that it takes some time. 25,000 images are getting unzipped from this particular zip file. And you can see there is a folder called train made over here. Now I can show you this folder and then it will collapse. But I can show you this using this command called ls, right? That how many files are there, and you can see these many files are there inside this particular folder. cat31.jpg, cat32.jpg, dogs 121, 1200, these files are over there. I will get rid of this thing and I will go to you, right? Those of you who are not sure, there is always a library called OS. OS means operating system in Python, which can do all these tasks for you. So OS has one thing called as list dir. List dir will help you to share the content inside that particular folder. So what I'm asking is, I'm asking that list dir, it means list the content of this particular directory called train. And you can see over here, the moment I click on this thing, it tells me all the file name which were there, right? This list is very big. So what I'm going to do is I am going to, rather than looking at the complete list, I will take a length of this thing. So there are 25,000 images, my friends, over here, right? Very fantastic thing. 25,000 images are over here. And let me quickly also show you some images. Let's take any dog image, whichever comes first, we will take that one. And this is how you will read the files. Is this, am I doing it correct? Can I do plt.show and then the file name? Somebody should stop me. That's not how you can do it. Sometimes you guys are very, how do I say? Smart. Okay, I'm not using OpenCV2. I am using another library, PIL. We have already talked about it, just to show you. Below library, PIL, and this is one image of the dog. Right? This is another dog. And then similarly, there are cats also. Understood? Our first objective to get the data from Kaggle to Colab. Is this clear to all of you? I know there are some issues. We will talk about those issues right now. But is this objective clear? First of all, now there are two things. First of all, this is all real world data. And this is exactly how your client is going to give you. The client is going to make a zip file for you, give it to you, share it to you over some Google Drive or some Microsoft OneDrive or SharePoint, right? And from there, you will download it and you will get it to your systems. Understood? So this is now going all how we do in real world also. So, okay, what we did here very quickly, we connected our Kaggle. Kaggle has a little issue over here. Kaggle says that I don't know who you are, so please present your file.
File needs to be at a particular position. The moment you do this thing, Kaggle is now connected through your account. This file kaggle.json contains your identity, that who you are, have you verified the phone number or not. All these information are stored in this particular file. It connects. Now you can download any competition, but that you have either, let's say, we should also write it down over here, that please make sure that you have accepted the rules of competition. Correct? This is one thing that we have to make sure that we have accepted the rules of competition, and then we have done this thing. Correct? So this is the data set that we have, my friends. This is fantastic now, but the only problem is that the Keras, our friend, was helping us, and the Keras, our friend, was helping us in giving all the data. Keras was helping us convert all the images into array, right? He was doing it for us. But this time there is nobody who's going to do. We have raw images. How do we convert these raw images and how do we make it an array, my friends? That's the biggest challenge for us. Right? Say yes or no, something. I mean, don't you think it is a challenge? Or you guys are like, no, Shim, this is not a challenge. We can do it. If you can do it, then tell me how. In the meanwhile, you guys help me. One of my friends has said, Shivam, can you show us more images? Yes, why not, sir? Definitely, I will do this thing. np dot I in range 10 plt dot subplot 1 comma 5 comma I plt dot I in show. First of all, let me import some libraries. Import numpy as np, import pandas as pd. These two libraries. Okay. And then np dot random dot choice os dot list dir. Correct? Who can tell me what am I doing over here? One of our friend, his name is import cv2 also. We are doing this thing. cv2 dot im read and then image. And then we will say cv2 dot cvp color. What is this cv2 dot cvt color? Does any one of you remember? cv2 dot color bgr 2 RGB, right? And then we can say plt dot im show image. Correct? Is this right, my friend? What is this now? This integer number should be less than 5. So what has happened over here? I said range 6. Range 6 should give me only, okay, 1,6. Sorry. 1,6. Yes, it should not take a 0 over there. See over here now, what do you notice? Before we say anything, we figure out anything, do you notice something? You notice something. Okay, very good. And you say that, Shivam, that these images seem to be of different sizes and shapes. Correct? Very good. Let's try to put these images also on. Can I say it like this? So this is the shape. Okay, I did. Sorry. You can see now what I have done is I've done. Okay, so I have printed the shapes on the top. You can see, right?
one thing that I want to tell you is that first thing that I observed was that they are all 3 channel. They're all colored images, right? So this is not a single channel data set. This is a real world RGB data set, right? We can see every image has a 3 over there, correct? Second thing that we notice over here, that this data has different sizes of images, right? 500, 399, 200, 245, 375, 500, 275, 299. Very weird combinations are over here. So what do you think we can do now? See, one thing is for sure that our deep learning models are made to accept similar sized images. So what should we do now? Help me, help me, help me, help me, help me. Why did you write the just to increase the figure size, my friend, so that the images are visible? Figure size, this is not the question that you should ask me. Okay, find the maximum size. Okay, so one of my friends says find the maximum size and resize all the smaller images to that particular size. Correct? Okay, one of my friends says no, find the smallest size and then move everything to the smallest size. Okay, so how many of you, okay, and then there are some good answers, not good, but there are some other answers also. We'll try to answer them. But okay, what do you think? Should we go with the approach A, where they are saying that stretch all the images, STRECT, stretch all images to the biggest size, right? Or B, that squeeze all the images to a very smaller size? What do you think? Okay, A or B? Very good. You guys are getting smarter day by day. None of them, right? None of them. We should neither stretch our images to make it bigger. Why? Because then we are adding noise into the data. And we should neither, let's say, squeeze it down to the smallest number. Why? Because then we are losing a lot of much amount of data. Is this correct? Is this correct, my friends? So we should neither do full stretching, neither we should do the full squeezing. So we should come somewhere in between. Very good. As all of you very smart people are saying that we should come to where I really like this approach where people are saying come to the median size. Very good. Don't go to the mean, but the median size. Why median? Because where this, the skewness might help you. The skewness might skew the mean data and you have to go with the median size. Very good. So will you guys do this for me? Will you guys do this exercise for me and tell me what is that appropriate shape that we should take? So let's write down the question over here. Question. Find the best, not beast, best shape for images to be resized. Correct? That's a question that I've given to you. You guys will tell me, do your analysis, figure out what is the minimum shape, maximum height, minimum height, maximum width, minimum width. What should I take? What should I not take? You will do all these things on your own and you will help me get the answer. For the meanwhile, can you explain why not mean? Sorry, I forgot. Okay, see, listen over here. My friend, the difference between mean and median is that sometimes, and again, okay, let me say it again. I would never say that, go for the median. I will let you decide. Do one thing, calculate the mean and calculate the median. You will notice that if the data has skewness, the mean will also skew, right? It will skew your number, whereas median will keep it intact. I'll show you a quick example right now. Let's say if you have a list over here where people have, let's say, heights, right? So let's say people are, let's say, 170 centimeter, 168 centimeter, 172 centimeter, 180 centimeter, 160 centimeter, right? And if you find the mean of this thing, my friend, right? If you find the mean of this thing comes out to be correct, almost correct, 170, right? This comes out to be correct. But if I add just one anomaly over here, let's say somehow who's that guy? LeBron James, he comes up, right? He comes up and he is 280, right? See now what happens. Is this the correct representation? Is this, what is a mean? Mean is a number that should represent all the entities. Is this a correct number? Is this your data's mean? Average mean is 180. No, that's not. Why? Because this one number has changed everything, right? One skew has changed all these things. Whereas if I take a median, my friend, median will not be affected with this thing. I know median is not available like this, but let's try. See, I told you median is not available like this. Right? This is correct. So that's why you should focus on mean, median, when to get median, when to get mean. These are all things that you should know, right? You guys have done machine learning, correct? Okay. So this is something that you will tell me what is the best shape and size. For this session, we will take it as 150. I'm just taking it as an example. This might or might not be the correct approach, right? This might not be the correct number. I am just taking it as an example. I will go with 150, 150. Understood? Okay. Those of you who are telling me the answers about mean, median, very good. You guys do your analysis. You guys figure out, make a histogram for me for height, width. Don't just tell me the answer. Make a proper histogram for me. Tell me why have you taken that answer? Why do you think this should be the height? This should be the width. Please learn stakeholder management, right? This is also one thing that you have to learn as a data scientist. You think you will go to your vice president or a CFO and CMO and you will throw numbers at them and they will say, yes, 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 why not? Thank you, data scientist, for your help, right? Please take your bonus check. Go, have fun, go to Bahamas. That's not how life is, right? For every data that you give, you have to give the rationale behind it, why it is there, okay? Okay, coming back to the topic, where were we? We were talking about this thing, that how to convert. See, let's write down. In MNIST and fashion MNIST data set, we had the X-train and Y-train NP arrays, right? Do you all agree? There Keras made this thing. Today for dogs versus cats, we do not have an array. So the very first task for us is create a X train and Y train. Do you all agree? Do you all agree? Yes? Okay. So tell me how. How will we convert this image into a NP array? Very simple. My friends are saying just by reading that image. Very good, fantastic. I knew you will say this thing. Very good. Okay. So the very first thing that I will do is I will read that image, right? And I will convert that into BGR to RGB. I will also resize that thing and I will have the image. But how do I create an array out of it? And how do I make sure that my size looks like this? Do you all agree that our X train, how many of you agree that X train's shape should be somewhat like this? 25,000, 150, 150, 3. Yeah, obviously we'll remove it for, we'll remove it for test. But right now, do you think that this is what our shape should be? 25,000, 150, 150, 3. Those of you who are confused, please say no. Please say very big no in the chat. Capital NO. I will explain it to you right now. Nobody saying no, but I'll still. Yes, I believe. Very good. Okay, one of my friends says no. Very good. See, this is what I like. Just say if you don't know this thing, right? Okay. So my friend, tell me, when MNIST gave you this shape, what was the shape of MNIST? Do you remember? 60,000, 28, 28. Do you remember? What was this thing? Is this the same thing? That number of images, comma, height, comma, width, and if there exists any channel. Correct? Is this correct? Isn't it what we are saying here also? We are saying that we have 25,000 images of cats and dog, right?
We have 25,000 images of cats and dogs. The height and width that we are going to take today is 150, 150, right? Today we are taking 150, 150. Next class, you will tell me what is the height and shape that we will take. But for this particular example, we will take 150, 150. And what is this 3 in the end? This is the number of channels. No, it's not bad. Confusion, it's okay. It's fine. It's fine, right? Is it clear now? What is this? Number of images, comma 150, comma 150, comma 3. Okay. Before I proceed forward, do you guys have 30 minutes for me extra? I don't want to stretch it a lot, but see, if I don't complete this session today, it will be an overlap for you, and then you will have 1 week to not do anything. Just 30 minutes. Very good. Thank you. Thank you. Love you guys. Thank you so much. Okay. So what is the objective now? The objective is that I have to convert these images, and we have to make sure that we make an array of this case. Now, can you help me? How can we do this thing? Very good. Very good. One of my friends says, Shivam, make a very big list, store all the images in that list, and that convert that list into an array. Is this a correct approach? What I am saying is create a very big, not very big, I mean create a list, right? Append all images after processing in list, correct? And then convert that list into array. Do you all agree with this approach? One of our friends says, I think it will take a lot of time for 25,000 images. Who cares? We have time for the whole world. Anyways, we have to go and watch Netflix only. Rather, let's spend time over here. No, it will not take a lot of time. It will take 1 or 2 minutes, but not like if you're thinking 30 minutes or like that. No, it will not take. Do you all agree? This is what we should do. Can we try for an alternate approach with lesser time? So what do you think? What is the lesser approach? Help me. That's a good point. What is another approach? Okay. So no approach. That is something to think about. Very good. And we'll think about it when we are watching Netflix, right? We'll watch Netflix and then we will understand the approach. Okay, so let's do now. First of all, what we should do now, I want all of you to drop your pen, pencil, phone, whatever you're doing for 10 minutes. Don't even write code now. First of all, focus here now, right? Give me your attention. So what is this command os.listdir giving you?
Let's have a quick quiz question, guys. And the question is, which programming language is widely used for implementing machine learning algorithms and AI applications? And our options are Python, Java, C++, or Ruby. Please mention your answers in the comment section below. Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with IHUB Divya Samparka, IIT Roorkee, and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence, and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
If I write it down like this, what is it giving you? It gives you the content, every file that you have in that particular folder, right? And which basically means all the images that we have, correct? Basically means all the images. So what I'm doing is, my friend, I am going to run a for loop on this thing. I am going to say for image name in os.list this thing, and it will give me the image name, correct? Do you all agree? And if I do it for you, see over here, it runs for me, right? It gives me all the images. Very good. But do I need, should I worry about image names? No, I don't worry about image names. I actually need to
open up those images, right? See, I am doing one more thing over here. What I am doing is I am writing it like this. Can somebody tell me why am I writing it like this? Iterate over the train folder to get all the files. Now see, I am doing one thing over here. I am saying that image name is not just that name. Image name is actually train / the image name. And why do I say it like this? Because see, all these images are inside this particular folder, right? So whenever you are reading those images, you have to give the folder name and where they are. Understood? I'll repeat again. If I am going to write it down like this, cv2.imread, and then say directly dog.10.jpeg, will it read this file? No, because there is no such file called dog.10.jpeg over here. That is inside the folder train. Do you understand? Now it will work for you. Correct? So what we have done is over here is add folder name in the file name. Understood? I can show it to you also. See over here. It is now printing not just the file name, but it is also printing the folder name also. Understood? Very good. Now what should we do now? Once we have got the complete file name, what should we do now? We should delete the images. Correct? No, we should read the images. Yes, hey Baba. Read the images. Correct? So I will say image is equal to cv2.imread. And we will say image name. Correct? Then what we will do is, you know, CV2 has a big problem. What is that problem? That it reads the image in the format of BGR. We need to convert it into RGB. Very good. So we will say cv2.cvt color image, comma, cv2.color underscore BGR to RGB. Very good. What else should I do now? What else? What I've done over here now, we have to resize these images because these images are of different size and shape. And we want to convert them into 150, 150. Understood? One of my friends says, why do we need to convert to RGB from BGR? Can't we train BGR so that we can test directly from the BGR file? Can't we train a model on all the images where they are BGR only? Right? And that's a valid question. But the point is, my friend, that tomorrow, if some of your other friend, right, some of your different friend who does not know how this model was trained and brings an image from the internet, right, and reads it through some other library, that some other library is going to read it in which format? It is going to read it in RGB, correct? Then the point is your model will fail. And then you will be debugging this thing that where is my error? Where is my error? You will be banging your head left and right, and you won't be able to figure out the point. The point is very simple, that you didn't follow the standard procedure. That is why. But your point is totally valid. If let's say your images are coming from a controlled environment where you know that all of them are going to be BGR, you can definitely train the model with BGR images also. We have resized also. What should we do now? We should median array. Okay, array. So okay, let's do this one thing. Let's say all images. What I'm doing is I'm making this very big list called all images, and let's append all the images into this particular thing. This is a question for you, not for me. Do you read this? For this session, we will take it as 150, 150. Understood? Okay. Anything else that we're missing over here, my friends? Please, again, problem solving mindset. Problem solving, not OTT oriented mindset. Problem solving. Read it over here. You read the images, you converted them from BGR to RGB, you resized them. Anything else that we're missing? Normalize. Very good. That's a good point. That is a very valid point. Very valid point.
Normalize the images. Image is equal to image divided by 255.0. Our friend says labels. We need labels from the name. Okay, very good point. Very good, very good. That this all images is nothing but X train, right? Where do we get our Y train? How do we know that this image is a dog image? How will we know that this is a dog image, this is a cat image, this is a cat image? How do we know this thing? The client has not given us anything, right? The client has not given us any CSV file where they say this thing, or they have not written it any email to us. How do we know this thing, my friends? From the file name. Very good, very good. Now you guys are thinking. See, the labels were already present inside the image name itself. If you noticed the image names, and if I scroll up a little bit and if I show you, when we try to, let's say, draw this, plot this image, you can see over here, the name itself contains the label, right? So what we need to do is we need to write a logic. We need to write just a small logic over here that extract the label from this particular image name. So who, my friend, will come up and wants to give this logic? How do we extract the file name from this particular thing? Regex, very good. Build the regex for it very quickly. Split, very good, very good. Okay. In the meanwhile, actually, I think I should stop this and I should add the logic for all labels also. How should we write the labels logic? Image name 3,9, 6,9 can also work since cat and dog have 3 letters. Okay, very good. Can't I just simply say it like this? Like this. I don't know why you guys have a habit of making things complex, but I was just going to write it like this. No regex, no extraction, nothing. I just simply am writing a code that if the image name contains a label called dog, please write it as dog. If it contains a cat, please write it as a cat. That is it. Can we decode it to 0 and 1? Definitely. If you want, we can do it right now. You can do it like this also. We can make dog as 1, cat as 0. We have only 2 labels, right? What do you think by reading the Kaggle description? So see over here now, what we have done is, should we return something over here? I mean, it's just a for loop, right? It's not a function. Because I'm sorry, I didn't understood the question. We aren't returning anything here. Okay. So we have got these 2, and you can see over here, it contains 25,000 labels and 25,000 images, correct? What we will do is now, my friend, we will now convert this into X train. We will say np.array and all images, correct? And y_train np.array all labels, correct? Is this what we wanted? What is this answer? Okay, those of you who are saying keep it for give me just 1 second. Okay. What is the shape of X? Can somebody very quickly tell me? 25,000, 3,3. Very good. 25,000. Okay. Anybody else? Just 10 minutes ago, I wrote down this thing. Just 10 minutes ago. Just 10 minutes ago. Disappointment. You can see over here 25,000, 150, 150, 3, and Y shape is 25,000. Are we in the format of how MNIST was there. Was MNIST was also like this, right? So we are in a very good shape, correct? No, not exactly like 60,000, 25,000. I'm saying, but the format was same, right? The format was same, number of images. Let's write it down. This is what this is, a number of images, comma, height, comma, width, comma, channel, and this is number of labels. Correct? Okay. Now, who is going to help me? How do we divide this into? You guys were saying, right? You guys were saying in the chat, hey, Shivam, we want test data, test data, test data. Okay, you guys help me. How will you divide this capital X into X train and X test and Y train and Y test? Convert, or let's say not convert, let's say split X into X train and X test. Similarly, capital Y into Y train and Y test. We can't use Keras. This is not a Keras specific task. I mean, it's not a task over there, but I'm pretty sure that Keras might also have this thing. I haven't also used Keras over there, but let's check if you are saying tensorflow.keras.utils. It should have something. Sorry. It should have something for us. Image 2 is lead result, load, normalize, plot, progress bar, save image, sequence, select, split dataset. Here it is. You were correct. There is a split dataset, and it says what? Let's quickly check. It says that, let's delete this sklearn, and then we will use this thing. It says that give the data set and what is the left hand side that you want, right hand side that you want, shuffle, and then this thing. Okay. This is a TF object or a list or a tuple. Okay. So we have our left hand side and right hand side. Okay. But we need to also make sure that we are dividing this data into the same format, right? So what if we give it like this, capital X, capital Y, and we say left, I'll explain it to you, don't worry. Left hand side, let's say you want 0.9, and on the right hand side, you want the 0.1, right? Okay. Shuffle, yeah, we can do shuffle also. By default, shuffle is false. Let's do shuffle equal to true. And seed, those of you who are asking for seed, there's seed also, right? Let's try how this works. I also haven't tried this on a very long time. But see, that's how it is, right? See, I also don't remember everything, right? I also don't remember everything. So let's try this thing, X train, Y train, and X test and Y test, like this, right? And let's try to run this thing. Let's check if it works or not. And no, it does not work. Why? I'll tell you why. Let's say left and right now, and then see how it is returned. Okay. So now what is the type of left? Give me just 1 second. I'll explain it to you all the things. It's a kind of a perf thing. That is the problem. You have to do 2 numpy over here. Okay. So fantastic. So that's a stupid thing now because I have to now do a numpy over here. Control Z, Z, Z. Okay. So we'll use the sklearn thing only. Because that's a double way, right? First of all, I convert them into TensorFlow dataset and then I convert them back. But okay, I can use train test split from our best friend and we'll take his help. So our best friend test train help says that give me the arrays inside it and just tell me what is the test size, right? And in the meanwhile, I will return you in this format where it is the length of arrays, right? Okay. So we will say x underscore train, y underscore train, and we will say x underscore test, comma y underscore test is equal to trace train split x comma y, and then we will say test underscore size is equal to 0.1, right? Anything else that we have? No random state, shuffle equal to true by default, stratify none, which is already there. Okay. I am pretty sure this will not work. Why? Because this is the format in which it returns. See over here, this is what we just learned, right? Okay, fantastic. Okay, so what we have used is, we have used a regular train test split from sklearn. You just pass it into your capital X, capital Y, and just tell it that what is the size that you want. In return, it returns you X train, X test, Y train, Y test. Let's try to check the shape. What should be the shape of X train? What should be the shape of X train? It should be 25,000 minus 2,500, which is 22,500, comma 150, comma 150, comma 3, right? Very good. And what should be the shape of Y train? Y train should be simply 22,500. Similarly, I should write shape. Similarly, my friends, if I have X, Y test dot shape and Y test dot shape, you will notice I have 5,000 images, 2,500 images for testing, and then the label. I'll take a pause over here now. Do you understand this particular thing that we have done over here? First of all, taking these labels, how do we make this own, let's say, images into arrays, and then converting that array, splitting that array into test and train. Nothing, just simple things. Okay, see, I've tried to put up as much comments as I can, but still let me explain you one more time. I want your focus over here. First of all, we said that there are what is the objective of this for loop? The objective of this for loop is that if you want to start the modeling, my friend, the very first thing that you have to do is you need to have a big array, right? In that array, you need to have all your images and your labels, correct? But that labels were given to us by Keras, right? Keras would give us those labels called X train, Y train, X test, Y test in MNIST and fashion MNIST. But that is not going to happen when you will work in real world, right? In real world, the client will directly give you the images. The client will never share the array with you, right? They will not take the pain of reading all the images and then converting them into array and then giving it to you. They will directly dump the images to you. So the very first task for us is to read all these images and convert them into an array. Do you agree? That's what the objective of this thing is. So what we are doing is, my friend, to achieve that objective, we say that we will read the images, we will apply the appropriate pre-processing, which in our case is, first of all, convert them into BGR to RGB. If you are reading them from CSV, CV2 image library, right? OpenCV library. And then resize all the images to 150, 150. Correct? These are the two pre-processing things over there. Now, what we are doing is, my friend, in the first two lines, we made these very two big list.
one list for storing all the labels and one list for storing all the images, right? Then we start a for loop. Over here. In this for loop, now on what do we need to iterate, on what do we need to loop is all the images. Now, how do we get all the images? All the images are stored inside the folder called as train, right? All the images are present inside this folder called train. So what we will do is we will go inside this folder called train. How do we go? We will say by using this thing called as os.listdir. Now os.listdir, this particular function will return you all the files inside that folder. Once we have got that file inside the name called image name, we will append, prepend the name called folder, right? We will prepend the name of the folder. So now what is happening is the image name is not just the image name, but the full name, that where this file is present, correct? Then we read the image, then we convert the image, right? We convert this image into a BGR to RGB, right? And then we resize this image because all images need to be in one single format. For this particular session, we have decided to use 150.150 as the central location of the central size of the images. So we resize the images into 150. We can normalize the images also over here, but I have not done that. I will tell you later on why I have not done that, but we have not normalized these images, right? You can normalize these images over here. And then we are appending all the images inside the very big list called as all images, right? So all the processed images will go inside this very big list. Very good that we have got the input for the machine learning model, deep learning model. But do we have the labels for these images also? See, we need the input and the output also. We have the input, but where is the output? Where is the labels of these images? Right? Where do we have the labels? My friend, answer. Where are the images? Where are the labels of these images? The labels are automatically present inside the image name itself. So if you see, right, your file names already contain the labels. That is this a dog or is this a cat? So what just I wrote a very simple logic over here that if the image name contains a term called TOG, you append a 1 inside it. And if it is else, there will be, if there is not dog, it is cat, right? Otherwise, you can keep a explicit condition for cat also. And then you append a 0. It means what we have done is we have done two things over here. We have not just created the label array, but we have also label encoded it, right? We are saying that now dogs will be called as 1s and cats will be called as 0s. Understood? Why have I not normalized these images? As I told you, I will tell you later on, right? Understood? Now what we have done is we have got these very big lists now. All images contain 25,000 images and all label contains all the labels, right? All the labels for these images. Now what we do is, we can't work on list. We need to convert them into array. So what we do over here, np.array, and convert them all into arrays over here. And you can see over here, when I do it a shape also, you can see 25,000 images, each image of height 150, width 150, and number of channel 3. And we have labels also. We have 25,000 labels over here. Understood? Now this is capital X, capital Y. We need to divide them into train and test also. So for that, I used our OG library, sklearn, and I used a function called train test split, right? Using this train test split function, I was able to split the data into two parts, train and test. How? By saying that I want the test size to be 0.1, right? And then you can see the shape over here, the size over here.
Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with IHUB Divya Samparka, IIT Roorkee, and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence, and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
Earlier, let's say your array was storing all the images. Now it is storing images divided by 255. What is the problem over here? The problem is that when you loaded the images, my friend, they were into integer format. Original images are in integer format. I don't know if you noticed or not, but those images were in integer format. The numbers were in 0 till 255. 0 till 255, right? The moment you normalize them, they are converted to float. And all of you might know this thing. Those of you who are not from computer background, they might know this thing, and they should know this thing, that float takes more space, my friend, as compared to a integer. Have to normalize. Without normalization, we cannot send the images. If you have normalized your numbers, what is going to happen? The convergence is going to look very fast, right? Like this. But if you have not normalized, what is going to happen? It has to find the answer. It has to find that valley. Do you remember that gradient descent has to find that lower value in the valley? It will not converge very faster. It will be somewhat like this, right? It will gradually go down, but it will be in spikes. The confidence level is going to be very low because the searching area was earlier 0 to 1. Now you are saying it has to be done in 0 till 255. So here it is very huge. That is why we normalize these digits. Correct? And the normalized result will be saved in floats only. Because we have to normalize, we have to bring the range in 0 and 1. Now the point is, let's try to see the life cycle of the images, right? The life cycle of deep learning. So what do? First of all, we read data. Now the moment we read data, my friends, right? The data is stored in RAM, correct? So it means your RAM is going to crash now only, right? Your RAM is filled up right now only. It can't even process the next step of processing, right? Of pre-processing. Let me write down not processing. Let me write down pre-processing, right? Then you make the model, right? And then you fit the model, right? Model.fit. When you run the model, then in the first epoch, this data is required. Do you all agree? When you send your first batch of data, then images are required, correct? But you have stored the data inside your RAM in the very first step. Is this correct? Anybody who disagrees with my point, please say it right now. My point is that you have loaded something in your memory which is going to be required at the extreme end. And that is also not fully required. Why? Because let's say we have made with batch size 100, right? Let's say we have done a model.fit with batch size equal to 100. So how many images do I technically need now at this particular point? How many images do I need for my feed forward error calculation backpropagation at this particular point right now? 100 only, correct? So why have I loaded all the 25,000 images over here? Tell me one thing. Is this optimum resource of RAM? Is this optimum use of RAM? That you want only 100 images at a time should be inside your memory, but you have loaded 25,000. Is this correct? No, right? So the correct, let's say, method of doing this thing is that I should say that, have data. I will not say read data. I will say have data. Build pre-process. Don't do pre-processing. I am saying build pre-processing function. Listen to me. This is very careful. This is a very important thing. Please focus here. I am saying have the data collected wherever it is, right? Just have it with you. I am saying build a function. Then I am saying make the model. And then I am saying model.fit. When you do a model.fit,
And when you're running it for the first batch size of 100, this is where I tell you to read the data and process it also. This is where I'm asking you, read those 100 images only and pre-process them. Sorry, that I would, let's say, read all the 25,000 images over here. I can read it them over here only, right? But this will increase computation time. Very good. Yes. The only problem right now that you will have is that now your RAM will not crash, but you might have to do a trade-off between time now. Correct? You might, let's say, take more time because now you have to read these 100 images again and again. So your 100 images will, let's say, might take a little bit time, but otherwise now your RAM will any given time, how many images are there in my RAM? 100 only. Very good, fantastic. If these 200 images are done, these 200 images will not be taken in the third batch. Now these 300 images are done, it will make sure that these 300 images are not taken into the fourth batch, and then similarly more and more. So there's an internal track that we will keep a record of these images, and in one epoch you will have 250 batches, and it will always make sure that no batches are overlapping. This is your complete data 25,000. What I am saying is, my friend, that we will make, rather than taking this complete data, we will make it small batches like this, right? And each batch will contain 100 images. How many images? 100 images. And if I do like this, how many batches will I have? These 250 boxes that are made, my friend, these boxes are called as batches. Correct? Now what happens is you have to send the data, right, into your deep learning model, right? So first of all, there will be feed forward neural network. Then there will be a error calculation. And then there will be a gradient descent or backpropagation. You can call it anything, gradient descent or backpropagation. And this cycle keeps on moving, right? Now, the very first time, what is going to send? Very first time, E1, B1 will be sent. What is E1, B1? E1, B1 means epoch 1, batch 1, right? How many images are there in this epoch 1, batch 1? 25,000, right? No, very good. 100 images. Very good. These 100 images, my friend, will go and they will go in the feed forward, error calculation, gradient descent, come back again. Now the next batch will go. E1, B2. How many images are there? 25,000 minus 100. Very good. No, 100 again. Very good. So again, this batch will go. Again, this will be done. Again, this will be done. Now, what is happening is these two batches have unique images. They can never overlap. Listen to me. One batch cannot overlap with other batch. Now, what is going to happen? What will be the next batch? E1, B3. Again, how many images? 3 images, right? And at the end, what is going to happen? E1, B250. How many images? 100 images. In total, how many images have we traversed till now? We have traversed 250 batches. And each batch contains 100 images. So we have done 25,000 images. Correct? This is called as one epoch. This is called as one epoch. When your complete data set has traversed feed forward, error calculation, and gradient descent. This is called as one epoch. Now, is one epoch enough for the data? No, it is not enough. So this time we will do E2, B1, E2, B2, and then similarly E2, B50. And then similarly E3, E4, E5, E6. One epoch will handle complete data. One epoch will handle complete data. and one batch cannot overlap with another batch. Total 250 batches of 100 images each in epoch 1. Again, 250 batches of 100 images each, but the order of images had randomized. Yes, order will change. Is E1 B1 equal to E2 B2? No, 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 no. This is totally random than this E2 B2. Validation is done after once you're done with all the batches. When your epoch is done, then you will take your validation video. How SGD behaves here? Because of SGD, batch size remains single image. Optimizers, but because you have asked me, yes. The version of gradient descent that we are using is not stochastic gradient descent. This is mini batch stochastic gradient descent. Right? Stochastic gradient descent will take one image at a time. So do you all understand my concept today? What I was telling you? The concept is that yes, normalization is required, multiple epochs are required, and normalized results are saved in floats only. The only problem that we were doing in last classes was that we were reading this data unnecessary, which was not required. Correct? Do you all fundamentally agree or not? Forget about me telling you something, but fundamentally, does it make sense or not? That yes, that's not fair to read all the 25,000 images. Very good. Very, very, very good. 10th of June, not 19th, 10th of June. Image data generator collab, and here it is. Correct. Okay, so let's now learn what this image data generator is, right? And how do we use this image data generator? First of all, how many of you know what is a generator? Generator is a function which use yield keyword. That's the definition you're telling me. What is the generator? So I'll help you. See now, iteration function. Very good. See, this is the example. Very good. So generator says that, see, listen, if there is a big list, right? And if somebody is asking you for, let's say, a list, what you can do is you can run a for loop, and for loop will run for the end, right? Till the end. So it will give you item 1, item 2, item 3, 4, 5. There is no way to control this thing, correct? There comes the generator. Generator says that, hey, listen, I can, if let's say this list is very big, let's say this list is very big and you don't want the complete list, what you can do is you can control this list and you can send it in how much format you want, right? And how much detail you want. So generator will say that, okay, I will give you till 1 till 5 only. Next, I will give you 5, 10, 10 only. Then I will give you 10 till 15 only. Also, generators only work when they are asked to work, right? They don't work until and unless you, until and unless they are not asked to, correct? So this is what is going to happen. We will read all the data. I mean, we're not reading the data. I mean, we are just storing it into an index. And every time a batch is running, what is going to happen? These top 100 images, they will go and they will go in the function. What function? First of all, read the image and then pre-process the image. Let's say this is a function which is written over there. So only 100 images will go. The generator will take the first 100 images and will send the result. Next time, the next 100 images, then the next 100 images, then the next 100 images, and then the next 100 images. So image data generator is a kind of a generator which will take these number of images and will pass them through a function and will send it to you rather than sending all the 25,000 images. Is this clear? Understood? Very good. Very good. See now. So get data from Kaggle, right? So how do you get the data? First of all, I will say import Kaggle. Then I will upload my Kaggle.json. Once I've done that, then I will say mv root slash dot kaggle correct. Is this correct? Kaggle.json is the file name and the location is this. Okay, fantastic. Import Kaggle, very good. Can somebody help me with the competition link? Correct. And you can see I have already started getting the data. I will unzip this data. Dogs versus cats. And I will delete these two files, which I don't require. One is the test one, which is called as test1.zip. RM means remove, right? I don't want these files. And the second one is sample submission. I don't want this file also. Please remove these two files. They are also gone. And then I will say unzip -q train.zip. And you will notice that a huge folder is created. Very good. So we have this folder called folder train is created. Correct? Correct? One of our friends says, so you intend to use okay data set from train for test as well. Yes, yes, yes. We don't have any testing data, right? We don't have any testing data with us. Okay. So last time what we did is, last time we went inside this folder and read all the images and did pre-processing, right? But today we will not do that, right? Today we will not do that. Today what we will do, first of all, we will call our friends NumPy, Panda, and we will call our friend TensorFlow Keras over here, right? And through Keras, we will use something called as, and then we will use image data generator, right? But before we use image data generator over here and we go into the details, you need to understand that image data generator requires you to have data in a particular format. See, if your friend is doing all these help to you, he is doing this help to you, but he requires the data to be into a particular format, right? Data generator says that, listen, I can do all these things for you by not reading all the images, pre-processing them, sending it to Keras for batches and all these things. I will handle all these things. But you have to promise me that you will give me data into a particular format. Now, what is the format? Please focus here. Data generator says that first of all, you need to have a master folder. You need to have a master folder. You can call it anything. We will call it train, right? Or let's say train data you can have, right? Then it says that you need to have inside this particular, let's say, inside this particular folder, you need to have another folder called as the category 1. So how many categories do we have in our particular data set? Dogs versus cats versus dogs. How many categories do we have? 2 categories. Very good. And what are those categories? Dogs and cats. So it is asking you to first of all make a folder called category 1, which is your dog, right? And make another category which is your cat, right? Dogs and cats. Now inside this dog folder, my friend, you need to have all the what? Any guesses? No awards for guessing. All the images of dogs, right? Your image is like this, image 1 of dog, image 2, image 3, and so on, right? You need to have all the images of dogs over here. Similarly, inside cats also, you need to have all the images of cats over here. Understood? So this is what kind of a format they're asking. All of you understood, right? I will write it down here also just to make you explain you again. First of all, there is a bigger folder. You can name it anything, but it wants it like this. So we will name it called as train data. Inside this train data, we will have a dogs folder first of all, and then we will have a cats folder. Inside dogs folder, my friend, we will have all the images of dog, and inside these cats folder, my friend, we will have all the images of cat. Does it make sense? Understood? You can name this cat and dog folder also anything, but I would not recommend you to say it anything else. Why? Because then this is what the label names are, right? Keras will understand these as labels only. So I would suggest that always give them whatever category names that you have. In the image, if it is written on the image, it does not matter. Keras wants the format to be like this. Keras wants its format to be in this particular manner. It does not matter how the data is, how it is not. Okay. So let's now, first of all, convert this data into this format. So what is the first thing that we should do? What is the first thing that we should do? So mkdir is a kind of a, let's say, a function you from the OS library, which helps you to create the folder. So I am going to first of all make os.mkdir train folder. Then I am going to make mkdir train underscore data, and then I'm going to say cat. And in the end, I am going to say train underscore data slash docs. Is this correct? When I wrote it down over here, if you see on your extreme left hand side in the folder structure, this is how these folders are created. You can see, first of all, a master folder called train data. Inside that master folder, I've created a cat folder and a dog folder. Now what we have to do? Move cat images to cat folder and dog images to dog folder. Thing we have created the folder structures. Now we want the images inside these folders. We have to copy the images inside from the train folder to these cats and dog folder. How do we do that? Let me help you. All the images are inside this folder. Currently in this folder. Currently all the images are in this folder. This is the source folder, right? And you need to bring them to either to cat, either to dog based on some logic. Okay, so see over here. First of all, I am going to import a library called as shutils. What is this library shutils? This utils library helps us to copy some content from one place to another place, right? Can I say that the source folder is the train folder? Correct? And the destination folder, there are two destination folders. One is destination dog and another one is destination cat. Am I right? What is the destination? The destination is train underscore data slash cat.
and train underscore data slash dog. Is this correct? We all agree? 3 folders are there. The movement is going to be between them. Okay. Now what I am going to do is I am saying for image name in os.list dir inside the source folder.
Let's have a quick quiz question, guys. And the question is, what is a Turing test used in the context of AI? And our options are evaluating the speed of AI algorithms, assessing the creativity of AI system, determining if a machine can exhibit human-like intelligence, or measuring the efficiency of AI hardware. Please mention your answers in the comment section below. Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with iHub Divya Samparka, IIT Roorkee and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
Can I say this thing that for image name in the os.list dir source folder, right? That go inside the source folder and tell me all the image names, right? And if dog in image name, then I am saying shutil dot copy. I am saying shutil dot copy. Copy the image from where? First of all, if you see the syntax, it says what is the source and then what is the destination. So what is the source? The source is source folder, comma, plus image name. This is the source folder. And what is the destination? The destination is destination dog. And in else I can say shutil dot copy source folder plus image name, comma, destination cat. Obviously, shutil, the spelling is not correct. Right. I have plenty of image over here. See, my disk is what? I have 100 gigabytes of, 100 gigabytes of disk. I don't care. And then there can be 2 destinations, right? Destination is dog, destination is cat, correct? And you can see over here, what is happening over here is, you saw that all the images came over here, right? And let me show you os.list dir. Let me show you what is inside this folder of train underscore data slash dog. What will be there? All the dog images. See, all dog, all dog images. And how many of them are dog images? Let's do a length of this thing. And you can see these are all 12,500. And is this number correct? That is not. Otherwise, it will find it in this domain. Do you see any image in this area? No. You can see sample data, you can see train data, you can see dog versus cat zip, you can see this train.zip. But do you see those images? No. The images are inside the train folder. That is why I have to write the complete thing. Right. Arey, my friend. Okay. How many of you know this thing? That with trained data, whatever your training data that you have, you always have the labels with you. This is clear, right? That with trained data, labels are already given to us. So trained data, we have labels for the trained data already. Please explain the for loop. What is there to explain the for loop, my friend? Okay. And do a os.list dir. What is list dir? List dir means that tell me whatever files are there inside this folder, right?
What is the next if statement saying? The next if statement says that if the image name contains the term called DOG, if the image name contains the term called DOG, then please copy those images inside the destination dog, right? Else, please copy them into destination cat dot image data generator. Correct? Very good. Now, image data generator, let's see what it is asking us, right? Don't worry, there are so many things written over here, but we will just run it like this. We will say IDG. We will just write it like this. Okay, so what did I write down over here? I said IDG, that is it. And the moment I write it down, I write it down like this, IDG. Then I say IDG dot flow from directory, because we have used the option called flow from directory. Otherwise, there are three different options. One is called simple flow, one is called flow from data frame, and one is called as flow from directory. Flow from data frame, I will explain you. Don't worry, what is this? This is a much simpler version and much more easier version. But today we will learn the hard way. Flow from directory. What I am going to do now is, see over here. It asks you, first of all, what is the, it asks you the very first thing is the help not coming? Okay. The very first thing it is asking you is that please tell me what is the directory. What is the master directory? So what is the master directory for us? Master directory is train underscore data. Correct? All of you know this thing. Train underscore data is the master folder. The next thing it is asking you is that please tell me what is the target size that you want. It means that it will also auto resize the images. Do you remember in our pre-processing, we were resizing the images? You don't need to worry about it. It will also take care of that thing. So we can say target size is equal to 150, 150. And it will not just make sure that it reads the images, it will also resize those images. The next, it tells us that what is the color mode. It is RGB already taken. Classes is none. Why none? Because we have already given it the folders, right? And the last thing, which is more necessary thing for us, is that is called as batch underscore size. Batch size means that how many images. Do you remember in our example, I was saying to you 100 images, but you can take higher or lesser number, right? I will take 64. That my one batch should be made with 64 images. Again, this is the hyperparameter. You can change it in however condition you want, right? You can change it. And the answer comes out to be 300, 300, 350, 350, right? And I think, see, the friends are writing the numbers also. For this example, I'm taking a smaller number, 150, 150, just to make my things simple so that the model can run a little faster also for us. But you all, I will encourage you all to use a larger or the correct number, right? Just for running this thing, I am using the, I'm using this 150, 150, okay? And one last thing that we have in this particular data set, sorry, not data set, in this particular function is that we have to tell it the, where is that thing? Where is that thing? Stupid thing, subset. Here it is. Now, what is this subset? Okay, first of all, let me not run subset. Let me just show it to you like this. And if I run this thing, my friend, what is going to happen? Will it read all the images? What do you think what has happened? Had it read all the images? And see your RAM over here, the RAM utilization, nothing has changed. It is still 1.6 only. Has it read all the images? The answer is no. It has not even touched the images. It just went inside those folders and it just did a basic sanity check for you. And it told you that, hey, listen, you have 25,000 images and they belong to 2 classes and your RAM didn't even blink also. Generator function is ready now for us, right? There are a few tweaks that I will tell you a little later, just in this session only, we will run the model. We'll go for a break now, a small break. And when we'll come back, we will make a model now on this. One of my friends says classes is decided basis the folder. Yes, yes, based on how many folders are there, it tells you. It visited 25,000 images. No, it has not visited 25,000 images. It is just saying that it went inside this bigger folder. It counted how many images are there and how many folders are there. So it told you there are 25,000 images it found, and it found them across 2 classes. Is this clear? What will be the format of image data generator in the class of image has more than one category? It in like both cat and dog and same frame. That you can do. That you cannot do, right? As I told you in last class also, if you have both the categories inside the same image, then it is worthless, right? Okay, let's say if a house is also at a beach and is also apartment, what will your house prediction model say? Let's say you have a house type prediction model, right? And based on the properties of the house, right? Based on the attributes of the house, it can tell whether it is a beach house, whether it is an apartment, or whether it is a mansion, right? Now tell me one thing. If you have an apartment which is on the beach, will your model say both the answers? No, your machine learning model will only say one of them, correct? Which has higher probability, it will only give one answer. Is this correct or no? And I'm asking you, basis your machine learning things. Don't think about deep learning. Just tell me what does your machine learning will do. Your machine learning will only give you one answer, right? It can't create a third category called beach plus apartment, correct? Similarly, here also, my friends, if there is a image, see your model, you're training a model for cat or dog, right? You are not training a model cat and dog. So if let's say there is a dog also and there is a cat also, whoever's feature are much more brighter, whoever's feature are much more bigger, right? The model will give the answer as like this, but it will never say it has a cat and a dog also. No, it will never say that. Understood? So it has saved a list of file names somewhere in the object. Yes, correct. It has gone, it has checked for all the images and how many folders are there. It has stored it somewhere. Exactly. And what somewhere, you can see all these things over here inside. I don't want to show you all the details now, but everything is stored over here, right? How many class indexes are over there, how many modes are over there, what are the directories where it is saved, right? What are the file names which is saved, right? It can tell you all the things, right? My friend, all the things are saved inside this particular thing. You're asking this question. I forgot who was asking this question. Yeah, somebody was. Okay. So it has saved all these things over here. We'll go for a break now. And when we come back, we will run the model today using image data generator. And I will show you that the RAM is not even going to cross 2 gigabytes, right? Okay, but in the classification would be normal. I'll explain this categorization thing a little later, right? Let's focus right now on this thing, right? Which is, I think, much more important for me. So, okay, the very first thing that, very good. So there are 2 things that my friends are saying. My first of my friend says, why are we not making validation data? Okay, so the very first question is, why not validation data? Okay, validation data. The first thing my friend is asking. So let me help you with both the things. First of all, see my friend, when you're making a generator, right? In generator, you can specify that, hey, listen, this 25,000 data that I have made for you contains a split. How much split? A split of 10%, similar to what we did in last time also, right? And then there is something also called as rescale. There is something called as rescale. Rescaling is nothing but your normalization. Rescale means that you multiply this number with all the images. This rescaling is nothing but normalization, and validation is this 0.1 that I've done over. right? I will run this thing again. Now this time when I am writing this thing, what I will do is I will also say it like this: subset is equal to frame. Now see over here, please see the magic. What is going to happen over here? This is what is written over here right now. It says 25,000 images for 2 classes. But the moment I run this thing, it changes and now it says 22,500 images belonging to 2 classes. What happened over here? What just happened? That the validation split of 10%, those 2,500 images are now gone from this data. So for validation data also, you will need to create another generator called as flow from directory, right? And you will say that my directory is what? My directory is train underscore data. You will say my target size is 150, 150, and our batch size is batch size, right? And sorry, and what? And my subset, that this generator that I'm creating for you, how will Keras know who is what for what, right? So you have to give the name. Now it will understand, right? That for training it is this, and for validation it is this. And you can see now that this is 22,500 images belonging to 2 classes. Understood? Go inside the image data generator, and I want to create a generator where I want to have a split of 10% to validation and 90% for training, right? And I also want to make sure that my images are rescaled. It means that you divide them with 255.0, right? So we wrote this thing like this. Then we said that this IDG is prepared now. Image data generator is prepared. Now, how do you want to read this image data generator? So image data generator, there are three ways in which you can read through it. One is simple flow, one is flow from data frame, which we will study later. And then another one is flow from directory. In the directory, we told it that we want our master directory is train data. It means this folder where we have our subcategory that we have prepared for Keras. And then we are saying that please resize our images also. Please, when you read those images, these images are into different formats, right? Please read those images and please convert them into what shape? 150, 150. But also remember that give me a batch size of batch size. It means give me a batch size of 64. It means once you read, you will read only 64 images. And then to it also understand that whether it is for training or validation, we give it a name called subset is equal to training. The moment it reads this thing, it understands that, okay, this particular one is for training data. So the moment I run this thing, you can see it says found 22,500 images belonging to 2 classes. Why 22,500? Because this is for training data. So it has subtracted the 10% of 25,000, which is 2,500. Right? Then we made this second kind of generator, again from flow from directory, same target size, same batch size. The only difference is this time we are saying subset is validation. The moment it reads this statement subset validation, it goes and it says that I need to read only how many images? 10% of the images. So you can see 2,500 images belonging to 2 classes. Is this fine? What happens if we do not name subset? If you do not keep this thing, it will read all the images. We have just written some function and the generator has understood the function. It has done some sanity checks, some simple checks like how many classes are there, how many images are there. That's it. It has not read anything. It has not even done this transformation. Nothing. This all will happen only when we do model.fit. At any given point, how many images will be there in the RAM? 64. Very good. Only 64 images will be there inside the RAM. From df.keras.models.sequential. Very good. Okay. So I will make the first 2 layers and then you will help me make the last 2 layers. Okay. So the very first layer, which is the most difficult one, let me help you over there. Right, the layers. Okay, I will help you in the outer layer also. Okay, enjoy. Today I'm going to also help you with the input and output layers. Two very important layers. In the input layer, what does it ask you? What is the first thing it asks you is that what is the input size? Then it is asking you the name. Give it the name also. Input layer. The next thing that we will do is model.add. Right? Model.add and tf dot keras dot layers dot flatten. Okay. Flatten. And then I will say name equal to flat. Which layer to take and how many activation functions, oh sorry, how many units should I take, and then activation I will take as tf dot keras dot activations dot hello. How many? 128. Okay, 128. Can we take two hidden layers? You help me. You guys will help me. How many layers? What layers? You help me. You want two layers? Very good. Let's have two layers. What should I take for next layer? Change 512 to 256. Let's go. Let's try what happens. Wait, let's try. Okay, so we made the model over here, and this is a 34. Actually 34.5 million parameters. Oh, fantastic. Woohoo. Congratulations. Which is fine. I am again not saying anything. This is hit and trial. You all should try this. Okay, what should we do now? We should say model.fit. Correct? But this time we don't have anything called as X train or Y train. This time we have something called as train IDG. Correct? And this time we will say batch size. We have already decided, right? So we will say batch size only, right? Because batch size is now decided by the generators. Okay. And you can actually give your val IDG also over here. Or what you can do is you can say validation data equal to val underscore IDG, right? And how many epochs? How many epochs? 10. Let's run with 10 at least. 30. Definitely we will run 30 also. But let's run this thing, right? See, we have done the rescaling, we have done the resizing, we have done the all things, right? Okay, so let's run this thing. And it did not work for us. Why? Compile. Exactly. Very good. My friend Nikhil actually said this earlier in the chat. Sorry, my friend. Sorry. Excitement. Right. So the very first thing is optimizer. I will use SGD. I will use tf.keras.optimizer.std. Second one is the loss, which is tf.keras.losses. Dot categorical cross entropy, and the last one is metrics, which is ACC. Right. Okay. And this thing and again, and you will see that your first epoch is gone. See your RAM also. It's not even going 3 gigabytes. It's stuck at 2.3. And you all understand the rationale now, right? You all understand why it is not increasing also. Tomorrow somebody asks you that why is the RAM not increasing? You have the rationale. That, hey, listen, because at any given point of time, right? One of my friends says, can we take batch size equal to 100? Why only 100? Go with 128, 512 also. Try if your RAM is not crashing. Increase it. No issues. But do you see the trade-off what is happening now? Your data model is now crying. It is almost taking 2 minutes to run this thing. Right? Almost taking 2 minutes. So let me do one thing. As I think our friend was saying, can we go with the higher one? So let's go with the higher batch size. Where's the batch size? Here it is. Let's make it 512. Right? And I will also delete my model just to make sure that something has it will just be done. Okay. One of our friends says, was the image data generator created in order to overcome the RAM crash problem? Yes. Yes. We are using disk as the waiting zone instead of flooding the RAM. Very good. That would be lot, this batch size. I did 512, it's not crashing. I mean, the RAM increased now. See, it's touching now 300 some gigabytes, which is fine, right? Fine. And then it's not just us, but the whole company goes in the pain and the client says, yeah, your RAM is also crashing every time you make this thing. Is it your code or that, you know? So it's a trade-off that you will need to decide that you have higher RAM, go without image data generator. Who says buy a 1 TB of RAM, buy a 1 TB of RAM and then do it. Nobody's stopping you. But everybody cannot afford this thing, right? So that's the problem. One of my friends says, but irrespective of batch size, all images have to be read, right? Yes, that's a problem. So in totality, you can never beat the time that we were doing in last week, right? Last week, everything was read already. If for every epoch, we had read it. This time, it is going to read these things again and again, again and again, again and again, again and again, again and again. So if you are running it for 10 epochs, 10 multiplied by 44, right? So 440 read operations are happening. So obviously you cannot beat that. One of my friends says, would we need to show the training process to the client? No, never. Why would you show that? Why would you run this training in front of a client? Never. You would show them the end product. Do you go in front of a client and then write the code? Let's say your client has asked you to make an Android app. Do you go in front of them and then write the code? No. You show them the end result. That's what is happening in deep learning also. You will show them the end result. You can only enjoy something once you understand the value of it, right? If I don't show you the value, see, especially those of you whose RAM has crashed, correct? Those of you who have been irritated by this thing, you know, that my RAM is crashing, my again and again, Shivam, I have to make this Kaggle, join the Kaggle and then read the data again. Those of you who are frustrated, only those people can respect what, or let's say can appreciate what image data generator is doing today. What are the results helping now? Now we don't need a manual person to go and inspect those things. I'll give you my example. So my very first project of deep learning was that we had rail tracks, right? And on these rail tracks are going these different cargo trains are going. And initially there was a manual person who would sit down and who would, let's say, check all these cars that whether they're logged or not, right? And each car has its own function. So there are tank cars, if you might have seen, tank rail cars are there. Then there are Golconda tank cars, then there are flat cars, right? And everything has its own, measuring things, right? That it can faults that can happen. So in a tank car, there's a nozzle, right? On the top there's a cover, and on the lower side there's a nozzle. The nozzle need to be shut down for a 350-degree angle. So this person would manually go and check this. And now imagine there is a train, and a train generally in US trains have 300 to 350 cargoes attached to it. So this person would manually go and check these things one by one, one by one, one by one, one by one. We propose that we will make a solution for it. What we will do that, let's say we will make a oval kind of a, let's say, solution, cross solution, and this is your rail tracks, right? So your rail track has to cross through this oval kind of thing, and this oval thing had, let's say, multiple high-speed action cameras attached to it, right? Every time a train would pass through this particular, let's say, cross section, oval cross section, it will take high-speed action camera images through it. We would send it to our machine learning, deep learning model. First of all, it will detect what kind of train it is, and then it will find the faults. Now, this person has to not check these things for 350 trains. It will only check for suspicious ones, which is now reduced to 17, 27, around 27, 25. That's it. So now see how much time we are saving, right? Those trains don't need to stop there. And trains are not like this that you can, it's not like a key, you can stop them. It's a big diesel engine. It's a big electric engine. You can't just stop it in the meanwhile and then say, okay, go and inspect. So yeah, that's, so think from a longer perspective, right? That are we saving carbon or are we burning carbon? And that's a very good topic. You should definitely find some research. I have some papers with me that we generally attach. I'll send you those, and I can give you some very good names of AI researchers who are working in this field of sustainability. Very good topic and very good thing over there. Right? Yeah, first epoch ran, you can see now the accuracy is 51, 55, 57. Tracks would lose, you know, the oil would lose almost its density, and almost a 15% leakage would happen. Now we are saving those 15% of oil for every car. And if a car has 300, let's say, cargo, right? And let's say even 10% of them are faulty, you have saved so much oil, right? So yeah, that's the whole thing. And in US, right, see, these things are taken with very high precision and care. You know, everything is through a playbook. You have to check these things and right. Okay, so let's come back to the topic, right? So you can see over here, we trained this model, but the very good thing is that this thing is not increasing. This thing is stuck at 3 gigabytes. You all can see, right? It has never, ever increased. So now your RAM crashing problem is done, right? The model is going to take another 17 minutes to complete. It's all up to you, guys. This is your problem, right? Do these different hyperparameters. What hyperparameters can you use? You can use batch size as a hyperparameter. You can use learning rate as a parameter in your SGD. These layers is the activation. Layers in the model, and then activation. These units in each dense layer is also a hidden hyperparameter. Do these things.
Just a quick info, guys. Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with iHub Divya Samparka, IIT Roorkee, and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence, and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.
So let's start with machine learning interview question. Here is your first question. It is a kind of pretty basic question, and the question is, explain machine learning, artificial intelligence, and deep learning. It is very common to get confused between the three in-demand technologies, which are machine learning, artificial intelligence, and deep learning. These three technologies, though a little different from one another, but are quietly interrelated. While deep learning is a subset of machine learning is a subset of artificial intelligence. Some terms and techniques may overlap in these technologies, and it is quite easy to get confused among them. So let's learn about these technologies. If I talk about machine learning involves various statistical and deep learning techniques that allows machines to use their past experiences and get better at performing specific tasks without having been to be monitored. If I talk about artificial intelligence uses numerous machine learning and deep learning techniques that enable computer systems to perform tasks using human-like intelligence with logic and rules. If I talk about deep learning, then deep learning comprises of several algorithms that enable softwares to learn from themselves and perform various business tasks, including image and speech recognition. Deep learning is possible when systems expose their multi-layered neural networks to a large volume of data. I hope so, guys, you would have got brief idea regarding machine learning, artificial intelligence, and deep learning. So our next question is, what is the difference between bias and variance in machine learning? The answer to the same question is that bias is the difference between the average prediction of a model and the correct value of the model. If the biased value is high, the prediction of the model is not accurate. Hence, the bias value should be as low as possible to make the desired predictions. If I talk about the variance is a number that gives the difference of predictions over a training set and an anticipated value of another training sets. High variance may lead to large fluctuations in the output,
Therefore, a model's output should have a low variance. If you could see in a diagram, you could see the following trade-off. So here is a bias and variance trade-off. Here is a desired result in the blue circle at the center. If we get off from the blue section, then the prediction goes on wrong. I hope so guys, you would have got a brief idea regarding the difference between bias and variance in the machine learning. Now let's move on to our next question. Our next question is, what is clustering in machine learning? If I talk about clustering, clustering is a technique which is used in unsupervised learning that involves grouping data points. The clustering algorithms can be used with a set of data points. This technique will allow you to classify all the data points into their particular groups. The data points that are thrown into the same category have similar features and properties, while the data points that belong to a different group have distinct features and properties. Statistical data analysis can be performed by this method. Let us take at some of the examples. Some of the examples can be k-means clustering. If I talk about the k-means clustering, this algorithm will be commonly used when there is a data with no specific group or category. K-means clustering allows you to find the hidden patterns in the data, which can be used to classify the data into the various groups. The variable k is used to represent the number of groups the data is divided into, and the data points are clustered using the similarity of features. Here, the centroids of the clusters are used for labeling new data. Another clustering algorithm can be mean shift clustering. If I talk about the mean shift clustering, the main aim of this algorithm will be to update the center point and the candidates to be mean and find the center points of all the groups. In mean shift clustering, unlike k-means clustering, the possible number of clusters need not to be selected as it can be automatically be discovered by the mean shift. So here are some of the examples of the clustering algorithms. I hope so guys, you would have got a brief idea regarding what is clustering in machine learning. Now let's move on and discuss our next question, which is, what is linear regression in machine learning? This is the most popular questions which is asked in the machine learning interview. Now let's discuss the answer of the same. Linear regression is a supervised machine learning algorithm which is used to find the linear relationship between the dependent and the independent variables for predictive analysis. Here the equation can be, consider y equals to a plus b dot x, where x is the input or the independent variable, where y is the output or the dependent variable, and a is the intercept and b is the coefficient of x. You can see here the diagram with best fit shows that the data of the weight y or the dependent variable and the data of the x of the independent variable. Here the straight line shows that the best linear relationship that would help in predicting the weight of the candidates according to their height. To get this best fit line, the best values of a and b should be found. By adjusting the values of a and b, the errors in the prediction of y can be reduced. This is how the linear regression helps in finding the linear relationship and predicting the output. I hope so guys, you would have got a brief idea regarding what is linear regression in machine learning. Now let's move forward and discuss our next question. Our next question is, what is decision tree in machine learning? If I talk about the decision tree, a decision tree is used to explain a sequence of actions that must be performed to get the desired output. It is a hierarchical diagram that shows the action. This algorithm can be created for a decision tree on the basis of the set of hierarchy of actions. In the above decision tree diagram, a sequence of actions has been made for driving a vehicle with or without license. So you can see how the decision tree algorithm works in the machine learning domain. I hope so guys, you would have got a brief idea regarding what is decision tree in machine learning. Now let's move forward and discuss our next question. Our next question is, what is overfitting in machine learning? Actually, overfitting happens when a machine learning has an inadequate data set and tries to learn from it. So overfitting is inversely proportional to the amount of data. For small databases, overfitting can be bypassed by the cross-validation method. In this approach, a dataset is divided into two sections. These two sections will comprise the testing and training dataset. To train the model, the training dataset is used, and for testing of the model for new inputs, the testing dataset is used. This is how we can avoid the overfitting. I hope so guys, you would have got a brief idea regarding what is overfitting in machine learning. Now let's move forward and discuss our next question. Our next question is, what is hypothesis testing? If I talk about the hypothesis testing, machine learning allows the use of available dataset to understand a specific function that maps the input to the output in the best possible way. This problem is known as a function approximation. Here, the approximation need to be used for the unknown target function that maps all plausible observations based on a given problem in the best manner. Hypothesis in machine learning is a model that helps in approximating the target function and performing the necessary input to output mappings. The choice and configuration of algorithms allow defining the space of the plausible hypothesis that may be represented by the model. In hypothesis, the lower h is used for a specific hypothesis, where the uppercase H or the capital H is used for hypothesis space that is being searched. So this is what exactly the hypothesis testing is. I hope so guys, you would have got a fair idea regarding what exactly is hypothesis testing. Now let's move forward and discuss our next question. So our next question is, what is the difference between supervised and unsupervised learning? If I talk about the supervised learning, the algorithms of the supervised learnings used the label data to get trained. The model takes the direct feedback to confirm whether the output that is being predicted is indeed correct. Moreover, both the input data and the output data are provided to the model, and the main aim here is to train the model to predict the output upon receiving the new data. Supervised learning offers accurate results and can largely be divided into two parts, which is classification and regression. If I talk about the unsupervised learning, the algorithms of the unsupervised learning use unlabeled data for training purposes. In unsupervised learning, the models identify hidden data trends and do not take any feedback. The unsupervised learning model is only provided with input data. Unsupervised learning's main aim is to identify hidden patterns to extract information from the unknown sets of data. It can also be classified into two parts, which is clustering and association. Unfortunately, unsupervised learnings can offer results that are comparatively less accurate. I hope so guys, you would have got a brief idea regarding what is the difference between supervised and unsupervised learning. Now let's move on and discuss our next question. So our next question is, what is bias theorem? If I talk about the bias theorem offers the probability of any given amount to occur using the prior knowledge. In mathematical terms, it can be defined as a true positive rate of the given sample conditions divided by the sum of the true positive rate of the said conditions and false positive rate of the entire population. Two of the most significant applications of bias theorem in machine learning are Bayesian belief networks. This theorem is also the foundation behind the machine learning brand that involves naive Bayes classifier. So as you can see the formula here, P of A by B equals to P of B by A dot PA divided by PB, where P of A by B is a probability of occurring B given the evidence B has already occurred, where P of B by A is equals to probability of B occurring given the evidence A has already occurred. Here PA is a probability of A occurring and PB is a probability of B occurring. I hope so guys, you would have got the idea regarding what is bias theorem. Now let's move on and discuss our next question. So our next question is, what is PCA in machine learning? If I talk about the multidimensional data, it plays an important role in the real world. Data visualization and computations become more challenging with increase in the dimension. In such scenarios, the dimension of data might have to be reduced to analyze and visualize it easily. This is done by removing irrelevant dimensions and keeping only the most relevant dimension. This is where the principal component analysis is used. The goal of the PCA is to find a fresh collection of uncorrelated dimension or orthogonal and rank them on the basis of variance, which defines the process of PCA in machine learning. I hope so guys, you would have got a brief idea regarding what is PCA in machine learning. Now let's move on and discuss our next question. Our next question is, what is SVM in machine learning? If I talk about SVM or support vector machines, it is a machine learning algorithm that is majorly used for classification. It is used on the top of the high dimensionality of the characteristic vector, which basically defines what SVM is in machine learning. I hope so guys, you would have got a fair idea what are support vector machines in machine learning. Now let's move on and discuss our next question. So our next question is, what is cross-validation in machine learning? If I talk about the cross-validation allows a system to increase the performance of a given machine learning algorithm which is fed a number of sample data from the dataset. This sampling process is done to break the dataset into smaller parts that have the same number of rows, out of which a random part is selected as a test set and rest of the parts are kept as a train sets. Cross-validation consists of the following techniques, which can be hold-out method, k-fold cross-validation, stratified k-fold cross-validation, and leave p-out cross-validation. I hope so guys, you would have got a fair idea regarding what is cross-validation in machine learning.
Let's have a quick quiz question guys, and the question is, what is the main ethical concern associated with the development of AI and autonomous systems? And your options are ensuring they are completely error-free, or protecting intellectual property rights, or ensuring they are affordable for everyone, or ensuring they make fair and unbiased decisions. Please mention your answers in the comment section below.
Our next question is, what is entropy in machine learning? The answer to the same question is, entropy in machine learning measures the randomness in the data that needs to be processed. The more entropy in the given data, the more difficult it becomes to draw any useful conclusion from the data. For example, let us take the flipping of a coin. The result of this act is random and it does not favor heads or tails. Here, the result of any number of tosses cannot be predicted easily as there is no definite relationship between the action of flipping and the possible outcomes. I hope so guys, you would have got a brief idea regarding entropy in machine learning. Now let's move forward and discuss our next question. Our next question is, what is epoch in machine learning? If I talk about epoch in machine learning, which is basically used to indicate the count of passes in a given training dataset where the machine learning algorithm has done its job. Generally, when there is large chunk of data, it is grouped into several batches, and all these batches go through the given model, and this process is referred to as iteration. Now, if the batch size comprises the complete training dataset, the count of iteration is same as that of epochs. In a case, there is more than one batch, which is equals to d.e equals to I star b, which is a formula where d is a dataset and e is the number of epochs and I is the number of iterations and b is the batch size. So you can remember d.e equals to I.b, where d is a dataset, e is the number of epochs and I is the number of iteration and where b equals to batch size. So this equation generally defines the relationship between epoch, dataset, iteration and number of batches. I hope so guys, you would have got a fair idea regarding what is epoch in machine learning. Now let's move on and discuss our next question. Our next question is, what is the variance inflation factor? The variance inflation factor is the estimate of the volume of multicollinearity in a collection of many regression variables, where VIF equals to variance of the model divided by variance of the model with single independent variable. That's it for variance inflation factor. I hope so guys, you would have got a brief idea regarding what is variation inflation factor, and it is one of the most important questions which can be asked in a machine learning interview. Now let's move on and discuss our next question. So our next question is, what is a confusion matrix? If I talk about the confusion matrix, it is used to explain model's performance and gives the summary of predictions of classification problems. It assists in identifying the uncertainty between classes. Confusion matrix gives the count of correct and incorrect values and error types according to the model, where you can see accuracy is defined as TP plus TN divided by TP plus TN plus FP plus FN. I hope so guys, you would have got a fair idea regarding what is confusion matrix. Now let's move on and discuss our next question. So our next question is, what is the type 1 and type 2 error? Type 1 error is false positive, is an error where the outcome of a test shows the non-acceptance of a true condition. For example, suppose a person gets diagnosed with depression even when they are not suffering from the same. It is a case of false positive. If I talk about the type 2 error, Type 2 error or false negative is an error where the outcome of a test shows the acceptance of a false condition. For example, the CT scan of a person shows that they do not have a disease, but in fact they do have a disease. Here the test accepts the false condition that the person does not have the disease. This is a case of false negative. I hope so guys, you would have got an idea regarding what are type 1 and type 2 error. Now let's move on and discuss our next question. So our next question is, when should classification be used over regression? Both classification and regression are associated with prediction. Classification involves the identification of values or entities that lie in a specific group. Regression entails predicting a response value from the consecutive set of outcomes. For example, if you want to predict the price of a house, you should use regression since it is a numerical variable. However, if you are trying to predict whether the house situated in a particular area is going to be high, medium or low priced, then the classification model should be used. I hope so guys, you would have got a fair idea that when should you use classification over regression. Now let's move forward and discuss our next question. So our next question is, explain logistic regression. This is also one of the most asked questions in a machine learning interview. So logistic regression is a proper regression analysis when the dependent variable is categorical or binary. Like all regression analysis, logistic regression is a technique for predictive analysis. Logistic regression is used to explain data and a relationship between one dependent binary variable or one or more independent variable. Logistic regression is also employed to predict the probability of categorical dependent variables. Logistic regressions can be used in the following scenarios. So here are some of the examples, such as to predict whether a citizen is senior or not, or to check whether a person has a disease or not. I hope so guys, you would have got a fair idea what exactly is logistic regression. Now let's move on and discuss our next question. So our final question is how to handle missing values in a dataset. So if I correctly answer this question, in Python pandas, there are two possible methods to locate the lost or corrupted data and discard those values. The first function is null. It can be used for detecting the missing values. The second one is dropNull, where it can be used for removing a column or row with null values. And there is also another which is called fillNull, which can be used to fill all the void values with the placeholder values. I hope so guys, you would have got a fair idea regarding how to handle the missing values in a dataset. Thank you guys for watching this video. That was all for today's session. I hope so you would have enjoyed our today's video on machine learning interview questions.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Just a quick info guys, Intellipaat offers executive post-graduation certification program in data science and machine learning in collaboration with IHUB Divya Samparka, IIT Roorkee and Intellipaat. Through this course, you will learn a multitude of tools used in the industry such as SQL, Python, machine learning, deep learning, artificial intelligence and computer vision from the esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take the first steps towards a career growth in the field of data science and machine learning.